since ancient time, and we usually say that how he had been tortured and he suffered for his scientific temperament because of the reign of the ignorant people. But here we didn't have any. If you go that we accepted that Earth is one of the planet and Sun is the prime source of all energy, and we have tried to concentrate everything towards the Sun in our knowledge system. We have done it actually. So today we need to say, because that many of you know it, again I like to mention, because nowadays it is being told repeatedly and it is needed to be told repeatedly, because that we do not understand even in spite of knowing the facts and figures. So you have to assimilate and you have to believe it, and you have to act on the basis of your actual knowledge, whatever you are gaining. So Britishers, they didn't get full control over India. So it took actually after Sipai Mutiny, they got the full control over India, but they were in process of getting the grip over the India. So we know that Macaulay in 1835, when he was asked to see how the Britishers can have full utilization of the resources and exploitation fully at its extent for their benefit, then he thought of the culture is very, very strong in India. Unless you demolish this cultural system, that you cannot actually change this mindset of the Indian people. So you will be ruling, but you will not be able to exploit them fully. So you know, and Satparji will be telling many things to you, but think that he attacked the Indian education system, through which he not only tried to propagate or teach or inculcate, but simultaneously it was a process through the rulers how to demolish the existing knowledge systems and practices. It was there. Many a times you are doing research, I am also doing research. It is not that my research will be established through my hard work and my intelligence we are putting in it. But if you simultaneously do it, okay, if that person is my competitors, every time not only I have to concentrate on my work, but I have also to concentrate simultaneously to demolish and destroy the works that they are doing. It is not fair. In every society, civilization, these sorts of attitude never can be accepted. But this was the practice that Macaulay did it, that once he tried to give the preachings of the education systems of the Britishers, and a very, very proactive processes was there to change the mindset, demolishing the existing teaching learning processes which was there very strong in the country. And therefore we know nowadays that whenever we try to refer something, that if you are referring some Western philosopher or Western scientist, then we take these persons that is a very, very well versed in the knowledge system. If you start your lecture with the quotations of Aristotle, then okay, so the person is really, see, the working in science and giving the quotations of Aristotle, Kant, and so many persons. But if you say and start your lecture with Chanakya, then the person will say this is a traditional, conservative, and a kind of mindset that they are trying to pull back the civilizations from its onward march. This is the mindset. Chanakya was the successful person to inculcate, and he defeated Alexander actually. And Alexander's guru was Aristotle. But we celebrate Aristotle as a great philosopher, and I am very sorry to say that this was our problem through which we have been taught. I am telling actually that at this stage we see that these gaps are there even within us, and we need to know, and each and every lessons of what Chanakya had given, not only in the scientific temperament, in every aspect, in the diplomacy, in the governance, it cannot be imagined. So all the diplomatic relations, many a times our foreign minister Jaishankar says that Mahabharata, even Chanakya, these are the guiding things what from we usually draw a lot of things for the deciding our policies and relationships with so many troubling neighbors. So we have those things. And see, the Britishers had come after 1858. The Macaulay, it got its total grip in our education system. And if you think 1858 to 1947, how many years? It's hardly less than 100 years. And within the 100 years, we have changed totally our mindset, and today itself we have not been able to come out from our colonial mindset. It's a very sorry state. And therefore, when the national education policy is saying that we need to say that we have the Indian knowledge systems in every aspect. So scientifically, as he was telling, Charok, Susruta, Bodhayon, Arjyavarta, and so many names are there, we know it. And nowadays so many that Indian knowledge systems that in the patent raj, somehow we see that Neem had been patented by those persons, the Holdi has been patented by those persons, and we are afraid and we usually go in the court of arbitration wherever it is there to get the justice of it. And see that when we think of that in this patent raj, there is no dilemma that the zero and decimals have come out from our ancient Rishi Muni, the Aryavarta. So you try to express the numerics with Roman system, the Roman, so great civilizations of the world, you try to do it and try to solve so many computational problems nowadays we do in the digital world. It's impossible. If it is so, recognize that these knowledge systems we are subscribing from the Indian knowledge system and try to give the share of the fractions of share of the patent whatever you are doing today. You will be wretched actually if you try to give the share of the even 1% fractions of the patent because of the utility you are getting from the decimal systems and the zero systems. This cannot be imagined. But basic thing is that, as I told it in the beginning, that we have the knowledge system in such a way that always try to propagate it for the onward march of the civilizations of the human society. Never it was that you put such a system which is very, very restrictive and only I will develop, but our neighbors or the world which is adjacent to us, that will be remain in the dark. That is, the sustainability we talk about today in each and every aspects, whatever the Rig Veda, the hymns, I am very poor in pronouncing Sanskrit, so I will not try to do it here, ridiculing myself. But if you see it, so many hymns always say that we will go together, we will talk together, we will think together, we will move along with each and every persons together. Sangachata. So Rig Veda hymns which 5,000 years ago, and today we are telling, so Vasudhaiva Kutumbakam, and that peace, it should be for everybody. That today this comes from our knowledge systems, and after so many traveling and facing so much of disturbances, insecurities, and rift with civil war, now they talk about the democracy, peace, and the global human right, and so many things. We need not to be taught for that. We are basically for that, we are the preachers of that, and we want that the whole world is our family, and as of the members of the family, we like that everybody should grow and have the benefit of each and every knowledge system. That is the basic things that each and every young mind should know, that we had a huge treasure of the scientific researches which have been planfully kept out from the minds of the young people, and a kind of subjugated, dependent, colonial mindset that you cannot go with the developed nations, as many a times it needed to be told that Viksit Bharat, you need total transformation in the mindset. You will excel. Our scientists are excelling. They are actually getting control the big managerial aspects, Google, and so many. I need not to actually. So even in US, in NASA, that our scientists are contributing a lot. But thing is that you need to celebrate and appreciate the Indian knowledge systems, and we are for the humanism, but we should come out from the colonial mindset. We are contributing for the world, for the peace and its civilizations, and therefore the each and every aspects of the Indian knowledge system should be in the tips of the young minds, so that whenever they get exposure with the Western knowledge system, they can get a kind of assimilations that what Indian knowledge systems had contributed and made a base towards the advancement of the Western knowledge system, and recognize that yes, we have a huge traditions, and you can get a very good footing for moving onward. Thank you so much. Thank you. I do not know, I took a little bit more time, but it is for the young people. You need to cherish and be confident and proud of our knowledge systems. Thank you.
Thank you, sir, for the inspiring talk. Finally, we are honored to have with us Dr. Satyapal Singh Ji. He is the Honorable Chancellor of Gurukul Kamri University, Haridwar, and a former Member of Parliament from Bagpat, Uttar Pradesh twice. Dr. Singh holds a postgraduate degree in chemistry, an MPhil in chemistry, and PhD from Nagpur University. He has also served as the Union Minister of State for Education, Ministry of Water Resources, River Development and Ganga Rejuvenation in Government of India. He is a retired IPS officer of Maharashtra Cadre 1918 batch and has served as the Police Commissioner of Mumbai, Pune and Nagpur. Dr. Singh is a distinguished recipient of the Special Services Medal for his exceptional work.
I have to leave. Professor Dipendra Das ji, Professor Kashyap Dubey ji, Professor Vijay Kumar ji, Dr. Vinod Kumar ji, Dr. Ravindra Kumar ji, all the distinguished faculty members, research scholars and students. It is my privilege to speak from the portals of GNU. especially on this Indian knowledge system. This is, I think, fourth or fifth time I have come to JNU, and perhaps it is the first time I will be speaking on this Indian knowledge system. On 9th, about few days back, I was in Gujarat University and speaking on the same topic and addressing the All India Conference of English Teachers. From tomorrow and day after, there will be World Conference again in Gujarat, which is focused on this Indian knowledge system, and I will be one of the speakers there. Though, in the academic terms, as we were discussing while taking tea, perhaps I am the least eligible and educated person to speak on it. In the midst of so many luminaries sitting on the dais and off the dais. But I have been a student of this Indian knowledge system. I am one of the architects of this new education policy. And I take the pride that the Indian knowledge system was incorporated because of my existence. What is this Indian knowledge system? There is a lot of confusion about it. Before I speak, I must congratulate Dr. Ravindra Kumar ji, Manoj ji for writing this book, Integrated Waste Management. I must congratulate you and your colleagues. Kanksha Gupta is also there. Now, Professor Dipendra Das was also telling, sometimes I hear from the professors of the universities, it's because of neglect. We consider ourselves as inferior. What did we do after we got independence? The universities like JNU, I must say that they were in the forefront of denigrating the same kind of knowledge system. There have been many professors like this. I must blame them more than the government. In 1966, Professor Kothari, he happened to be the chairperson of this UGC and the first education commission. And he mentioned emphatically that the center of gravity of Indian intellectuals is tilted towards west. And we must correct it. I think perhaps Professor Kashyap was telling, or Vijay Kumar ji, unless somebody from the West, somebody from America and Europe, you quote, you get approval, you are not confident. We don't believe our own legends. Our rishis were scientists. They were scientists. Even the modern scientists, if you go into the depth, in fact, about a year back, I wrote a letter to my Prime Minister, and I would like to tell especially the researchers. Even today in India, we have around 10,000 manuscripts or books available on Silp-Shastra, different aspects of scientific knowledge. I would like to quote Bhrigu Samhita. Bhrigu Samhita talks about 10 Silp-Shastra, 32 Silp-Vidya, and 64 this different kind of different. I should say this, whether you call it handicraft or the different kind of things. Now, Professor Dipendra Das was telling we have 5,000 years of tradition. No, I don't agree with that. I'm sorry to say, I don't agree. Why I don't agree? You go to Hardwar, you go to Banaras, you go to Mathura and Vrindavan, and many of you might have gone. done a sankalp from a Brahman. In our religious functions, ceremonies at home, the Pandit, they chant a mantra. We call it Sankalpa mantra. Adhaya Brahmane Ditya Prardhe Svait Varaha Kalpe Pasta Svait Saptamehe Manmantre Ashta Vinsiti Tame Kali Yuge Pratham Charne. Every day we have been counting. Every day. Every day have been counting since the advent of man on this earth. And what is this calculation? You go and check today. Every day they have been adding to this. It is around 2 billion years old. Around 2 billion. 1 billion, 96 crore years before the man came on earth. But, as Professor Dipendra Das was telling, we were influenced by the Macaulay, we were influenced by the biblical gospels. And Bible says, if you read the Bible, especially Old Testament, especially our young researchers, they must learn this thing. Bible says this world was created in 4006 BC. What is the date I told you? 4006 BC. It means how many years before? 6030. Just 6030 years before. Nobody is going to accept it. Neither the West nor the East. No scientist would agree to it. That the world was created in 4006 BC. That was the influence all over the world on the intellectuals. And that is why he was telling about the Galileo, when Galileo mentioned that. No, it is not the earth, it is the sun. It is earth. And what Bible said? No, it is the sun. It goes around the earth. Was it? I would like to quote 3 books, important books. Sometimes I feel that I also, and Professor Dipendra Das says, you must give me some job of a visiting professor to GNU. 3 books especially I will quote. One book was written in 1852. 1852, before 1857. Name of the book is India in Greece. India in Greece. He is a Greek philosopher, historian and philosopher. 1852 he wrote, and he mentions everything, whatever Greece learned, practice. It is all because of India. We all learn from India. 1852. Will Durant, the world famous historian, American historian, Will Durant, we all teach that. Will Durant says, India is mother of all the sciences. India is the mother of all the sciences, whether it is mathematics, whether it is astronomy, everything. India is mother of our philosophy. India is the mother of the democracy. India is the mother of our administration. India is the mother of the entire world. It's Will Durant, American. Why I am talking it? Because the modern professors, they think, no, we should think about what Westerns are telling. That is why I am quoting it. Now, recently, yesterday only somebody gave me a book. Yesterday only. A new book has come. The Golden Rose. Go on the internet. William Darlyle Mill. I'm told he is staying somewhere here near GNU for the last many years. And he mentions from 250 BC to 1280. He has quoted thousands of documents in his bibliography he has given, thousands. And he has documented the India was ruling the world in science and technology, in trade and commerce and But today we are discussing about nanotechnology. There is not much time left. I will just give some examples. You were talking about iron, this iron pillar of Delhi. There are two iron pillars also in India. One is at the heart in Madhya Pradesh. There is a mosque there, and this is called Lat Masjid. Lat Masjid. Lat Masjid. समझ गया? Lat pillar. Lat Masjid. Three pillars are situable. One pillar has vanished. Second is in Karnataka. There is a Kollur district. Kollur. And there is one temple, old temple. Murg Ambika temple. Adi Murg Ambika temple. The pillar is around, the iron pillar is around 8.7 meter high. The rustless pillar. You are talking about the Basam and all these things in Ayurveda. I would also quote one example, and please go through it. Our problem is, we have the book, we have the manuscript, nobody is there to interpret. I don't see anybody. I would like this quote one. I don't know how many of you have heard or read. Even on Indian knowledge system, unfortunately, we don't go deep into our own system. Have you heard the name of Raja Bhoj? Raja Bhoj. About 1,000 years back. Some people, modern historians, they say that 1,000 years back, in fact, exactly 1,055 years before he at AD, he died. Somebody say 1,052, 1,055, whatever it is, but around 1,000 years old. He wrote two beautiful books. You must quote, you must teach in to your students. What is the book? One is Sambrangan Sutradhar. Sambrangan Sutradhar. Second is Yukti Kalpaturu. Yukti Kalpaturu. And he mentions about the iron technology. Iron technology. Dr. Subramaniam, he has written extensively on the metallurgy, on the iron metallurgy in India. If you go through it, Raja Bhoj also talks about a chariot or a rath or a plane which can fly in the air, which can run on the earth, and which can swim or float on the water. Raja Bhoj, I'm talking about Raja Bhoj. I'm talking about Yantra Sarvas, Maharshi Bhardwaj. One chapter is available, we call it Ramanic Shastras, Brihat Mimamsas. The man who first interpreted or translated this book, I happened to meet him in 1976. I met in 1976. He was staying in Haridwar. Swami Brahmamuni Privrajak. रविंदर जी ने शायद नाम सुना हो, मिले तो नहीं होंगे, बहुत पुरानी बात होगी. He was very old when I met him. In 1976 I met him, and I asked him, how could you translate that book? In 1956 he translated the book. Government of India asked him to translate the book when Pandit Jawaharlal Nehru was the Prime Minister of this country. So I don't want to go into details, but it's very difficult. That is why I wrote to the Prime Minister. Nobody, unfortunately nobody, I see in India or abroad who can understand this text on science. For example, Shaktan Rishi, it will be of interest to you. Shaktan Rishi, he wrote a book on Lohu Tantra. Even the entire world, nobody has done work on that. And Shaktan speaks about 3,015 different kind of alloys, metals. 3,015. We don't understand it. I happened about few years back, I happened to meet one Dr. Rao. Dr. Rao, sorry. He was working in the government of India, in Hyderabad. He was working in the computer center. I'm forgetting this very famous institute of government of India. CDEC. He was working, he was scientist there. Perhaps I missed his number, but anybody who happened to come from Hyderabad, please find out about Dr. Rao, who was working CDEC. About few years back, he was speaking in a function, and I was also present there. One demonstration he did. What was the demonstration? On the basis of this Viman Shastra, he created one solvent. I think probably Vijay Kumar was telling about this camouflage, na? He was telling about this. He took this newspapers. Newspapers can easily catch the fire. He sprinkled this solvent on the papers, and it didn't catch fire. It didn't catch fire. Newspaper did not catch fire. He was telling that our old astronauts, I don't know how many of you I have read it during my college days, Eric von Däniken. Most of the fellows, they tell, no, he is a pseudoscientist. Eric von Däniken, anybody have heard the name? He is an 89 years old man. He has wrote very famous book, Chariots of the Gold, Gold of the Gods, according to evidence. And he claims around 20 to 25,000 years before, we are much more highly technological society. People were having such aeroplanes or satellites visiting different planets. He talks about it. There's so much of things are available. So I requested the Prime Minister, please constitute teams. Constitute 4 or 5 teams at least. One team should have modern scientist, nanotechnologist, metallurgist, who knows Sanskrit grammar, literature. So 4 or 5 persons, they must be constituted in a team who can interpret these texts. I don't know whether you have gone to, I would like to recommend even our young researchers, please, if you happen to go to the south, please visit Tanjore temple, Raja temple. That library there is called Saraswati Mahal Library. I have gone there. Saraswati Mahal Library. It has around more than 1 lakh Sanskrit texts. More than 1 lakh Sanskrit texts. If you happen to go to Mysore University, I had gone last year. I had interest for this kind of thing. It has Oriental Research Library. Oriental Research, it has 55,000 Sanskrit texts for different subjects. Unfortunately, we do not have the persons who can interpret them. If really we are sure we want to do something about the Indian holy system. I can tell you one more thing. Today's professors can be mercenaries. They can have the sponsored research. We have the scientists also like this. Our forefathers, our rishis. वो कोई मजाक में भी झूठ नहीं बोलते थे. लिखने की बात तो छोड़ दीजिए. मजाक में भी झूठ नहीं बोलते थे. लिखने के सवाल तो बात छोड़ दीजिए. If they have written about it, I would just quote one example because I have some meeting. I'm sorry. Dipendra Das has taken so much of time. In 1973, one American professor, lady professor, you can note down the name Ruth Raina. She had gone on sabbatical leave to Punjab University, Chandigarh. She was a Sanskrit professor. Some of our researchers, we call researcher, whatever we call it, Lhasa, you know Lhasa? Where is Lhasa? जेएनयू के लोगों को बताना चाहिए ना, स्टूडेंट्स को। इतने जोरे से बोलते हो और पढ़ते पढ़ते नहीं, कम पढ़ते हो। लाशा तिब्बत की राजधानी है। लाशा में कुछ पेज मिले, जो पेजेस थे देवर इन संस्कृत। हु विल इंटरप्रेट? चाइनीज लोगों ने, क्योंकि उस समय तक वहां पर कब्जा हो चुका था चाइनीज का, वो पता किया कि कौन इसको इंटरप्रेट करेगा, तो ये देवर सेंट टू द पंजाब यूनिवर्सिटी। रूथ रैना के पास आए। रूथ रैना ने उसको ट्रांसलेट किया। वन कॉपी वॉज सेंट टू चाइनीज ऑथोरिटीज, वन कॉपी वॉज सेंट टू आवर इंडियन इंस्टीट्यूट ऑफ साइंस बेंगलोर। 10 साल के बाद इंडियन इंस्टीट्यूट ऑफ साइंस ने बोला नहीं, इसमें कुछ दम नहीं है। मेरी बात समझे? On the basis of those papers, Chinese created the interstellar these satellites, and Chinese claimed it. Chinese scientists claimed it. And this story came to us how? Nobody wrote it. One American professor, his name is David Childress. David Childress, he wrote a book, handbook of gravitation. Handbook of gravitation. He has quoted this story. There are so many things. I can tell you so many things. So I must congratulate JNU, Professor Dipendra ji, or your department, technology. You have taken a lead. I must congratulate JNU, Ravindra ji, वीरेंद्र, क्या नाम आपका, विनोद जी, गुरुकुल कांगड़ी यूनिवर्सिटी, गुरुकुल कांगड़ी has been famous for it. Gurukul Kangadi has been famous for it. Gurukul Kangadi was established because of this thing. But we have so much of solid knowledge, sound knowledge, in every aspect of life. That Swami Dayananda Saraswati, Swami Sradhananda Saraswati established this university on the ideals and on the teaching of Swami Dayananda Saraswati. Swami Dayananda, this Satyat Prakash you have presented today, its English translation is also available. It is available in 18 languages. The light of truth, it is mentions. We have so much of science, we have so much of technology available in India. Unfortunately, because of Macaulay wanted this kind of thing, to demolish our culture, to demolish our education system. You go through this Murray, this 1810 this survey, Dr. Rampal has written about this beautiful tree. You go through the book. How many institutions we had? We had around 96% literacy rate in 1810. 96% literacy rate in 1810. And in 1947 it came down to 18%. Just 18%. Because of the British policies. And if you go through what British has done, unfortunately sometimes it happened. I was in this conference I am mentioning on 9th. One of the professors, I would not tell his name to you. He was speaking in the conference, unfortunately because he spoke after me, so I could not clarify the matter. He spoke after me. He was mentioning, no, these Britishers, they united us. They gave so much knowledge to us. Because he had not read the book, was Will Durant has written. Please go through this book also. This book was banned by the British. The Case for India. The Case for India. Will Durant. You are far ahead in science, in technology, in literature, in yoga and all these, in Ayurveda, forget about it. We have so much to learn from our Indian system. So much to learn. So I must congratulate JNU. If JNU take the lead, the Indian university will follow. I think with these words, क्योंकि मुझे थोड़ा जल्दी है आज, तो thank you very much giving me this time and inviting me for this conference. And I am very sure that our research scholars and our professors they will have faith in their forefathers. Have faith and confidence in your own forefathers, in your own system. Go back to the roots. Go back to the foundation of knowledge. Foundation of knowledge, seeds of the knowledge. Our forefathers, they are given the roots of the knowledge. Thank you very much, and I am very sure this conference will certainly enrich you more. Thank you.
Thank you, sir. With this, we come to the end of the opening ceremony. We now invite all the dignitaries, faculty members, students, and all participants to proceed for the high tea, which has been arranged outside the convention center. We kindly request all guesting participants to return to this hall by 11:40 for the first technical session of today's event, which will be chaired by Professor Manoj Khanna, Professor Satyendra Singh, Dr. Pratima Solanki, and Dr. Tulika Prasad. Thank you all dignitaries.
कुछ बच्चे पीछे आ सकते हैं। स्टेज सही है तुम्हारे स्टेज पे आप फटाफट आ जाइए। अब 15 मिनट बाद वापस आएंगे। कुछ बच्चे पीछे जा सकते हैं। क्लिक कर।
यस सर। और थोड़ा पीछे थोड़ा
हो गया क्या भाई?
नहीं
चलिए ये तो अच्छी बात है ना कि पहले मुलाकात हो जाती है।
थोड़ी भलाई कर दो उसका नाम पूरी भलाई कर
थोड़ी भलाई कर
ऐसी कर रहे हो क्या फायदा भाई?
लैपटॉप बंद कर दो मैं तुम्हें चार्ज।
यस बेटा एक मिनट थोड़ा थैंक यू वेरी मच सो नाइस थैंक्स अ लॉट थैंक यू गुड
बहुत गुड 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 गुड।
अनु इसी चीज का पॉलीक्लिनिक कहाँ है?
कौन?
पॉलीक्लिनिक नहीं है इसी चीज का।
हाँ है यहाँ पे मेरे को पता चलो।
अरे मौसा जी को लेके जाना ना वही है। बहन क्या है बताओ कहाँ है वो?
जेएनयू में क्या
गाजियाबाद में पूछ रहा हूँ। एक टाइम पे था जब हम लोगों ने बेसिकली मेरे वाले तुम रखो, मैं बैग मेरा काम है, मेरा बैग को मेरा जो बैग लेके आए थे ना, मेरा बैग और ये सारा रखो, मेरे को चाबी।
चलो सर, हो गया सर।
आप प्लीज चाय लीजिए, मेरा थोड़ा सा लेट हो गया तो अब मैंने बोल दिया, वो अभी बोलेंगे। लोगों ही कहा क्या कर रहा हूँ, लोगों बिल्कुल नहीं जाता है, जरूर सफेद और चलो जल्दी चलो, सबको मिला दो। हाँ लेट हो रहे हैं।
और जी मैडम कैसे हैं?
कैमरा अपने पास ही रख लो, उसी में रख दो कैमरा, दे दो मुझे, वो भी डाल दो मेरा, ये भी डाल दो उसी में डाल दो।
ये क्या है बुक दिखाना? ये इन्होंने विनोद जी ने एडिटिंग किया है इसका, सस्टेनेबल सारा वाटर है, सब कुछ किया है इसमें 20 चैप्टर्स हैं। सो आई थॉट अगर रहेगा तो पढ़ के कुछ खाली टाइम में बुक पढ़ना आजकल सभी भूल गए हैं।
वहाँ पे लाइव चल रहा है ना।
इसका बैग लेके आ रही हूँ। ये तुम लोग के बैग ये रहे।
Speakers to do something.
वहाँ पे सीट तो है हमारा।
We welcome all distinguished guests, faculty members, students and all participants back to the seminar. We believe that you've enjoyed the high tea and the pleasant warmth of the winter sun. We now formally commence the first technical session, chaired by Professor Manoj Khanna, Professor Satyendra Singh, Dr. Pratima Solanki and Dr. Tulika Prasad. It is our pleasure to introduce the chairpersons for this session.
Now, we would like to invite Professor Manoj Khanna, Professor Satyendra Singh, Dr. Pratima Solanki and Dr. Tulika Prasad on stage. Professor Manoj Khanna is a faculty member in the Department of Electronics, Science in the University of Delhi South Campus with expertise in microwaves, VLSI, communications, material science and sensors.
Professor Satyendra Singh, a faculty member at SCNS JNU, specializes in diverse areas including ferroelectrics, piezoelectrics, supercapacitors, energy storage, perovskites, antibacterial activities, functionalized nanostructures, and thin films.
Dr. Pratima Solanki, Assistant Professor, SCNS JNU, focuses her research on nanobiosensors and dye degradation. Dr. Pratima is actively engaged in the research and development of biosensors utilizing nanostructured materials for healthcare and environmental monitoring. She has received the prestigious Visitor Award in the year 2019 from the Honorable President of India. This session is honored to feature three distinguished speakers, Professor Rajan Patel, JMI, Professor Prashant Singh, ASRE Delhi, and Dr. Sandeep Kumar Singh, OP Jindal Global University. We now entrust the proceedings to the esteemed chairpersons.
Okay, thank you. Thank you very much. In the first our technical session, there is a three lecture, and first to be delivered by Professor Rajan Patel. So it's my pleasure to introduce Professor Rajan Patel. He is a director and he is a distinguished academician and researcher who obtained his PhD from the Department of Chemistry at Jamia Millia Islamia. He is currently served as a professor. His expertise lies in the protein stability and activities of diverse solvent systems, including ionic liquids and etc. And he has published many research articles and also some book chapters. So I request Professor Rajan, please start your presentation. Thank you.
Thank you, Pratima. First of all, I am thankful to all the organizers who called me to deliver a talk in this wonderful IKS traditional to modern technology conference seminar. And especially Dr. Vinod, who just asked me to deliver a talk. And I am not a man of IKS basically, but he just asked me to be somehow just maintain the conference scenario, and just I'm trying my best that because I am a physical chemist, then in Jamia I am a biochemist now, and I'm an interdisciplinary center basically. So where we have a pupil of biologist, chemist, physicist, computational scientist, and mathematician also. So my topic is exploring the synergy of chemistry and Vedic knowledge, enhancing antibacterial efficacy of melatonin using pyrrole-based ionic liquids. So I'm last around 12 to 13 years I'm working with ionic liquids, and one of my colleagues, Dr. Prasad, sitting over there, and I taken the first ion liquid from his lab basically. So from till today I'm just working with ion liquids, and there are a lot of questions occurring with ion liquids, whether it's toxic, non-toxic. So because I'm in center and where we have all the equipments and all the biological lab where I can do antifungal, anti-cancer, antibacterial activity, and also do the MTT assays and propose that the ion liquid we are using is non-toxic basically. So a lot of people in funding also called me, asked me about the toxicity. So I showed them this is less toxic, non-toxic. The concentrations I'm utilizing. So it's a green solvent basically. So the Vedic science. So the Vedas present a comprehensive understanding of the natural worlds, emphasize the elements and their interactions. So basically, Satyapalji just told us that. So it's an era of science, yes, of course. So the traditional chemistry, we forgot. So I'm thankful to the NEP 2020 and who implemented this system to our new education system currently basically, by which we can at least we have that type of events, conference, seminars, and we are also planning for the current for the IKS seminar, IKS also. So the ancient perspective aligns with the modern chemistry focus on atomic structure and chemical reaction, testing holistic approach studying matter and energy. So Ayurveda, basically Ayurveda and chemistry. So Ayurveda is ancient Indian medical science, we know that, and Ayurveda means Ayu, life, and Veda means knowledge. So we get lot of knowledge from our Vedas basically. So Earth Ved, Samved, Rig Ved, Yajurveds, there are a lot of science available in our Vedas basically. But we are not more focused earlier on these Vedas. But now it's an era, it's come now, we should be focused on these Vedas by which we can just get the excellent knowledge from there, science knowledge from there basically. So in Ayurveda, two factors are Indian medical science and medicinal herbs. So basically my focus on this Ayurveda is medicinal herbs and plants, basically the natural compounds. So I just try my best to be just relate this my talk to the herbs, basically this Ayurveda. So the chemical analysis of these natural substances reveals their active ingredients and potential therapeutic benefits, bridging the gap between traditional medicine and modern pharmacology, that is current science. So I'm just exploring my research toward the synergy basically. So exploring the synergy between chemistry and Vedic knowledge can lead to innovative solution in medicine. So the current talk is basically based on the synergy between the natural compound and the synthetic compound, which is green in nature. We proposed ionic liquid which is green in nature and maybe produce advanced therapeutic applications. So generally integrating Vedic knowledge into modern chemistry provides, already I just told you, and from last many years I am working with these ion liquids and I published a lot of papers on ion liquids and their applications toward as a in pharmacology. So they are my research. So for today's talk we just propose this melatonin basically. Melatonin is a peptide, it's a naturally occurring compound present in the venom of the honeybee basically. One can very easily extract it from there. So it's antimicrobial in nature. Its mechanism involves disrupting the bacterial cell membranes leading to cell lysis. By integrating melatonin with ionic liquids, we can potentially improve their antibacterial efficacy and broaden their therapeutic application against resistance. So what we are doing? Yes, of course, the individual impact already present of both of these things, ionic liquids as well as the melatonin. But what is synergy between these? Because it's an era, we know that resistance against AMR, antimicrobial resistance, because currently we are taking a lot of doses of antibiotics. So the problem is the resistance basically. I am coming out there. So before that, what are liquids? Very simple things basically are consisting of organic cation, organic inorganic anion,
Generally, they are pyrrole-based, imidazole-based, ammonium choline-based ionic liquids. I am focusing currently in pyrrole-based and also working with choline-based. They are both are very less toxic in nature, and they are amphiphilic in nature. Means they are surface active in nature. So, and they have larger temperatures, more viscous and solvent, and low vapor pressure. Also, there are some beautiful properties of these ionic liquids. They are easily tunable. We can make in our lab. These having a good antimicrobial activity and well proposed in literature, and non-flammable, liquid at room temperature. So basically, there are a lot of applications currently of ionic liquids. You can see, but my focus is through today talk is generally antimicrobial agent. So a lot of researchers in worldwide using ionic liquid as a purpose already that ionic liquid is a antimicrobial nature. That lot of literature available as an antifungal, antibacterial, anti-cancer already. So I already published a lot of paper on its activity as an antifungal and antibacterial. So anti-cancer I'm trying to do with our next research. So a lot of paper are available on this antimicrobial agents as an liquids. So the question, what is antibiotic resistance? Why we need this research basically? So it's a very serious problem for health now. Antibiotic resistance is the ability of bacteria to resist the effect of an antibiotic basis. It's a simple, you know all about these. So there are some factors that are responsible for antibiotic resistance, means overdose of antimicrobials. You know that in COVID era, what we performed already, we are taking a lot of doses. The impact is now occurring. So lack of current knowledge, poor sanitation, huge population and our crowding. So environmental factors. So a lot of factors which those responsible for the antibiotic resistance. The recent study I just take from the Times of India, 2 months back. So we can see what they write: antimicrobial resistance, which is caused when microbes evolve into drug resistance superbugs in response to the misuse of or overuse of antibiotics. So it may be the problem of this resistance basically. So it's a recent research, recent in article in the Times of India basically. So what is planning? We just have both the antibiotics and we just planning to study their synergy effect. So we can mix them and just check their synergistic effect of these ion and peptide conjugates as a antimicrobial agents. Lot of techniques we have utilized for this work. You can see, these techniques we use in this work basically. So we have synthesized this ion in our lab. This scheme simply. So R means we have different chain length over there, 4, 6, 8, and 10, 12. We have designs. So here you can see the 5 ion we have designed and synthesized and then characterize also. So only I am showing the C4 over here, not C6 because it's a long, maybe the this part of the talk. So you can see by NMR, by the FTR and mass spectroscopy, we have well characterized them because I already told you that the ionic liquid are surface active in nature. That is, it is amphiphilic molecules. It acts as a surfactant basically. So we also characterize using these CMC methods. That is critical mass concentration by using this surface tension methods. And then we have calculated various parameters. That is the thermodynamics of this ion using these surface tension methods. You can check. So why we calculate? Because we want to show that how much surface active are molecules. So this tau max means surface area and A minimum area per molecule. Both of these things give you the nature of how much the ionic liquid is surface active in nature. You can see that this tau max maximum means this C12 is more hydrophobic and this will be minimum, that it should be a 0.8. So this is that C12 is the more hydrophobic in nature. Further, we have calculated the delta G micellization and delta G adsorptions. Now why? Because you can see the delta G micellizations also here and delta G adsorption in negativity is more negative basically. It says that the ionic liquid 7C12 chain is more adsorptions property. So the negative value of delta G adsorption is that the spontaneity of absorption. Number 2, increasing delta G adsorption with increasing chain length, this increasing migration rate state of vial to the cell wall. So I compare this value with the antibacterial efficiency of ionic liquids. So it's no one knows about it, because one can also relate the antibacterial activity by this delta G value, the more absorption of the cell wall of that is the bacterial cell wall. So that's why we just measure these value and compare in my further slides. Also the CMC value we again compare with the iron flow methods. The value are same basically for all the liquids. As I told you that there is a problem with iron liquids. People say there's toxicity. So I am proposing RIL not toxic. It's a green in nature. How? You can see that the compound was subjected to the cell toxicity to HK cell line 93 using various concentration up to 10 micro equal to 160 micromolar. All the compounds show a good response in terms of all solubility as evident to the lowest concentration of all fives. Basically, the concentration we have utilized for antibacterial activity are very less in this range. However, this C10 and C12 showed some toxicity up to this concentration, but we never utilize this concentration in our work. So we just concentrate up to this 10 to 160, which are less toxic, and the results are here. So that's why we proposing that ILR green in nature. So MTTS results showed that the lesser toxicity of synthesized pyridine liquids as compared to the imidazole and pyridine. It was well proposed that imidazole and pyridine are more toxic. So here the pyrrole and also choline we are using are less toxic, and the concentration we are using are non-toxic from these results basically. Now you can see the antibacterial activity of the individuals, because I am proposing the synergy. So you can see that we just use two strains, E. coli and Azarosis. So C4, C6, so the MIC value. So as we increase the chain length, that is C4 to C12, you can see that the C12 has good MIC value compared to this C4, and also against Azarosis. Now melatonin, because melatonin also antibacterial nature, so it's very less in millimolar. Then this is a reference drug. So now you can see that individual effect. You can see there. This is the individual effect I'm saying. Okay. So further, we have gone through all the growth curve for all the ionic liquids with both the strains, and we mix them. So we make some conjugates, because actually the question is that why we not go for the covalent conjugate, because it is a melatonin, it is a peptide. So if we make some want to make some covalent bonding, the effect or melatonin may be destroyed. Okay, so we can't perform the covalent conjugate. So we just proposing a composite, or we can say the non-covalent conjugates. So we have performed all the growth curves with both the strains for all the ionic liquids, and we are proposing these things, the mixture in micromolar, you can see. In micromolar. So you can see over there, this 50, 1.2 and 1.3 against this E. coli Azarosis. The best combinations you can see further, this one. So C4, C6, C8, C8 and C12. You can see the combination 1.2 micromolar, 50 micromolar of this C4. However, in case of this lowest C12, 0.53 micromolar we have melatonin, the best combination, and 2 micromolar of ionic liquid, which is very less. If you see our last slide, remember, then where we saw the in millimolar. Here we are proposing in 2 micromolar of IL, which is very less toxic, non-toxic. So we can propose that it's the best combination, that is C12 is the most effective with both the strains. And it is a green system, green composite, melatonin and ionic liquids, which is non-toxic and green solvent. So these are our best combination against both the strains for all the ionic liquids with melatonin. We further performed the docking study, so, and by which we can just check the how melatonin bind with our ionic liquid basically. So again, you can see that the C12 is performing well, and it's bind very well with the melatonin peptides. So further work, the spectroscopic work for binding, we only propose with the C12. So these are my general spectroscopy work. We can calculate the binding constant by using this UV spectroscopy. If the main peak is around 280 nanometers, and we have this Benzi-Hilbert equations. We have just calculated the binding constant. It is around 1.18 10^5. Further, these values of binding constant we can compare. We compared already with the fluorescence study. So we have just this first spectra. This is the quenching of the fluorophore of the melatonin. As we increase the concentration of ion liquids, there is a decrease in the intensity of the fluorophore. So further, we can utilize these to make what type of quenching is there and binding constant to compare this earlier value. So you can see that it is almost the same order, the binding constant what we have in the UV study. So the case value further decrease with increasing, also the binding constant is decreasing. Means that if the binding constant decrease with the temperature, there should be a possibility of static quenching. That means the system is exothermic in nature. You can see the value of delta S should be negative if we have that type of trend. So we also consider the quenching and the binding constant means the binding constant. So it is around the same as we have in the UV spectroscopy. And these are simple. What type of force is involved in the interaction? One can very easily use the thermodynamics also. As a physics chemist, I always use these techniques in my study. So you can see very easily that what type of van der Waals interactions, hydrophobic interactions, hydro bonding interaction should be in the system. So as you can see that value of delta S negative, so it should be hydro bonding and van der Waals force of interaction. And in molecular docking, if delta H negative, we can propose there is a possibility of hydrogen bonding in the binding system. It's very easy to can define if you know the knowledge of these things. Further, we have also performed the CD spectroscopy. Is there an impact when we just proposing that our composite or our conjugates is highly efficient? So how maybe it affects the structure of melatonin? You can see that in the CD spectra, the molar electricity is not, it is the main MRE of this melatonin is with our ionic liquids. So in all the cases, compactness increasing as MRE value decreasing, not increasing. So more compactness after adding the ionic liquids in melatonin. So it's so that the compounds are good in nature, basically. So we have also it is evident from this that on addition of ion, so we have just shown that the stability is increases, not decreases. So we have also shown the value of R. The spectra were further analyzed to back into the ratio of the molar electricity at both the nanometers. The value are depict that ionic liquids with varied chain length have no significant influence on the secondary structure. On the behalf of this R value, we further explain that there is no impact of ion liquids on the melatonin structure. You can see the R value almost same. When we proposing any composite or any drugs or any compounds, whether it is a pharmaceutical important or not, this study very important. So hemocompatibility is a very good study to show whether your composite or drugs is pharmaceutical importance. So you can see we have shown the spectra of our HSA first, human serum albumin, and check the impact of these ionic liquids with melatonin on the HSA. So you can see there is not much change in the CD, also not much change over there. In CD you can see that this is the HSA, this one, and when we adding our composite, then again the R value says that it's the same results. You can see that the value is MR values decreases, means somehow below this the original value, means it is safe. The composite is safe in nature. How? Because you can say that the structure of HSC is safe and more compact. Our composite, the concentration we are proposing in our results are safe to use as a pharmaceutical. So this we were published in Omega because we are hurried, so we want to already patent it, this work. And now the same study we have performed with this BR. Basically, they are reviewer asked me many times you have done a lot of work. However, what is the impact of the different anion? Where we have N2F2 anion, here Br anion. So no one proposed really show the impact of anion. So one reviewer asked me to also show the impact of the compare the impact of the anion also. The chain is same, but the anion is different, Br. So we perform all the techniques, all the study with Br also. So you can see all the results with Br also. We are not showing these results. Just we performed all the techniques, antibacterial activity with Br anion also. So and these things. So I'm coming to this conclusion because we don't have time. So already late. So you can see that our best composite 0.53 micromolar of melatonin and 2 micromolar of our ion liquids against E. coli, and against S. aureus there is a concentration. However, with Br anion, you can say that there is a small change in the values. You can just see there, but the concentration is slightly high with Br anion. So here is 0.52, but with NATF2 and with Br, you can see 2 micromolar over 10 micromolar. A small change, but less toxic because the concentration is very less. We are saying 10 to in MTTSA 10 to 160 micromolar are non-toxic, and what proposing only 2 micromolar and 10 micromolar. So this is highly biocompatible and pharmaceutical importance composite. So there are our results, that MTTSA results of both series of ion liquids showed that the synthesized ion liquids are less toxic than that of the, it was already proposed. And hemocompatibility of these composite was determined, which show that the structure of HSA remained unchanged, which implies that the complex as well as individual ions at low concentration are hemocompatible, means pharmaceutical importance. Further, this docking study showed that the interaction plays a major role. We already proposed the hydrogen bonding and the van der Waals forces, and our all these are thus easily can prove to be useful in overcoming antimicrobial resistance. So one thing I would like to, these papers are published again, I just say, so both the papers are being published because there are a lot of data. We published 2 papers basically, only published, and small 2 slides I would like to show. So currently what we are doing that, because it's a seminar on IKS. So I am Ayurvedic terms, we are using herbs also. So during COVID period, we have published some paper on some herbs, their impact on the avidic M protease already. So currently, these are the simple theoretical docking and simulation and DFT studies we have published. These one, you can see that. So we have taken lot of herbs, using this salimarin, curcumin, amoxicillin, and others also. And also compare with these the current available drugs like acyclovir and other drugs. Those are currently we are taking during the COVID period. And ionic liquids, already proposed people, they are anti-viral in nature. So you can see that the best compound is uridine. So we are proposing these compounds. So by this, because time is very less, this was already published, and currently I am working with the synthetic route of this. I am making some coupled with the herbs and ionic liquids. The work is going on in my lab, and these are my labs basically. Sometime please visit to my lab. The girls, Juhi, did very well for all these works. Now she is teacher PDF in my lab also, and I am thankful to the SERB who continuously supporting me from last 15 years. And DHR also, and our CIF in Jamia Islamia. So by these words, I am thankful to the organizer again, Dr. Vinod, all the team you have, Dr. Vijay. So all you all, I am highly thankful, madam. So thank you. If you have any small question, please ask to me.
showed that you are actually integrating some naturally occurring herbs in the form of your studies to see their usability in drugs. So how do you prepare these things so that they are not harmful to the body?
Yes. Actually, I already told you that I'm not going to make some direct conjugates. This is a composite system. It's take long time basically. So we have make large concentration range and different composites. So we have checked a lot. First, we confirmed from the computational study which one is best. Like in this case, this one is very best against inhibit the M protease basically. It's a leading herbs basically. It's a from carrot. We can extract it. So some people we have in our center, though are working with herbs, we can extract very easily from carrot. So we are not going to make some conjugate. We are just directly using it. So we are make some conjugates and non-conjugates with different concentration range. Then we plan. Then we go for MDTSA further. So simply we are using this. So no direct formulation, no need for it. Direct composite.
Thank you very much.
Thank you, ma'am.
Thank you,
so much.
sir, for a very enlightening talk.
Yeah,
and
thanks.
first time I have seen the IL liquid is also has a good property. So can you which one is the more having the more efficiency to showing the antibacterial properties?
Yes, ma'am. From last 2-3 from during COVID before COVID, I think 2019 we started the work on like this work because we have some fund from SERB on this topic. So basically, first is that like I lot of paper on imidazolone and pyrrole. Currently, I am using with choline liquids. It's less toxic. So first, because in funding agency, they first ask immediately it is toxic, and I am non-toxic because I showed the results non-toxic. The concentration I am using non-toxic. So first, my work is that whether it's toxic or non-toxic. Then we choose from last 5 to 6 years that currently pyrrole and choline-based liquid are less toxic. So we choose like this.
Thank you very much, sir.
Thank you, ma'am.
Next speaker,
Thank
Dr.
you,
Ayurveda.
Professor Rajan. The next talk is by Professor Prashant Singh, chaired by Professor Satyendra Singh. Before we start the talk, we have to contribute to the mementos. We now request Dr. Pratima Solanki to present a memento to Professor Rajan Singh.
Prashant Singh. Let me briefly introduce Professor Prashant. It's a great honor for me to introduce our next speaker. Dr. Prashant, he is working as a professor in Department of Chemistry, Atmaram Sanatan College, University of Delhi. He received his PhD degree from Dr. B.R. Ambedkar Center for Biomedical Research, University of Delhi. He is the recipient of Postdoctoral Research Award from UGC in 2012. He has also received an offer letter for the postdoctoral fellowship from Northwest University, South Africa. He has completed several research projects from various funding agencies of the India. Well, his 4 students have already completed his PhD under his supervision, and 6 students they are currently working for their PhD. He has published more than 190 research articles, review articles, book chapters in various national, international journals and books. And total citations to his work is nearly 4,000. His H index is 33 and I-10 index is 110. His research interests are DFT calculations, molecular dynamics, simulation, and electrochemical studies to understand the behavior of small molecules with macromolecules. So over to you, Professor Prashant. You have around 15 minutes, 20 minutes for the presentation, and then we will take few questions. So, welcome.
Good afternoon, everyone. I hope my voice is audible to all of you. So first of all, I will congratulate the organizing committee for a wonderful inauguration of one-day seminar on Indian knowledge system, traditional to modern nanotechnology. I'm thankful to Dr. Vinod for inviting me to with you, and I hope my talk will generate a spark in the UG, PG students and the research scholars. Actually, this presentation is mainly for the youth, and we need to work, we need to understand the molecular interactions through computational tools. First of all, I would like to introduce about my institute. I am working at Atmaram Sanatan Dharm College, which is one of the prestigious institute or college of Delhi University. It has a score of 3.77 from NAC and secured 5th rank by NIRF. The title of my presentation is Theoretical Insights for the Sensing Ability of Graphene Oxide for Pesticides and Metallines. The contents of presentation is the role of computational tools, functionalization of graphene and their ability to sense small molecules or chemical entities, and the conclusion. As I'm talking about graphene oxide and try to correlate how it is connected with our ancient time. So here we can see that we have CNT and graphene, which we are using since long. But the claim by the Western is that these materials are discovered few decades back. But it is not so. Recently, a research article is published in scientific reports that the inner coating of pores is of CNT. You can see the reference scientific report. It was published in 2020, and still you can see its stability. Even after 2500 years, we can see the coating is as such. Further, CNT is also used to enhance the properties of blades. Here you can see the strength, toughness, and other properties can be enhanced. In the literature, in the modern science, we study about graphene. Here you can see that a scientist mentioned graphene and CNTs are discovered after 1990s. Graphene was discovered even before the existence of human. So in this connection, I would like to discuss how these carbon-based materials, especially graphene oxide, is useful to us, especially in sensing of pesticides and metallines. Everyone is talking about organic food. None of us want to consume pesticides. Nowadays, in agriculture, we have seen people are using different pesticides in huge amount and creating toxicity. Here, I will emphasize on chromium. All of us must be aware of leather industries in Agra. And we have seen they are using chromium in excessive amount. And directly or indirectly it affects us, that is human and other living organisms. So we need to think what type of material can sense them. Next please. Yeah. So these small chemical entities can enter in human through dermal, through skin, as well as through inhalation. And they target the vital organs in the human and the living species and cause toxicity. So we should avoid the uses of pesticides, but if pesticide or metallines are available, we need to find in what concentration they are available. My presentation will focus on for UG and PG students, as the students could be from different disciplines, physics, chemistry, biology, as the head or the chairperson of this center is from electronics. So there is need to understand how computational tools can be useful in understanding or in sensing of small molecules or chemical entities. Next please. From different computational tools, we can find various structures of the small molecules, their stability, their reactivity, their physical and chemical properties. And there are many tools, or you can say softwares, like GAMES, Gaussian, Material Studio, and many more. I'm sure that some of you have used the tools in your UG, PG, or might be using in the PhD. I'm focused on exploring the Material Studio and Gaussian. Next please. Usually, we have a perception the computational calculations are correct, or we are far away from the experimental results. We need to understand. We will first talk about Gaussian, when it was or when it came into existence. Next. It came in existence about 50 years back, or 55 years back. You can see that the first version of Gaussian came in 1970. So we can understand that that time this computation tool has some demerits or limitations. But with passage of time, the company came up with new versions of Gaussian, and next please, we came up with Gaussian 16. Still it has some challenges or some limitations, but with passage of time we are moving towards the accuracy, because with time we have mature algorithms. The computational scientists, there must be some student or scholars from computational science, so they have developed better algorithms and machines we have, because for running big calculations we should have good machines to complete the calculations, or the command should be terminated normally. So we will discuss the role of Gaussian and Material Studio in understanding the functionalization of graphene and their ability in sensing of small molecules. Next please. But the question is, why we need to functionalize graphene? Because it has certain limitations. So to overcome the limitation, Hummer's method came into existence to prepare functionalized graphene or graphene oxide. So we have some better applications, definitely, due to better properties, as it has some functional group like COH, epoxide, and OH. Due to this functionality, the adsorption ability can be enhanced. Next. Few years back, 2 to 3 years back, we wrote a review article and which published in ACS Omega. We discussed the different properties and ability of graphene oxide, but still it has some toxicity on some living species. The most important thing matters how toxic it is, but I'm not going to discuss that part because today I'm here to discuss the computational tools roles here. Next please. So this is the structure of graphene. We have taken a small sheet of the graphene, and what functional group we can have, as I have told you, we can have COH, epoxide and OH in it. We have varied the functional group 100, 111, 011, means the functional groups have been varied. What is our interest? Our interest is to get the functionalized graphene which has the maximum dipole moment. And out of this, when we perform the calculation using Gaussian 16, we reach to a conclusion that 322 means when the sheet has 3 COH group, 2 OH and 2 epoxide, we can have the maximum dipole moment which is of our interest. From this, you can also see that as the graphene is made up of only carbon and hydrogen, so that dipole moment is almost negligible. That you can see 0.00023 dBi, while in the case of graphene oxide, the dipole moment is much higher, that is 30.31 dBi. Further, the stability of graphene and functionalized graphene has been explored through MD simulations, which was performed by GROMAX, and herein we have determined different trajectories. The one of the trajectory is RMSD, and in the literature it is mentioned that if the RMSD value, or you can say deviation from the mean value, is less than 3, or 0.3 nanometer, then it is widely accepted. And here you can see the value is in acceptable range. Similarly, we can also see RMSF and others which are in acceptable range. So this paper was published in ACS Omega by one of my students, Mr. Madhu. Please move to next. Now we need to understand, can we explore graphene oxide in sensing of a pesticide, that is pymetrozine, which is widely used in India. We need to understand how it can be done. Here we have taken a smaller sheet of graphene oxide and tried to understand or investigate its ability to absorb the pesticide. Next please. Here you can see the structure of pymetrozine, graphene and graphene oxide. We have taken the three molecule, 3 chemical entities. Next. Because as I have told you, if you want to run the calculation, suppose if you want to run the calculation for graphene 10 by 10 or 15 by 15, or for graphene oxide, we should have a very good machine. Machine plays an important role. Sometimes we say, "Arey bhai, results to bahut dur hain." From the experimental results, we are far away. So we need to understand we should have a bigger sheet. So if you have a good machine, only then you can go for the calculations. So herein, what different we did from the other researchers. The students can think in this way. In most of the research articles, they have studied the molecular interaction of carbon-based material. Herein I have taken GO with pesticide in 1:1 ratio. But instead of taking 1:1, we have explored it for 1:2. So in this, what we have observed that the optimization energy, we have calculated it through Gaussian 16, and we reached to a conclusion that
graphene oxide can effectively bind with pesticide in different ratios, in 1:1 as well as 1:2. Next please. We have also performed molecular dynamic simulation using GROMAX, and the results are acceptable and interesting that graphene oxide has the ability to bind the pesticides effectively. Next please. Next. Now we need to understand how they binds with matter. This paper was accepted yesterday in Journal of Inorganic and Organometallic Polymers. So that's a good news for another student who worked on it. Our group worked on electrochemical techniques, computational calculation, and some other methods to understand the binding of or the adsorption ability of graphene oxide towards chromium. Next. So this sheet was taken to run the calculation of geo. Next please. Here, and we have varied the number of atoms. As in the Gaussian, we cannot put a charge on atoms. We have taken chromium as such, and we perform the calculation. In this, we can see the interaction between graphene oxide and chromium, as well as the interaction between the chromium atoms, because they also want to attain more and more stability. Herein we can see that the optimization energy, which was calculated in the default case, it is in Harty per particle, but we can also convert it into kilocalorie per mole or kilojoule per mole. So students, we need to understand how or what happened at molecular level, how geo or other materials can bind with small chemical entities. Next please. Further, we try to explore Material Studio. Recently we have started working on Material Studio, but on Gaussian we are working since 2014 or 15. In the case of Material Studio, we try to understand what is the ability of the sheet. Means it can absorb how many chromium. In the Gaussian, we have certain limitations, but in the case of Material Studio, we realize that it is beyond our understanding. In the Gaussian, we reach up to 3, but when we perform the calculation through Material Studio, we reached to a conclusion that it can bind the 12 chromium atom. So we will further explore it through MD simulations. This is the absorption study which we have performed for chromium. This work is published, but we will explore it and publish it in, or extend the work, you can say. Here, please go back. Herein you can see the distance, which is very important to understand. The range is 3 to 5. So we need to understand what is the distance between the graphene oxide sheet and the metals. And herein, most of the interaction is observed between the functional group and the chromium. Means functional group or the polarity enhance the adsorption. Next please. Next. We have also explored graphene oxide in sensing of antimony. Again, it is a very toxic metal. We need to understand. Even in the UG lab or PG lab, we use many metals and throw in the sink. And directly or indirectly, we consume it. I do not know about JNU, but at most of the places, we play with chemicals and throw in the sink. We need to understand that they are very toxic. We do not throw them in the sink because they kill the organism in the soil. They directly or indirectly come to us because we do not have good machine. Suppose if you might have RO, but most of us don't have.
So herein we have studied the interaction or the adsorption ability of graphene oxide through various approaches, various techniques. It is under communication, and I will discuss only the DFT calculation through Gaussian and MD simulations through Material Studio 2020. Next please. Here you can see that I have taken a graphene oxide sheet and varied the number of antimony atoms, and we can see the optimization energy in it. So this is the optimization energy which we have calculated in kilocalorie per mole. As I have told you, in default cases, the Gaussian gives you optimization energy or any energy in Hardy per particle. But we can convert them in different units. Next please. Next please. We perform the different calculation using Material Studio. Herein we can see, first of all, we have taken the graphene oxide sheet and we explored how many antimony atoms can show or can bind with the sheet. The graphene oxide the layer has good adsorption ability and it can bind with the 11 atoms of antimony. And we have performed the calculation in gaseous state as well as in water. In water, it binds effectively in comparison of gaseous state. Next please. So with this, I conclude that the computational tools can play an important role in the life of researcher. We can study the interaction of graphene or other GO, RGO and other materials with such toxic chemical entities. So guys, it is my suggestion, please include some computational work along with your experimental results. It will definitely give you an insight what happens at molecular level and will enhance the quality of your work. Next please. Next. So this is my research group. 4 of them are faculties in different places, and this is my research group. 6 students are working with me. Next please. The presentation cannot be completed until I acknowledge the people. I would like to acknowledge the principal of the college, Professor Gyantosh Jha. Second, my mentor, Professor D. Jairam. And I did my MSc from IIT Delhi, and since then, I'm in touch with him and using the facility of SCF Bio. Nowadays, he's retired or superannuated from the service of IIT Delhi, but still, his passion towards research encouraged me or provoked me to do some work. With this, I'd like to end my talk. Thank you so much, and I'm thankful to everyone, especially to the audience, because without audience, the talk is meaningless. Thank you for being here, and if you have any query, any suggestion related to my presentation, I will be very happy to respond to you. Thank you.
Thanks, Professor Prashant, for the nice talk. So now we can take 1 or 2 queries. Yeah, please.
Thank you, sir, for a nice presentation. So basically, I'm not a physical chemist, so just curiosity I want to ask, because most of the toxicant exist as oxides like chromates or arsenates, and what you have shown is I think atomic level, right? So have you also tried those?
Yes, one of my student is also working, and in that case, we have taken the salt, like lanthanum nitrate. Instead of taking an individual atom, we have taken the salt and varied it and tried to understand the interaction of GO and metal salts. And we find valuable information from it. Different from this, because here we cannot put charge on the atom. So we can claim it as atom or as well as ions. But in that case, we have taken the salt as one chemical entity without putting charge on it. Nice question.
Hello sir, thank you for this talk. So I actually wanted to know that how do you decide that how much like big the structure of the nanomaterial should be in the computational study?
It all depends on the machine you have. If you have good machine, means machine having good configuration, like its processor, its RAM, and hard disk. Only then you can decide what should be the dimension of the structure.
So the dimension of the structure from the like the computational and the wet experiment will vary.
Definitely it will vary. That's why in the beginning I mentioned that we should have a good machine. Only then we can expect that we are closer to the experimental results, otherwise we are not. So machine plays an important role, even if you have the same computational tool.
Thank you, sir.
One last question, sir.
Yes, sir, please.
A nice talk, and you emphasize on complementing your experimental results with DFT calculations or some kind of simulations. So one thing in your last slide, you have shown that 12 of the antimony atom can bind to GO, but how many GO atoms are there when you did the calculations?
Yeah. Here I have taken only one sheet.
So one sheet means how many carbon and oxygen?
That I have mentioned the structure with GO I have taken. It's 3 by 3 and functionalized with COH. Right now I cannot tell you the exact number of atoms, but I have taken a sheet with a particular number of COH, OH and epoxide. And I try to study or investigate how adsorption of atoms can happen.
Okay, one thing is that I am from IUAC. We have a very high performance computing center. IUAC New Delhi.
Yeah.
So we have a high performance computing setup.
Yes.
So you are welcome to utilize that for your simulation.
Wonderful.
If you have more space.
We will exchange our information or contact number, and we'll try to work in future.
Okay, now I think if you have still some questions, you can connect directly to Professor Prashant, right? So because we are running out of time, so yeah. So thank you so much, Professor Prashant, for the wonderful talk. I hope students will be benefited from your talk. So thank you so much.
We now request Professor Satendra Singh to present a memento to Professor Prashant Singh. Thank you, Satendra sir. Thank you, Professor Prashant. Good afternoon, everyone. It is my honor to introduce Dr. Sandeep Kumar Singh, our next speaker, who is Associate Professor in Information Systems and Analytics in O.P. Jindal Global University, Sonipat. I'll give a brief introduction about the next speaker. He has completed his MTech in Industrial Mathematics and Scientific Computing from IIT Madras. He earned his PhD in Computational Physics from Antwerpen University, Belgium. Post-PhD, he worked as research scientist in Sweden for 4 years in energy storage systems and bioelectronics. His research interest is to apply artificial intelligence to solve complex problems in scientific, business, and financial domain using mathematical modeling. Dr. Sandeep, it's my pleasure to invite you. And since we are running out of time, so I would request you to maintain the time. You have 20 minutes for your talk and 5 minutes for your questions.
Okay. So thank you very much, Professor, for such a nice introduction, and thank you, organizing committee, to inviting me for this event. Okay, so myself is Professor Sandeep Kumar Singh. I'm associate professor in Jindal Global Business School. I teach artificial intelligence to the MBA students, but my research interest is in, because I'm a physicist, so I do physics chemistry research at the nanoscale. I'm a computational scientist, but recently I'm also interested to decode Vedas scientifically, so I'm fusing artificial intelligence, science and Vedas. And today we will learn how we can harness the artificial intelligence to the ancient knowledge. will start why we should study ancient text, why we should study Vedas. So what is the purpose of human life? Everybody wants a happy life. The first purpose is to get the moksha. In modern term, we can say moksha is the end of all suffering. Either it is physical, mental or natural. And we should be in the state of anandam or state of bliss. Everybody wants happy state. But how it is possible in today's environment? We have lot of pollution problem. So how can we fit physically? In today we don't have pure water, pure air and pure food. So we cannot imagine good health. Next. Now we will talk about mental suffering. So now most of the people are suffering from the mental disorder, and it is predicted there will be a tsunami of mental disorder. Why? Because our thought is also not pure. They are filled with anger, jealous, hate, grief, pain, and we have a lot of psychosomatic disease because of that, like diabetes, hypertension, insomnia, and we have mental disorder because of war. So how to get rid of all this physical, mental suffering? And the second thing is how to create a warrior of future with dharma. Here I am saying Divya Manava ka Nirman, but can be Divya is too much big word, but Srisht Manava ka Nirman. So it is our dream how to create people like Yogeshwar Krishna, Dhyanand Saraswati, Bhagat Singh, Subhash Chandra, Azad. So how, because nowadays the youth don't have that much bravery, courage and purpose of life. So this is our goal, motivation for this Vedic study. So how can we get that happy state, by state of bliss? That only we can get if we have a pure knowledge of materials of this world. And this pure knowledge will come from the Vedas. Because in our Indian philosophy, the Vedas are considered the ultimate source of pure knowledge. And if you see Darshan, Upanishad, Gita, Mahabharata, everybody is citing as Vedas is the ultimate source of knowledge. And even in Bhagavad Gita, the Krishna told that there is nothing as purifying as divine knowledge. So what is that divine knowledge and pure knowledge? So in Dhyanand Saraswati talked about this knowledge. The Vidya is that which help us to know fully an object and material as it is. The word is important, as it is, or in Hindi we are saying Yatharth Vigyan. What is the actual form of that material? In today, I will give an example. In today environment, there is hurry to make product. We have some half-baked knowledge, and we are trying to make product to get the market benefit. For example, we created polythene. Now the polythene is the main polluter, or it's a big problem. But ancient Rishi, they are a visionary. They are thinking what will happen with this product after 100 years, 500 years, 1000 years. So they made this copper, and they made pots from the mud, and so they didn't invent any technology which is harmful to the humanity. So this is also a definition of science. So making wise use of Gyan, Karma and Upasana, and from acquiring exact true knowledge about Ishwar to the material Prakriti, using them suitably is called as science. So the technology which is harmful to the humanity and for this world, we cannot say science. But nowadays scientists are saying this is depend on the humans. If you are using for the good purpose or bad purpose, like nuclear energy, if you are using for bad purpose, nuclear bomb, or if you are using for good purpose, it is a nuclear reactor. It depends on the human. But the true definition of science is this: it should be always for the benefit for the humanity. So then the question is, how can we end the suffering of physical body and mind, mental state, once we know the origin of this universe, how we came here, and how our mind is evolved. So this is the big mystery. Human mind is also a big mystery, and this universe has a lot of secret. It is also mystery. So scientists up to now solved the puzzle up to atom, molecule, atom. Then they know the nucleus. Nucleus is made from proton and neutron is made from quark. And what is beyond that, they don't know. They told that there is a strings. This quarks is made from vibrations, and they call them strings. But this is like a theoretical tool. We cannot verify experimentally because this is so small. But this thing also did with our rishis in ancient time. In Vedas, all this process is written. And later, people wrote various darshan, philosophical granth like Sankhya darshan, Yoga darshan, and Vaisheshik darshan, Nyaya darshan, and Vedanta. So I will discuss how we can start from the beginning of the universe. So before that, the modern scientist is also trying to know the secret of the universe. So they start from the Big Bang. So this universe is made from the Big Bang, but there is a lot of problem with this theory. So first problem is entropy. So we know that according to the second law of thermodynamics, the entropy of the universe doesn't change or reversible process. Means I want to give an example. This is, for example, this is your hostel room. You clean your room, and after 7 days, your things are here, there. So usually things become from order to disorder. This is the entropy is increased. This is the law. But in the Big Bang, what happened? So there is an explosion from the point, and then the universe, this galaxies and we people are created. But we are highly organized. Galaxies are highly organized, and we people are, our eyes, our nose, everything is very systematic. So it is a very intelligent creation. So, but here is the reverse. In Big Bang, there is an explosion. This is the entropy is decreased from disorder to the highly ordered state. So it is not able to explain the second law of thermodynamics. Also, I want to give one more point, that this is the building block of the life cell. It is made from 40,000 atoms. There is a Darwinwad is there, and they are saying this is a natural selection. Atom is arranged in such a way that the life came in a cell. But if you make a possible combination of 40,000 atoms, then there is a 10 to the power 160 combination are such that life is not possible. Out of one only life is possible. Then we are saying that okay, life is coming by natural selection or by some random move. So this ratio is too much, 10 to the power 160. You imagine. So we believe that there is some super intelligence or Brahma is there, some super intelligence is there who created this universe. There is a one beautiful analogy that there is a one waste is there, and then storm is came, and after storm passed, then one fighter plane is invented. How it is possible? From highly disordered system, fighter plane is very complicated structure, and then how it is possible? So this is the analogy. It cannot be happen. So this I can give like hundreds of examples. So there is a lot of discrepancy in modern science to explain how this universe is originated. So then I try to decode the Vedas, what is in the Vedas. So in the Vedas, how the Vedas is written, means there is some vibrations are there in the universe, cosmos, and in the beginning, when the humans came in on this earth, there is a 4 Rishi, Agni, Vayu, Aditya, Angara. In their deep meditative state, they resonate with those cosmos, and then they wrote Rig Veda, Yajur Veda, Samveda, and Atharva Veda. In the beginning, Rishis are able to communicate with these Vedas directly, but later, because of this tamasic nature is increased in the humans, and they are not able to understand the Vedas, then they wrote the Brahman Granth, the explanatory Granth of this Vedas. So each Vedas have their explanatory Granth. For Rig Veda, this Aitreya Brahman is the explanatory Granth. Brahman is means here to know the Brahma. There is a Aitreya Rishi was there. So Rig Veda is the book of the universe. It is, many people claim that it is okay, Yamuna is there, some Rama is there, Krishna is there in the Vedas. No, this is the book of universe, only universal law is there. In Sanskrit, this is the beauty of Sanskrit, every meaning has some, every word in Sanskrit have a meaning. This is the only language which has direct meaning. So Krishna is also has a meaning. It's not like Krishna Bhagavan is not there. So Krishna means some dark color or some object is there. But what happened after Mahabharata? Lot of warriors and rishis are killed in Mahabharata war, and then other people, not eligible people become king, and then they misinterpreted the Vedas and Brahmana Granth. Because of that, the bad rituals came in the society. The animal sacrifice, human sacrifice, intoxication, casteism, inferiority towards women, and so lot of, and because of that, the other religion came like Bauddha Dharma, Jain Dharma to counter that. So this is a different story, but because of that, the Vedas and Brahman Granth science has lost. People now hate it, and now even today people don't know too much about Vedas. What is the science in Vedas? So this is the book we have written, and this is the Vedic. So I also studied lot of books from the Vedas, and I didn't find any good interpretation. The trusted interpretation is only from Dayanand Saraswati, but it is only just they are giving some hint. It is not detailed interpretation. So then from the Rig Veda we wrote one book, Rig Veda Brahman Granth, Aitreya Brahman, how this universe is working. So this in that moment in 2018, Venkaiah Naidu was the vice president. He inaugurated that book. So this is the Vedic Rasmi theory we gave. This is new theory. People are trying to unify all the theory like electromagnetic, strong force, and gravity is now not able to unify. But this is the like a universal theory. We can interpret using this theory from the nano scale to the or atomic scale to the galaxy level. So according to this theory, the universe is made from the vibrations. Even Tesla told, if you want to understand the universe, you have to understand the universe in terms of vibrations. So here Rasmi is the vibration. So we go back, we start from the beginning. So in the beginning, we have like a there is a Trivad is there, Tretvad. This Ishwar with universal consciousness is there, and then Prakriti is this is the fundamental cause of this universe is there, and this is, so when Ishwar or universal consciousness want to create this universe, they create first vibration, and that is we call Para Om or Kal. So this time we are saying, oh, now it is 1 o'clock, this is the relative time. Now it is 2 o'clock, so this difference is 1 hour, but this is relative time. But what is actually Kal? What is time? What is its property? How it is involved in our life? That is different. Nobody is able to explain it. That is different story. So actually Kal, what it is decay, its property is to decay. So we also become old. Who took the shape, who took the birth, he or she will die. Even in non-living things also will die. So Kal is invented, then the role of Ishwar universal consciousness is over, but its vibration, this first vibration, Para Om, is always there. That's why the Ishwar is everywhere. In us also Ishwar is there. In this mic is also Ishwar there. Because non-living or living, the param vibration, the first vibration is always there. Because of that, the Prakriti transformed to this universe. So there is a 5-6 element. So we explain in a detailed manner everything. So how this, then this Prakriti, where this Sat, Raj, Tamas was in equilibrium, but it disturbed. Because of that, it created the universe, and then it converted to Mahat state. In Mahat, then Ahankar, Man. This Man is like a universal mind. All the minds, we have an individual mind, and we are connected to each other with this universal mind. So when we are hating each other, we are jealousy, we are getting anger. So it is, we are not affecting our mind, but we are polluting the universal mind. Nowadays, in the universal mind, the waves of pain waves, anger waves, it is more. That's why we are attracted towards the universal mind. We are not loving each other that frequently, means we are hating, we are jealousy. Because of these waves are filled the universal mind. Okay, so why we should study the cosmos or universe? I will give one analogy. You purchase one car. Once you know the rules of the car, then you can drive safely. Otherwise, you will do accident. Similarly, if you know the how to live in this universe, then we can live peacefully and happily in this universe. We know the rule of this universe. Otherwise, we will do mistake. We will suffer physically, mentally. So I discussed this thing. What is Rasmi? This is the vibrations. And how this is, there is a 4 types. This Rasmi vibration have Sabd, means words, and this is sound. So sound is eternal. And how it is works? So you study only sound is the compression of in the medium air, but it has a 4 types of in the Vedic. First one is the bakery. When we speak, so this sound is going through this medium air to some ear. From ear to the mind, it is going in Madhyama, in electrical signal. From Madhyama to the Manastat, universal mind, it is going in Pashyanti form, and from Manastat to your Atman, it is going in the Para form. So then you are feeling, they are saying, abusing me, or so it is, somebody is saying kind words to me. So this is the form of the sound. I think you heard first time this thing. And this is the origin of all the vibration is Achara Rasmi. Achar. Char means to decay. Achar means it never decay. This Achar, never decay. So this is that's why we are saying Sanskrit is the God language, because what the vibration is happening in the beginning of the universe, it is this Achara, A, I, U, all this. So this is the language of the God. People are saying because of that, because this is scientific. And then this Achara Rasmi creating another Rasmis, bigger Rasmis, that is called Chand Rasmi. So now you know that there are 7 types of Chand Rasmi. So Gayatri is the famous, you know Gayatri Chand. So in the O Tat Savitur Varenyam, this has 24 words. So this is we call RC, but even Om is also Gayatri Chandrasmi, that is Devi Gayatri. So these Chandrasmi have different property. So Gayatri Chandra have light property, is illuminate. So when this, in the sun rays, the vibration, if you can detect the vibration, in modern technology cannot detect, but in future maybe, it is the Gayatri Chand in Pashyanti form. And when we recite the Gayatri mantra again and again, then it is giving energy, ignite some photon energy in our body. So it is a great, this vibration have a different purpose in the universe. So, so we discuss about many things, like I will give 1-2 examples because of time. So in modern science we have 4 types of force, but in Vedic science we have 9 types of force. even for this is the mediating particle for the graviton, and people say this is the fundamental particle, but we say this is also made from many vibrations, like 7 type of vibrations. Om Rasmi, Ritu Rasmi, Mas Rasmi, Trishtu Brahati, Pakti Rasmi. So this is unknown to the modern science. Even photon, they say this is the elementary particle, but in the Vedas, it is like this is made from 360 type of vibrations. So we have a detailed knowledge of this technology. But why should we study photon and this internal structure? You know, we know the electron and photon, then we have a technology of electronics and photonics. And the country who has this power in electronics and photonics knowledge, they are dominating the future. So people are going more deeper. So if they have this knowledge, then they can control the other technologies. So everybody is trying to dig. Quark technology, something anti-particle technology. Now positron is also some MRI based on positron in the UK, some cancer detection is there. So yeah, this is the one more example that we know we know the electron has a negative charge, but we don't know how this charge came. What is the origin of charge? We know positive and negative electron attract to each other, but why it is attracting? Because positive charge have Virati Rasmi and negative charge has Marut Rasmi. This is the science. People claim or people say that you Vedic guys, what the modern science is doing, you Vedic guys tell that, okay, it is already in our Vedas. What we are doing new things to us. So we are giving these new things. The modern science will take 50 to 100 years to verify this, or to prove it. So we are ahead of modern science by 50 to 100 years in this research. What is the structure of Akash, space? So in the Vedic physics, so this is the book Vedic physics. This is the book Ved Vigyan Alok. We have written from the Atre Brahman. This is like 3,000 pages. But then we wrote a summary book of Vedic physics. This is freely available as PDF. I can share in this group. And then this is the new book of Vedas Vigyanam. We have written how to understand Vedas. And this is the scientific interpretation we did from the Gayatri Mantra after 5,000 years. People are saying only spiritual interpretation can happen, but we did scientific interpretation. How the Gayatri Mantra is affecting us scientifically. And recently I interpreted Gayatri Mantra in 50 terms, like how management, marketing. I'm writing one book in artificial intelligence in various, because Veda is told that Vedas has सर्व सत्य विद्याओं की पुस्तक है, but how we can claim if you have only spiritual interpretation of Vedic mantra, then how सर्व सत्य विद्या we can prove? So I interpret. So any field can be interpreted using mantra. This is the cosmos, and if you interpret in terms of physics, chemistry, mathematics, management, psychology, anyway. So I'm writing one book, so I will interpret like 50 or 100 ways Gayatri Mantra. So now, what is the role of AI? So this book took 12 years to decode Atre Brahman, because we don't have labs, or we are just doing deep meditative state. We are taking one mantra. We are in the room. We are doing meditation for 3-4 days, and then this is visualizing. And my Guruji is doing, because he is like pure by heart, pure in mind. In Patanjali Yoga Darshan, Yam Niyam, we have to follow first Yam Niyam. You have to purify your heart and mind. Then only you can decode. But and this Vedarth Vigyanam, this is Nehru. It took 5 years to decode. So only 2 Grantha took 17 years to decode. But in the morning, Satyapal Singh told that there is a 10,000 other books are there to decode. So how we can decode all this? So this book is inaugurated by Vice President. Few days before, I was there. So now we are living in the AI era. So AI, artificial intelligence, this is the exponential era. So in the beginning, when we have a very less amount of data, so progress is very slow. But we are here today in this steep curve. We have a lot of data, deep learning, machine learning is working very well. And this is the famous Moore's law, CPU computing. It says in every 18 months, the number of transistors becomes double on chip. So the computing power is become double. Even in NVIDIA nowadays, it breaks its record. It become 1 million times faster than within 5 years. And now the new era of quantum computing is also coming. In 2 days before this, is Google chip was there, and it is trillions times faster than the regular chip. So it will, this accelerated computing will accelerate the AI discovery. And this is the, some people are saying that we are just fascinated with the ChatGPT research, and people are saying that ChatGPT is the amoeba of AI evolution. It is just a starting point of AI. And people are saying we have like 10,000 Einstein power. Yes. So what I did, so this is the ChatGPT 4. This is the O1 model, recently released model. I have paid version of this. So what it is very good in mathematical reasoning. So there is a prompt, how we are writing prompt, it matters. So this is zero-shot prompt. So I told that, okay, explain the Gayatri mantra. So it is explaining different, it is not good. So I gave some reference. This is the few short prompt. So if you give the few, some reference, then it is explaining very well. So I am giving some reference. One interesting thing is, it is capturing Sanskrit very well than Hindi. So I trust on Dayanand Saraswati interpretation. So I give Dayanand Saraswati interpretation, and then it is explaining very well who, what it means, and what is interpreted meaning. It is what is I want. And then it is explaining Savita means, and it is giving reference also from the Rig Veda. Savita is there. This is the style of Rishis Parampara. What Rishis are decoding, they are giving reference from the Veda, different other Vedas, Upanishads, Darsana. So it is doing very well. And this is the last slide. So people are saying, okay, Newton stole our three sutra, Newton's law. But we have that is Vaisheshik Darshan is there. There is 370 sutras are there. And so we cannot claim that Newton. There is a scientists are working. Curiosity is there. Idea can come on Newton mind. Okay, it is told. I agree with you. But what about 367 sutra? You can do. So people, it is not good to just put finger on the other side. You stole my work. You stole. Lot of things are here in India. So you do work. So there are 367 sutras are there. So now I started. So I first tried to want a Newton's law from there. So I think it is easy. But other mathematical form from this sutra we can derive, and we can, like 3 Newton's law gave lot of engineering applications. So even one sutra we can able to decode mathematically and give some engineering application. This will be a huge change. A great change for the society. Okay, thank you very much.
Thank you, Dr. Sandeep. It was indeed a very interesting talk. So, since we are running out of time, we'll just take one question. Okay, so we drop the question and answer session. Whoever is interested, you can please get in touch with Dr. Sandeep during the lunch.
Can I just make a quick comment?
Yes.
So that was a very interesting presentation. So thank you very much for that. In fact, I have a book on Karn, and usme it is mentioned that Karn, while doing his Surya Puja, because we know that he was a big devotee of Lord Surya, so he would often chant the Gayatri mantra. And आज तक मुझे इसका correlation समझ नहीं आता था. You illustrated it in your presentation that while doing Surya Namaskar or a Surya Puja, the purpose or the relevance of Gayatri mantra. Because I always saw Gayatri as a Devi. So I was wondering that why Gayatri Devi being worshipped when you are actually worshipping Lord Shiva, Surya. So that correlation you illustrated in your presentation. Thank you very much.
Sir, do you have a blog or website?
Yeah, Vedic Physics is a YouTube channel. Vedic Physics is there.
I think you can promote there. No?
Yeah. Yeah, so in the Vedic there is no Devi as like human form. Devi is who give us. Dev or Devi. So Gayatri is energy, everything is energy.
Thank you, Dr. Sandeep. We now request Dr. Tulika Prasad to present a memento to Dr. Sandeep Kumar Singh. Thank you, Dr. Tulika. May we now request Dr. Vinod Kumar to present a conference kit to Professor Satyendra Singh. Thank you, Dr. Kumar. May I now request Dr. Khushbu to present a conference kit to Dr. Pratima Solanki. May I now request Dr. Deepak Kumar, Dr. Deepak Gupta to present a conference kit to Dr. Tulika Prasad. We extend our gratitude to the speakers and chairpersons for their invaluable contributions to this engaging session. We are confident that the participants have gained significant insights and stimulating ideas from the discussions. We now proceed to the next session, the Rapid Oral Talks, chaired by Dr. Balaji Birisdar, Dr. Prakash Kanu, and Dr. Sandeep Kumar. Dr. Balaji Birisdar is Assistant Professor at SCNS JNU. He has expertise in electron microscopy, nanomaterials, thin films, and ferroelectric materials.
Dr. Prakash Kanu is recent addition to the SCNS family as Associate Professor. Dr. Sandeep Kumar recently joined as Associate Professor in SCNS JNU also. We would like to announce again that selected few papers will be considered for publication as a special collection in Wiley Journal Chemistry Select after peer-reviewed process by Journal Office. This session features oral talks by Professor Seema Vats, Dr. Indra Sulania, Dr. Tripti Kumari, and Dr. Bhaskaran. We now hand over the session to the chairpersons for this session.
Thank you. So we have this session of rapid talks. So welcome to you all, and we will not spend more time. We have the speaker. So floor is yours, ma'am.
Thank you very much, organizers. Since we are running short of time, so I'll stick strictly to the time schedule. My talk is basically, it covers very basic science, and whatsoever I have been able to research so far, I'll be presenting it, and it's basically a thought-provoking talk. So can I have a next slide, please? Point. Okay. So basically, I would like to talk about first the science behind Konak wheels. This is very common. This first slide you must have seen on the internet. There is nothing great I am discussing, but I'll come to the more detail of it. It is the Konak wheel, and you can just see that there are 8 basically. These are the wider spokes, these are the thinner ones. In between, it starts from 12 a.m. It is in anti-clockwise direction. You just note down the time, and then you have a beads. Beads are there are 30 beads that you can see that from thinner spoke to this one there are 30 beads, and each bead have a 3 minutes time. So it's basically it is serving as a sundial, and this is the center. This is here with a z-axis as well, and it's like a sundial. And then you have a shadow falling on this, and accordingly you can calculate the time accurately. Now, next one. The thing is, this is being talked about in the Brahma Purana, and this is a Bhavishya Purana. The Samba was the son of Lord Krishna. He asks about this Konak wheel, what exactly, and there is a lot of mathematics into it. The thing is that this says that this is your Excel. This is called as Padmanabi, and this is Nabi, this is Padmanabi, and just see the ratio. It's 8. Then they have this is ratio as 24. And then we have another, there is a circle, and this outer one diameter is of 64, inner one of is 40. So basically this larger is 80, 24 and 64. It has been mentioned that this has to be drawn in this manner. And basically when we talk in terms of mathematics, it's 138. So when we come to Fibonacci series, we just see the alternate numbers. Secondly, we can say that these 4 circles, we have a diameter 8, 24, 40, 64. So it is again alternate numbers from a table of 8. Second thing is, most important one is that when you have a 40 is a circle, this is the outer circle, this is the, this is the outer one, this is the inner one, and in between the difference of the diameter divided by 2, you have a 52. So next slide. This is all about the mathematics and all these things, but the main interesting portion that it's a wheel. And when we talk of wheel, we say that it should move. So I just somehow I got to know about this article, and it's very interestingly written. So I thought why not mention it and explain to you that what's the physics going behind this. It says that there is a certain kind of unbalance which is driven by the magnetic field. Now the question arises, how come we say there is a magnetic field? And that literature basically, what was written that in the Konak wheel, as I shown you the wheel, so this is a Padmanabi. They say that this is a central magnet. That magnet is fixed, right? But we all know that the magnetic lines of force emanate from north and south pole, and they are inherently connected together. We cannot separate the magnetic poles. But there is beauty in the building of the Konak wheel is that there are 2 influencer magnets. And then this have a shielding effect. Shielding effect means that we are able to shield few of the magnetic lines. Only few of them can emanate. Rest of them are being emitted. Now it has been mentioned that this is made, the shielding is made up of mu metal, which is nothing but an iron and alloy of nickel, this nickel and iron alloy, and we use in our sensitive electronics these days. Now the point to be noted here that when we just move, we say there are 8 chakras, right? In which I told you that the outer circle has this 40 and 64. So they say that there is a orbiter magnet being here, placed over here. Note down, this is a fixed magnet. These are the orbiter magnets. These magnets, they move around their axis. Okay. Now, what happens is that they are being separated by a separator. Why do we have a separator? This means that their magnetic lines of force, they do not interact with each other. The only thing is, what is interacting, that each chakra, each magnet, orbital magnet, is interacting with the fixed magnet, not with each other, right? Now, the point to be noted here that we have this shielding and we have a separator, and then we have in orbital magnet also, they have been provided with certain shields. So we are creating an imbalance somehow right from the roots by shielding effect. That few of the magnetic lines are exposed, few of them are not. Now, when we come to next slide, please. Now here you just see these angles are really important. You can see that this is angle 350. This is 360 degree because one moves around this state comes to 360 degree. This is 40. There's another point to be noted that between 2 large spokes, it's a 45 degree angle that we have.
Now what happens that this imbalance is created basically by the, next slide please. Yes, this is created, there are two diagonally opposite orbiter magnets. This is this 315 and 360 and here 135 to 180. What we can see, just talk about this orbital magnet. There is a shielding, it is not interacting. There is a shielding. The magnetic lines of forces are not actually crossing. Over here, this is also being shielded, but these are the angle at which there is a direct link between the fixed magnet and the orbital magnet. Same here, and same here. So what happens that this will try to move to the stronger poles because the magnetic field lines are strongest at the poles. So this wheel will try to move to this thing, and similarly this will try to move to this thing. So this process keeps on repeating, and we say that wheels start moving by this magnetic field. Next one. So basically this is a thought-provoking idea that we can have a self-sustainable machines. I am not claiming anything. I am just putting out that we can have machine like that. In the literature is very enriched. We are talking about the Vedas and all. So now, then there is a very good thing about Golconda Fort. If you have been there, the guide must have told you that there is an interplay of sound, and if you have a coin, you can hear it. So actually what's behind this? We always talk of basic science behind this. This is the building structure. So you can see that what they have done, they have an interplay of doors and the walls. Sound travel with a velocity of 343.3 meter per second, or we can say 1.23 kilometer per hour. But what happens in Golconda Court, that if a soldier would clap at the entry, the king over here would hear it within a second. So how does it happen? It's a pure acoustic marvel in which there is a material science of the walls, which are the walls are made up of, and it has been somewhere documented that these walls are made up of some clay utensils which is being mixed with the building material, and they are being smooth so that sound reflects it at a particular direction. You know, like sound gets reflected without being attenuated. So this is very important from the architecture point of view. The moment sound reflects, there is another body to catch it and again reflect it. So this is the thing. Next slide. The roof of this Golconda Fort, these are having the arches of the diamond shape, and these are indentations. This help in the basically even a clap is heard till up to 3 kilometer system. So this is a sound alarming system. Sound alarming system, this could best work for the lab students, like if their guide is coming, then the shoe noise can make them alert, they should start working. So just see that if we can have a combination of our material science, our placement of the doors and buildings, we can work wonders without any big machinery. It's just that. Please next slide. The same is there in the Gold Gumbaz. Gold Gumbaz acoustic marvel is beautiful in this respect that if you say hello, then this is echoed 7 or 8 times in just 26 seconds. So this is being very appreciated. And then there is a gallery on the top floor of Gold Gumbaz, in which what happens that king used to use this for hearing the people who are really, if people are conspiring in this corner, the king standing over here, he could hear it. Though there is a distance of 4 feet in between, the thing is again the walls are being smooth, and then they get reflected, and the circle is designed in such a way that the curvilinear propagation of sound is there, and there is an amplification, and there is a sound echo as well. So next one. Basically then there is another architectural wonder. The people wonder that how do they place this Gold Gumbaz without any pillars, without any beam system. The thing is that there is an interplay of these curved walls, diamond shape, and then they place the gumbaz on this. So these are the thought-provoking ideas that we should think about, that how could it be done. Yeah, next one, please. Yeah, last one.
Okay.
These are just 2 slides more.
Okay.
So now just we are talking about the nanostructure gold and this nano bhasma, and we say that swan bhasma. So I came across one paper in which they synthesized the swan bhasma, and then they try to characterize by XRD, SEM, and this thing. So I'm just size matters in nanoscience. If we have a 500 nanometer, it's comparable to the large nanoparticle with visible light. Small one electron mean free path, that is this. And since next one, I won't get into the details. When they did the XRD of Swan Bhasmas, they found 4 intense P's, and that too of a pure gold, which is really surprising that after being having going to such a high temperature and all, so this could be this. And then they have this 111 triple peak, and please the next one. I'll not go into a detail of it. The SEM micrographs of Swan Bhasma, this shows the agglomerated morphology of actually gold Bhasma, and the size is very small, so they did TEM for it, and this would be my lifestyle. In the TEM they have for low magnification floor one, and the size is actually they are talking about is in Bhasma is 5 to 20 nanometer size. And similarly, when they go into this, they got to know it is a crystalline, and then there's another portion of polycrystalline as well that I didn't mention. And this is how basically our modern technology and our all these monitoring can help us to improve on our techniques in making the substance. Thank you so much.
Thank you, ma'am. It was quite illuminating talk and a different perspective of exploring what all is there. So the next speaker, my colleague, Prakash.
Thank you, Dr. Balaji. Good afternoon, all. So our next speaker is Dr. Indra Sulania from IISc Delhi. Dr. Indra will be talking about searching ancient texts for usage of natural colors and pigments. So please, Dr. Indra. I'll have a request to the speakers, as we are running out of time, please finish your talk on time. A kind request. Thank you.
Good afternoon, everyone. So I would like to, on an onset, would like to thank the organizers for giving opportunity to interact with the audience on IKS, because our government is paying a lot of thrust to these areas to illuminate our youngsters with the treasure we are holding in our, Tamapatras and Vedas, etc. So I have been searching few of the things because I am connected to one of the groups who are working on these IKS systems. So today's discussion is on searching text for usage of natural colors and pigments in Asian caves in the context of nanotechnology. So my focus is in this Ajanta Ellora caves. Basically, these are the viharas which the king made with the help of the rock cut architecture. And these caves actually are the Buddhist caves which were made on the path where the व्यापार को क्या बोलेंगे इंग्लिश में मीन्स ट्रेड रूट्स के ऊपर बनाया हुआ था, सो दैट द जो हमारे ट्रेडर्स हैं वो रेस्ट कर सके एंड देन दे कैन जस्ट रेस्ट इन दोज, एंड दे बेसिकली बुद्धिस्ट monks used to stay in those caves. And because at that time the kings had lot of faith on the Bhagwan, so they have like crafted those caves beautifully in the form of lovely paintings which actually contains gold in the form of some nanoparticles, because their shine and light emitting things have not faded away since now, 1000 years ago. Okay, so these rock caves are made up of volcanic basalt, which is relatively hard and resistant to weathering. Still, because these are caves, so water used to come inside the caves. And this is one of the example where you can see Bodhisattva Padmanabhani painting is there with a lot of detailing. Eyes can be beautifully seen, lips can be beautifully seen, and this you have to appreciate that it is thousands of years ago and still it is retaining its beautifulness. in terms of detailing and the colors used. And mind you that these colors were not like synthetically grown. These were all naturally derived color from the natural elements which were present in the nature at that time. Okay, and it is a UNESCO World Heritage Site to ensure that these caves will not wither further. So we have to prevent them from withering. Okay, so this is one of the quote which I have taken, that Yatha Sumeru Prabhoro Nagaram Yathanam means you can read it. It says that as Sumeru is the chief of mountain and Garuda is the chief of those born out of egg and the king of the chief of the men, even so in the world is the practice of painting the chief of all art. So it is considering that the artists who are painting these unique paintings or walls of these inside caves, they were treated like very high during the kingdoms, ancient kingdoms, because they were considered to be like, coming from somewhere else, because they possess such a nice quality to paint in a beautiful manner. Okay, so I told that these are the Buddhist caves, and one of the person who was actually British Army person from Madras Army saw in 1819, and these Ajanta caves are named after I think it is written somewhere. It was named after the person who actually first saw it. These are like 5 kilometers away from the distance of Ajanta. And the first scholarly report on the caves was by James Ferguson, and in a paper who read at the Royal Asiatic Society of Great Britain and Ireland in 1843. Describe these rock-cut temples of Western India, including those of Ajanta. It's a very special way of seeing fulfillment of vision. Means he is praising these cave paintings a lot. Now you should appreciate that when we are nowadays, if we are painting some of the things with a normal color and all, in few of the days passing by, the color fades out. So how to prevent these colors from going away, because there is a special way in which at a certain angle these stones were cut, so that it is minimum exposure to the water and sunlight. And then over there is a it is coming up in the next slides, that how they used to treat a coating first, treat the stone with a coating first, and then let me show you. So you can see that the basic character of Ajanta sculpture is unconsciously but quite naturally related to indigenous school of Deccan sculpture, and the goldsmith and ivory carvers. Ivory carvers are the elephant stones were also used as the jewels to portray the Bhagwan Buddha into a very beautiful shapes. So I think it is missing. So they used to actually take some kind of make some kind of natural plasters using the egg yolk and some kind of binding agents, and they used to coat that wall first to make it into a smooth layer, so that if they are filling the colors into those walls, it will not go with water interaction or some kind of, if there are a lot of things which can actually take away the color from that. And this is the beauty of it. You can see this golden color, so it is still intact in those caves. Okay, and it is because of these nanoparticles which are seated inside these gold colored patterns. That time the nanotechnology was not nomenclature like that, but they still used to have a nanoparticle formation. Okay, and one more thing is this, how these colors were derived. So these were derived from the naturally occurring ochres, which you can find now also. The red ochre was used to give the natural pigment for red. It is derived from the iron oxide, which is reddish brown in color, yellow from iron oxide, which is yellowish brown in color. So these are all from the iron ore things, because it was heavily used in the metallurgy of iron. And some of the examples are here. Hematite ore is the red in color. So these are how the colors can be derived from these kind of ochres. Okay, so this is the example how nanoparticles are helping to protect the color from degradation, and it has been known from the literature that actually nanoparticles, they absorb certain light and give us good color, and it will also help in creating a non-degrading layer, so that the light and other things do not interact with them, and help them in the protection of those. So I found one literature over here. It is a thesis of one of the students from Thailand. Actually, in Thailand also, it's the second largest population of who worships Buddha. And Buddha is the incarnation of God Rama. So there are like many, similar to our Buddhist sattva paintings, there were many things which are carved in the form of Bhagwan Ram and other things in their caves as well, made in same era almost. So here you can see that they have, in this thesis, they have used the small elements from those caves, like extracted some of the paintings from those layers, colors from those caves, and then they throw it under the absorbance spectra, EDX spectra, to understand what kind of elements are present in there. So it contains magnesium, aluminum, silicon, and all these things in the form of, like hematite has Fe2O3, so, and it contains copper 2, aerostate, these kind of compounds. There are references also, so which says that if we have these kind of things which can be taken from the caves, and absorption spectra and EDX spectra and other FTR spectra can be taken of these elements, so we can have clear idea, and comparing with the nanoparticle peak of that particular element, we can actually confirm that these are actually the nanoparticles, which is keeping them away from the degradation. So in the ancient text also, sir has very nicely said, and the previous speaker also said, and Satyapalji also said, that we used to have it in the Ayurveda since beginning. So we have turmeric, sandalwood, neem, and they have like medicinal properties, and we used to have these bhasmas also in the medicine which was given to the human beings. And like, for example, this turmeric, actually it has a mention in Atharva Veda, and it is considered to be the Harida. It is used as a symbol of prosperity and fertility in the various, now also in the rituals of marriage and some kind of good auspicious occasion, we use haldi as an auspicious thing to be put on some of the human figures. It's actually lot of things I need to discuss, but still, just I will mention one of the things. So Shukla Bhattam is like, this is a phrase from the Rig Veda. It shows that it is a white pigment. So there is a mention of these pigments even in our Veda. So Malti Swarna is the phrase from the Manu Smriti, refers to as a golden color. Tamra Phal is mentioned in Charak Samhita. It is the copper colored thing. Kajal we all use. It is from the Sanskrit text, referred to as black pigment, traditionally used as eyeliner, etc. It is used from the soot from the lamp black. When you are burning something, then that soot can be collected to form kajal. And Gauri Ranga is taken from Bhagavad Gita, refers to as fair complexion. Like you know that Gauri means Gaur, Gora. So these are some of the terminology which are used for the colors in our ancient text also. So it is not, I am concluding. Okay. So the Vedas are, there are 4 Vedas, and he has already spoken about it. So we actually should, like it has been mentioned since beginning, we should have to have more kind of, self-admiration about our own historians, ancient rishis, because there is a lot of things to be explored. It is just, tip of the iceberg. And I hope on certain platform I will be able to interact with you more on this topic. Thank you so much.
Thank you, Dr. Indra, for a nice presentation. So, shall we take one question? Okay. So, if you have any queries, you can discuss with her in person. Okay. So, I'll now invite my colleague, Dr. Sandeep, to introduce the next speaker.
Thank you, Dr. Prakash sir. So, good afternoon to all of you. So, we have next speaker, Dr. Tripti Kumari, GC University of Delhi, Gargi College. So, over to you, ma'am.
With the permission of the chair, a very good afternoon to each one of you present here. I'm Tripti, and today I will be talking on quantum inspirations, Indian scriptures as the route to modern nanotechnology. Now, in my presentation, first of all, I'll be talking about very briefly that quantum mechanics is the foundation of nanotechnology. Now, we all know that, so I'll be very brief on that. Then I'll be talking about the time when we were shifting from classical mechanics to quantum mechanics,
a time when history was being rewritten. Then what the founding fathers of quantum mechanics had to say about Indian knowledge systems. Then I'll be drawing some philosophical or metaphorical references of quantum in Indian literature. Precisely, I'll be talking about just general relativity, uncertainty, the unity and continuity of quantum mechanics, and the dynamic motion of subatomic particles. And then I'll be concluding. So, we all know that nanotechnology finds its foundations in quantum chemistry, quantum physics, whatever we may call it. Nanoparticles display some very interesting properties. Now, in the microscopic realm, where these nanoparticles exist, they have some very intriguing properties like chemical reactivity, fluorescence, colors vary with, with the variation in size, and all these properties are vastly different from their macro scale counterparts, and all these properties are so because they are governed by quantum effects. So there is a lot of literature about the relationship between quantum and nanotechnology. Therefore, in my presentation today, what I'm going to do is that I'm going to draw parallels of quantum in Indian texts, and I would like to emphasize that how most of the earliest recorded evidences of quantum mechanics came from Indian literature or were already quoted or cited metaphorically in Indian literature. Now, this is a very important slide because this talks about the period when we were shifting from classical to quantum and the period when history was being rewritten. Now, there was a time in the 19th century when the scientists were making some very bold propositions. Einstein said that light is not a wave but a particle. Max Planck said that energy is not continuous but it is quantized. And Bohr, he did the hydrogen atom spectra, and he again said that energy is not continuous, it is quantized. Now, these people themselves were not believing in what they were saying. I mean, there is a line in the physical chemistry book by Atkins where it is said that Max Planck, when he proposed the concept of oscillators in energy, he himself did not believe it. बस वो experiment को justify कर पा रहा था, इसीलिए वो concept उन्होंने दिया, but they themselves were not believing. In fact, these boisterous propositions that they were being made, they thought they will be considered ridiculous, they will be considered too crazy to be true, and the scientific community will befool them. So, in this moment of self-doubt and personal dilemma, हम सब ने PhD करी है, and I think we all go through that phase in our research when we know nothing and we feel that we are stuck and we have an absolute self-doubt, a personal dilemma, and then who do we go to? God. So they also, they turned to ancient Indian wisdom, and ancient Indian wisdom brought them great comfort, brought them great solace, because ancient Indian wisdom में जो ये बात कह रहे थे, they were saying that the world that you see is not true, but it is just a projection. The same thing they were proposing when Einstein said that light is wave is not true, but a projection of something else, so light is also a particle. Or when Max Planck said that energy is not continuous, but quantized. So what we are seeing might not be absolutely true, but it might be just a projection of our consciousness. These concepts, this sort of philosophical interpretation they found in Indian scriptures. In the Upanishads, the Western world found echoes of their theories. They found metaphorical references which ensured that they will not be considered crazy, that they will not be considered ridiculous when they make such bold, revolutionary quantum propositions. The founding fathers of quantum chemistry, we all know of Bohr, Schrödinger, and Heisenberg. They often quoted, acknowledged, and credited the philosophical context in the Vedanta and Upanishads. In fact, in his autobiography, My Life, My Worldview, Schrödinger says that quantum mechanics is an attempt to give the form to the core ideas of Vedanta, or after the conversation about Indian philosophy, some of the ideas of quantum that seemed crazy earlier, they started making sense. In fact, Oppenheimer said that what we find in modern physics is an exemplification of old Hindu wisdom, and David Josephson, who's the youngest Nobel laureate, said that the Vedanta and Sankhya hold the key to the laws of mind and thought process and the distribution and operation of particles at atomic and molecular levels. The slides are not moving. Can I have the next slide, please? Niels Bohr said that I often go into the Upanishads to ask questions, and Heisenberg said that quantum theory will not look ridiculous to somebody who has read Vedanta. So this is what the world said. Now let me quickly go to the recorded references of quantum mechanics that can be traced to Indian scriptures, and the first analogy that I'll be talking about is Einstein's relativity, alternate universe, and the concept of multi-dimensional realities. Now Sandeep sir in the earlier talk already talked about time, and he talked about Kal, and he said that time is not absolute, time is relative. So the same thing Einstein proposed in his theory of relativity. He said that time is relative, it is not an absolute concept, and he conceptualized that if something moves very close to the speed of light, time slows down. The concept of time dilation was proposed by Einstein in the 19th century. This is from the book Halliday, Resnick and Walker, a very famous physics book. Measurements of the same time interval from another inertial frame will always be greater. Now I'll quickly give a very nice example to this. This is a thought experiment of two hypothetical twins. So suppose two twins, two brothers, one of them stays on Earth, the other goes on a spacecraft with the speed of light. Now Einstein said that there are two brothers, so this is a picture when they are departing, the same age, but when this brother who has gone into space comes back, he does not age much, but the one who has been on Earth has become old. So the concept of time dilation when you are moving or when you are in a different inertial frame, this is what Einstein had proposed in the 19th century. But a similar anecdote or a legend was quoted in Mahabharata and Bhagavad Puran ages before. There is this very nice legend of King Kakadumi. So Kakadumi was an emperor of the Surya dynasty, and he had his daughter. So the daughter was very, very beautiful. He wanted a proper match for the daughter, so he went to Lord Brahma himself. कि ब्रह्मदेव बताइए मेरी पुत्री के लिए suitable वर कौन होगा? And he spent 20 minutes in Brahmalok. When he came back on Earth, 16 Chaturyugas had already passed. So this is a legend which is quoted. Now the fact that 20 minutes in Brahmalok was equivalent to 16 Chaturyugas already passed on Earth, this kind of metaphorical reference of the fact that time is relative parameter, and that time for somebody who is going to Brahmalok with the speed of light, for that person the time will slow. So उसके लिए सिर्फ 20 मिनट बीते हैं, बल्कि जो धरती पर है, जो उस inertial frame में नहीं है, उसके लिए 3,24,000 साल बीत चुके हैं. So that concept of time dilation was already quoted in our scriptures ages before. That's my first analogy. Second is the concept of uncertainty. Now uncertainty is a very, very key or a profound concept of quantum physics, and it finds interpretations in Indian texts. This is a book called Yog Vashisht. This is Vashisht Rishi, a Rig Vedic teacher, and this is a creature by the name of Kak Bhushundi, a legendary creature who is also considered to be a time traveler. So Kak Bhushundi और Rig Vedic teacher Yog Vashisht के बीच के वार्तालाप, the conversations. Now Kak Bhushundi tells Vashisht Rishi that he has seen Ramayana 11 times and Mahabharata 16 times when he goes back and forth in space, and each time with a different outcome. Now this we are talking about alternate universes. Today we talk about alternate universe, parallel universe, multi-dimensional realities, but here a mythological time traveler says that every time he goes back and forth, he sees it with a different outcome. Now in quantum, we say that non-eigen functions, they produce probabilistic results. Now quantum में एक बहुत famous postulate है that if you have a mathematical operator and you operate it on a non-eigen wave function, every time you will get a different result. You will not get a accurate deterministic result. You will get probabilistic results. You will get non-deterministic results. You will not get the same outcome every time. And the same thing was being said, I mean, ages before in Indian text कि हर बारी कुछ नया हो रहा है. So the second evidence was this. The third analogy is the all-in-one concept of Vedanta. Now in Vedanta, in Upanishads, there is a central tenet, Tat Tvam Asi. You and me are all one. Brahma and Atma, they merge as one. That concept in the Mundak Upanishad also says that Brahm ev idam amritam purastat Brahm pashat Brahm uttarata dakshinata cha uttarata enam Brahm ev idam vishwam idam varishtham, which means Brahma alone is the universe, the supreme and excellent, and everything merges into the Brahm, the concept of all in one. Schrodinger said that the unity and continuity of Vedanta is reflected in the unity and continuity of wave mechanics. And in Brihadaranyaka Upanishad, there is a concept of Neti Neti, where Brahma is said to be neither this nor that. Neti Neti concept also finds a good correlation with the wave particle duality, where we say that light is neither a wave nor a particle. So, and the last analogy, I quickly wind up because I've been already given that this thing. The last analogy is Shiva's Tandav and the dance of subatomic particles. Now, Shiva's Tandav is the dance of creation and destruction. And the postures that Lord Shiva assumes while doing his Tandav has been considered to be the way to be the dynamics of how subatomic particles move. Now this is Higgs boson when it was bombarded in the accelerator at Geneva. This is the kind of dynamic motion we observed for the boson particle. And in the Tao of Physics book, Fridtjof Capra, who is an American physicist, he said that for modern physicists, Shiva's dance is the dance of the subatomic matter. And that is the reason precisely at the CERN Center in Geneva, at the European Center for Research in Particle Physics, a Nataraj statue, which is the dancing pose of Shiva, has been housed. So dancing Shiva of Indian mythology represents the cycle of creation and destruction, which is also similar to the dynamics of subatomic particles. Fridtjof Capra ने अपनी किताब Tao of Physics में लिखा है, when Heisenberg met Rabindranath Tagore, he said that introduction to Indian thought brought Heisenberg great comfort and great solace. In fact, like I said, 19th century में जब सब परेशान थे that what we are proposing, the world will ridicule us, the world will think of us as crazy, they refer to Indian wisdom, and that Indian wisdom inspired them, influenced them like nothing else. So concluding myself, philosophical and metaphorical interpretations of Vedanta, they closely align with the modern proposals of quantum, and that shows the kind of depth and the foresight Indian wisdom had. And in my presentation, I have drawn a few parallels. There are numerous, I must tell you, a few parallels between the key concepts of quantum mechanics and similar references in Indian scriptures ages before, and that which significantly inspired and influenced the Western world paradigm. And in the words of Einstein, when I read Bhagavad Gita and reflect about how God created this universe, everything else seems superfluous. So that is my bibliography, and thank you so much for your attention and time.
Thank you, ma'am, for your wonderful talk, and within time you have completed your presentation. So participants, if you have any query, you can discuss later on.
Thank you all the speakers and the chairpersons. May I now request Dr. Tulika to present the conference kit to Balaji sir. May I now request Dr. Ravindra Kumar to present the token of appreciation to Dr. Prakash Kanu. May I now request Dr. Neha to present the token of appreciation to Dr. Sandeep Kumar. We extend our heartfelt thanks to all the speakers and chairpersons for their insightful contributions. This session has undoubtedly generated sparks of innovative ideas and fruitful discussions among all the participants. With this, we conclude the rapid oral talks.
We request all esteemed guests and participants to proceed for lunch. You are all requested to come back to this hall by 2:30 p.m. 2:20 p.m. After lunch, the second technical session will be chaired by Dr. Ravi Verma, Dr. Ravi Kumar, and Dr. Neha Paras. It should be noted that all the poster and oral presentations will be taking place after Dr. Kartike Kumar's lecture, and the online oral and poster presentations will definitely start from 3 p.m. itself. Thank you. You may please proceed for lunch.
आध्यात्मिक वाले नैनो बंद करवा देंगे हमारे अब केमिस्ट्री वाले वापस फिजिक्स वाले हैं ये अब नैनो बंद करवा देंगे आइए सर प्लीज
मैं आपका मैसेज विनोद सर मैं आपका मैसेज अभी समझ नहीं पाई अब समझ आया
आप लोग हमारे नैनो बंद करवा देंगे
मैंने तो क्वांटम के साथ जोड़ा मैं तो नैनो में गई नहीं
फिजिक्स वाले सर ये भी आध्यात्मिक की तरफ जा रहे हैं सारे
मैम किसी को भेज रहा हूँ मैं
सामान रखा हुआ है लोगों का
उसको उसी में रहने दो ना।
जैसा आपकी हाँ पीपीटी वो तो मैंने व्हाट्सएप करी है ना ना देखो त्रिपुरेश तुम्हें दे रखी है उन्हें
मेरी स्लाइड्स भेज देना सर आगे।
हाँ हाँ भेज दी भाई
अच्छा उनकी ये फिर
हाँ भी मंगवा रहे हैं उनसे वो अंदर तो आ रहे थे सर चलो
सर मैं तो फिर ये
वो अच्छा जयदीप सर कहाँ हैं सर सबका मोबाइल से करना पड़ेगा चेयर अभी 2 सेशन चेयर गायब है हमारे अच्छा एक तो यहीं पे है सर आइए प्लीज अभी हम चलते हैं शायद 10 दिन बाद नहीं एक्चुअली सीधा मैं इन्फॉर्म करूँगा मैं भी वहाँ से भी सबके उम्मीद है हाँ इन 2 लेक्चर के बाद फिर हम आपको नैनो साइंस ले जाएंगे कुछ बच्चे सही है जिनका वहाँ पर है और जिनका यहाँ पर है उनका ही तो है ना
Welcome back to IKS-NANO 2024. We hope you had a pleasant lunch break and are ready to immerse yourself in the second technical session. This session will be chaired by Dr. Ravi Verma, Dr. Ravi Kumar, and Dr. Neha Paras.
Dr. Ravi Verma, Associate Professor SVT JNU, specializes in mucosal immunology, the gut microbiome, and transcriptomic biomarkers in cancer. Dr. Ravi Kumar, also Associate Professor at SBT, works on chromosome condensation in prokaryotes and the function of enzymes critical for bacterial survival. Dr. Neha Paras, Assistant Professor SCNS, has expertise in low-power VLSI design, semiconductor device design and modeling, and ferroelectric memory devices. This session will feature presentations by Dr. Jaideep Bhattacharya and Dr. Karthike Kumar. We now hand over the session to the chairpersons of this session.
Good afternoon, everyone. I hope you enjoyed your lunch. Now starting with the second session, I am going to give a brief introduction to Dr. Jaideep Bhattacharya, Assistant Professor in SBT School, JNU. It is my privilege to introduce an exceptional scientist and academic, Dr. Jaideep Bhattacharya. Dr. Bhattacharya earned his PhD in biotechnology from University of Calcutta and brings over 15 years of rich research experience in cutting-edge areas such as nanobiotechnology, biosensors, and single-molecule fluorescence microscopy. Currently, Dr. Bhattacharya serves as an assistant professor in School of Biotechnology, JNU, where he has made significant contributions to both research and innovation. In the past 5 years alone, he has secured 14 sanctioned research projects, published over 70 papers in prestigious journals, authored numerous book chapters, and earned widespread recognition for his work. Dr. Bhattacharya's accolades include the prestigious Alexander Humboldt Fellowship and the Dart Fellowship for PDF Research in Germany, as well as being recognized as a Dart Research Ambassador. Beyond academia, he actively mentors two innovative startup companies named BioNano Integra Healthcare OPC Private Limited and Bio Innovatic Life Science Private Limited, both incubated at the Rice Foundation, IISER, Kolkata. An inventor at heart, Dr. Bhattacharya holds over 10 Indian patents and 5 international patents, demonstrating his unwavering commitment to translating research into impactful solutions. So we are thrilled to have with us today, and we hope his insights will inspire and enrich our discussions. Please join me in welcoming Dr. Bhattacharya.
Hello. So I hope I am audible. So thank you for the nice introduction. So I think mic will not be required. Can I speak in front? And I think don't you can have the mic. I have the voice that from last bench they can hear. I hope you can hear from me. Yes. So don't take a mic. So thank you for inviting me and for the wonderful introduction. So I didn't thought that the introduction will take so long. So anyway, so I will now try to describe or mention about the work we are doing in our lab. So the title is various applications of nanotechnology. So I mostly work on applications. So applications of nanotechnology. That is interdisciplinary with that works with physics, chemistry, and biology both. So nanotechnology is a subject that where you require all of them together. So I try to amalgamate them and make it in a single box. So the work is that we use nanotechnology for drug delivery systems. We use affordable technologies to bring the large scale or bigger size instruments to point of care devices. I also fabricate devices so that we can bring or take the devices to the point of care services at the end users, so that you don't have to bring the samples to your lab. So if the lab can go to the site. So that's the idea of it. And also fabrications and for the diagnostic tools to make the tools in such a way that it is easier, user friendly. So reduce the complexity of the systems to simpler systems. So first I will like to talk about the drug delivery system that we developed in our lab. So we have more, but I just focus some of them. What are the problems? So today the discussion is about our previous knowledges that we had. But most of the materials that we had have a hydrophobic nature, and it's very hard to deliver inside your body. And these are the most problematic drugs, the class 2, class 4 and class 3. So this type of drugs, soluble drug, high permeability, you have no problem. You can administer the drug, and any type of administration, it is fine. But if it is hydrophobic, so it will go inside your body and it will precipitate out in your body. So how to accommodate this type of drug materials inside your body so that it goes inside your body, stays inside your body, and also delivers the drug at the target site at a maximum dose. So just think of some example that you take paracetamol once you have fever, 600 milligram or 700 milligram. Why do you take 600 milligram? The requirement is only few nanograms. So you take because all of your body, even the antibiotics, you take 750, 650 milligrams. Why? Because the whole body, the drug will be distributed, but a certain percentage will go to your target site. That is sufficient, and that should be nanogram level. That should be more than your IC50 value of the drug. So now the amount of drug that is keeping the load to your kidney, liver, everywhere, and side effects are there. So we wanted to reduce the dose so that you can take nanogram level, you can deliver the drug at the site, and it acts in a nanogram level and it is curing at the site. So that's main concept of targeted drug delivery or drug delivery systems or development of drug delivery systems. So the drug delivery vehicles should have some certain characteristics. The characteristics means it should be non-toxic, it should be biocompatible, it should be absorbed, it should be cleared from the body. These things, many go to in this. So these are the materials that are generally used for drug delivery vehicles. So drug delivery vehicles, you see that the drug delivery vehicles can be used as liposomes, lipid-based vesicles, dendrimers, nanomaterials, magnetic nanomaterials, spions, everything can be used as a drug delivery vehicles. And the attachment of the drug or encapsulation of the drugs will be different depending on the material that you are using. So we generally focused on liposome-based delivery vesicles. Liposomes are different kinds of lipid vesicles. It's a bilayer. It mimics the cell membrane that you have in your body. So micelles are there. That's a monolayer, but we focus on liposomes. The advantage of liposome, it is having a bilayer, and this kind of bilayer structures, inside is hydrophilic and outside is also hydrophilic. And once they are hydrophilic, both of them, you can encapsulate both the dual drugs in this hydrophobic membrane, as well as you can put some drug inside this hydrophilic core. So that's an advantage. Dual drug delivery system, as a dual drug delivery system you can prepare. And there are several kinds of vesicles. So large unilamellar vesicles, medium unilamellar vesicles, giant unilamellar vesicles. These are all types of vesicles that you can, multilamellar vesicles you can use. But mostly people uses this SUVs, that is small unilamellar vesicles, because they are stable inside your body. So how much stable it is inside your body? It is stable for 2 to 3 hours inside your body only. Still, it gives you the time 2 to 3 hours in the circulation system so that it can reach the target site. Okay? So the preparation is simple. Preparation that we do the process of exfoliation. You take the lipid in a solution, in a round bottom flask, dry it up, and then you just add hydrophilic solvent, hydration, rigorously shaking, and then you do extrusion. You need some, because at the very beginning it forms this kind of multilamellar stacking. So you have to remove this stacking one by one, and so that you get bilayer. And for that you need energy. And for the energy, either you give heat energy or you give sound energy, or you can give other types of energies also. Even heat energy is not only heating. You can do freeze-thaw cycling also. They also exfoliates and gives you single bilayer structure. So this is the mechanism. So we encapsulated, we prepared the liposomes, we encapsulated anti-malarial drug. You have heard about artemisinin. Artemisinin is an anti-malarial drug, and the problem that we generally do not take directly the artemisinin. We take the derivative of artemisinin, which is water soluble. The standard artemisinin is not water soluble. For that, we had to conjugated, and this chemical conjugation or chemical modification is not cost effective. That's why the price of the drugs goes increasing. So that's why we found, we thought to just encapsulate, if we can encapsulate the original artemisinin inside this liposome, what will happen? And we successfully encapsulated, and okay, there was some error. So we also prepared drug delivery vehicles, nano emulsions. Emulsions, you know. So emulsions, generally if you mix oil in water, you get emulsion. But emulsion can be also used as a drug delivery agent. So we prepared double emulsions, and we restricted the size in the nano size so that we can encapsulate both hydrophobic and hydrophilic drug in the emulsions. So we have prepared oil in water in oil, and also water in oil in water. So there are two types of double emulsions that we can prepare. Do you see the emulsions? You can see the 10 images of the emulsions. So here you can see the cores and the outside. So the double emulsion formation, and the size is in the range of 70 to 80 nanometer. So the 70 to 80 nanometer in DLS means it comes to 30 nanometer in 10 or 7. Also we have used this drugs which are known as anti-analgesic drugs. So we have used analgesic drugs here, so that the type of these drugs are known as painkillers. So you use painkillers, and these painkillers are hydrophobic in nature. And for that, we have encapsulated in this nano emulsion, double nano emulsion, and we have shown the activity has been increased 50 to 100 times. So also, what I mentioned, the circulatory time of liposomes are 2 hours. This nano emulsion is 1 hour. So if you want to target in some inner core of your body, you need at least the circulatory time of 6 to 7 hours. And that's why we have changed our delivery vehicles, and we have come up with the synthetic polymers. So here we have used polycaprolactone as a synthetic polymer, and we have prepared the nanocapsules and nanospheres, and this is the process where we prepare, how we prepare the nanoparticles. It is known as nanoprecipitation, and we can prepare the nanoparticles which are also in the range of 100 to 110 nanometer. And the good part of this thing that I was trying to mention, that with these materials now we can modify the surface, we can functionalize the surface, so that it goes to the target site where you just require it. So it's not all over the body, but at a certain time points it will accumulate at the target site. If it is lungs, you use some markers that is expressed in the lung cells, you use some markers in the kidney cells, and then you get this drugs targeted and localized at the target site. And after the time of their lifetime, so lifetime 6 hours, within 6 hours they will all burst. So if it reaches your target site within 6 hours, then you have ample time so that it can circulate in the circulation time and go to the target site. But liposomes has lesser circulatory time, so we try to avoid the liposomes. Another thing, all of them are closed vesicles. Here we have used planar vesicles, planar lipid bilayer structures, which in the form of nanodisc. So planar lipid bilayer structures are not stable. You cannot stabilize in the solution. So we have prepared a nanodisc, a special kind of planar lipid structures, which is surrounded by the hydrophobic coat, and this is known as nanodisc. So this is the smallest possible planar lipid structure. And the advantage of this planar lipid structure is that this is surrounded by the protein, and this lipid structure, the drugs, is open. So inside the core, what happens? The drugs are encapsulated inside in the liposomes of the polymers. Here the drug molecules are open, so body parts can see the drugs. So that's the advantage of this freestanding planar lipid bilayer. So here we have, you can see the nanodisc formation. This is the belt-like structure, and the lipids are here. So if it is not formed, then the belts are like this, closed belts. It's not an open belt. So once it is open belt, that means the lipid bilayer structures is embedded inside. And we can incorporate, we have shown that we have incorporated successfully cabazitaxel anti-cancer drug, and the dose can be reduced. Dose can be reduced to 1/3 or 1/10. So like this, it can be used. So everybody of us, we know about transformation, transfection, nucleic acid isolation during this COVID. Once there was boom of this kind of technologies. We also have one. So we have developed one magnetic nanoparticles that can extract the nucleic acid faster than any other medium. And all the other medium requires a column. So at the end you have to separate through the column. Our technology does not require any column. You can directly separate it out and you can run the PCR. Why? So we have generated the magnetic nanoparticles that is very much smaller in size, 40 nanometers. So if you go to the companies, other companies, they have the particle size 400 to 600 microns, the standard companies that we have. And we have smaller nanoparticle 40 nanometers. The other companies take 1 to 1.5 hours to take out, extract all the nucleic acid. Here it takes only 15 minutes to take out all the nucleic acid. So the surface area is high, magnetic property is 80 EMU, that is others have 40 to 60 EMU, and that's why. And another thing is that is the key part, that for these particles PCR cannot be done in presence of the particle. So you have to take out the particle, you have to elute and then go for the PCR. Here the PCR is possible even with the particles. You add in the PCR mix, the PCR will be done. So these are the particles and characterization. These are all spions, and then you can see that the nucleic acid can be extracted, and in the gel we can show that all the nucleic acid has been extracted. So another is that we have done in presence of this particle the PCR also, and you can see that the PCR can be done. So that's what I was mentioning. So with others it cannot be possible. So transformation is a process everybody in biology does for insertion of plasmids in bacteria. But for this you require competent cells, and you have to store the competent cell, and once you want to do the transformation, you see that the competency has been lost. It happens. So we thought if we can remove completely the competent cell preparation. So you take any growing cell, use some vector or material, tag it with the DNA, transfer it, and we have done it like this. So we have completely omitted this step, so no competent cell preparation is required. You just required cell culture, secondary culture is required. You take your plasmid with our magnetic particles, put it in your cells, and you get the transformation 10 to the power 8 to 10 to the power 9, which is more than the normal transformation efficiency. So you know about kidney failure patients, they have to go for dialysis every day. So that's a huge problem. So they have a load, but their lifestyle is hampered. So we thought, can we do something that diabetes patients also take everyday insulin, and they are working and they don't have to spend time in the dialysis centers. So can we prepare something that dialysis in your body and go out from your body, and you don't have to go to the dialysis center? So we have generated this kind of particles, which is mesoporous particles. Those have pores, and that can take out urea and creatinine from your body. So that can take any small molecules. It's not specific for urea and creatinine, and nothing is specific. So the normal in the dialysis center also there is no specificity that will take urea and creatinine. So that will take everything. So any small molecules, and that takes also the proteins also. Most of the proteins that we have in our body, that is 5 to 6 nanometers. So we designed these particles having the pore diameter 2 nanometers. So the proteins will never go inside these particles. So only the small molecules have a smaller size distribution will enter the particles. And we have shown that these particles can take out urea, creatinine and small molecules, and it can reduce the creatinine and urea level in your body. And to accommodate more and more material, we have made these particles hollow inside also. So that chemically we did after formation of the particle. So you can see that it can take out from urea and creatinine, and recently we got the granted patent also for this one. So I also work on biosensors, optical biosensors and electronic biosensors. We fabricate chips. So today I will discuss about the optical biosensors, where we Raman scattering, everybody of us know. So Raman scattering, but the problem with the Raman scattering was it was not bloomed before the invent of the nanotechnology. Raman scattering, the spectrometer is there in IKS, you can go and see, but till the nanotechnology has bloomed, the Raman width is the signal is very low. So as the signal is very low, there are no detector that it can just detect this Raman signals. But with the advent of nanotechnology, what happens? If there is anisotropic structures, it increases the signal. So that is known as the enhancement of the signal. So the enhancement can be 10 to the power 8 to 10 to the power 10 times, even 10 to the power 12 times. So now a very small signal can be enhanced in such a way in the vicinity of the nanoparticles that you get this Raman scattering, which is known as surface enhanced Raman spectroscopy. And with the surface enhanced Raman spectroscopy, the signal can be enhanced in such a way. So here we have fabricated this kind of dendritic silver structures, which is the dendritic structures, as I mentioned, anisotropic structures, dendritic structures have more signal enhancement. So with this dendritic silver structures, we have shown that we can detect up to femtomolar concentration of any analyte, and even one single bacteria can be detected. So we can detect one bacteria, we can detect femtomolar concentration. So that is the sensitivity of this kind of surface enhanced Raman spectroscopy. So PCR we know, the PCR we can design PCR and during the COVID all of us came to know about, even not the biologist, every physicist, scientist, everybody know about PCR. That it enhances or increases the nucleic acid sequences and then finally we detect it. So the PCR, the problem with the PCR was that the sample was coming and the PCR was, the time takes around 1.5 hours to 2 hours. Because you have to always go for this step and there is a heating block that changes the temperature time to time. Now if we can just make 3 temperature zones and the droplet can be moved on this PCR zone, then the PCR will be faster. You don't have the ramping time to change the temperature of this heating block. So we designed like this. So you can see previously there was a heating block. The temperature of this heating block, Peltier heating block was changing. Now what we have done, we have made 3 temperature zones on a chip and it is on an equilateral triangle, and you know in during class 8 and 10 geometries that the circumcircle always passes through the vertices of the equilateral triangle. So the simple idea is that move the droplet from the vertices of the equilateral triangle, stop it there at different points where the PCR has to be done, and then you get the PCR products. And this PCR can be done in 20 minutes. It does not take 1.5 hours because there is no ramping time. So the change of temperature does not require. So these are the softwares and other things we have prepared. Already these are the prototype has been done. Even now we have come up in the idea. You can see that this flag, you can see that it is just moving and it will just move at different time points and it will stop at different positions. And a magnet is placed at the bottom and the droplet is moved using a magnetic nanoparticles on a frictionless surface. So we have coated the surface with a Teflon and now this can move on the surface. Here you can see the droplet is moving like this with the magnetic nanoparticles. The whole droplet is moving. So like this we can move the droplet and we can do the PCR. You can see. And at the desired points it stops and the PCR cycle is running there. So we can do the PCR and we can see that even we can drop down the time to 15 minutes. Even from 1 copy number also we can do the PCR. Also we have gone one step further with this system. So here the complexity is that moving of the droplet. So once we went to the market or to the end users, there were problems in creating this droplet and moving this. So we omitted this delivery. So now we have micro heaters. So these micro heaters, now they are arranged in this arrays, and now each micro heater can be cycled. The good thing with these micro heaters, as they changes the temperature very fast. So that takes only few milliseconds to change the temperature from one to other temperature. And there also we can achieve exactly with the fidelity of the enzyme. If your enzyme can just amplify a nucleic acid at 40 bases per second, then in 6 minutes 240 bases can be polymerized. So it exactly matches with the fidelity of the enzyme, and you don't have to run for 10 seconds, 15 seconds, only 6 seconds is sufficient. So like this, even we can reduce 12 minutes, not 15 minutes, even below that. So even we can, we have tested with different samples, patient samples, and we got 100%. So another thing that I want to discuss here, that most of the biologists, we know that we have to synthesize proteins. So in everybody's lab, some of the, or none, everybody is working with proteins, and they have to develop recombinant proteins. So while the recombinant protein production, you take a plasmid, you put it in some strain, E. coli, DH5 alpha, You amplify the plasmid, take it out, put it in a BL21 expression vector, then you get the expression. And then also most of the time it goes to inclusion bodies, you take it out, and the yield is less than 1% sometimes. So here, we try to omit all these steps. You take a plasmid, you put it in a solution that we have prepared, and you get your protein in 1 hour. So rather, it was taking 1 month to get the plasmid to protein. Now, we have synthesized a cell-free system. This cell-free system works that everything is inside, it is inert, it is in a frozen condition. You activate it, you put your plasmid, activate it, and you get your protein in just 1 hour. And how much do you get the protein? You get the protein where the fluorescent proteins can be seen in naked eyes. So you can see the GFP and MCD expression in naked eyes. You don't have to go to the fluorimeter to check the fluorescence. You see the band, and we have also shown that all the structural intactness of the proteins is there, still there, and it is also working with Western blotting, so the structures, epitopes, everything is there. Even from this prokaryotic system, now we have moved to eukaryotic system. We can see the glycosylation pattern also in the eukaryotic systems right now. And the amount is around 3 gram per ml of our solution. In general, people require 10 liter culture to get 3 gram of protein. We get 1 ml of our solution gives 3 gram of protein. So that is the thing, and we also received a big grant for this one, for which we have developed this bioinnovative company. That's all. Do you have any questions?
Yeah, if anybody has any questions, thank you sir for this wonderful talk. Any questions from the audience? I think no questions are there.
One question, the protein that in the testing system. So have you commercialized?
Yes, we have started commercializing. So we have sold to several academicians. So now we are in contact with some companies. They want in 1 liter. So 1 liter for that we require at least 40 liter, 50 liter culture. So at the back end we also are working with the culture, but you don't have to do. We do it, and we prepare some self-free system which is just at a frozen condition, that these are freeze active, means activity wise they are freeze. So once happens that you put your plasmid, they only seize your plasmid, and so for 1 liter culture we require 10 liter to 50 liter culture. So now with this big grant we have received a grant to buy a fermenter. So in a couple of months we will purchase a fermenter of 10 liter, and then we will go for this. So we have tie-ups and we have sold, and even recently some paper has been accepted by some faculties who have used our product, means purchasing our products. So that will be.
So any kind of protein can be synthesized, or there is a limitation of size?
So till now, whatever we have done up to 240 kD we have prepared. So 10 kD to 240 kD, it's a broad range we have synthesized, and they are working. And the good thing is that no inclusion bodies, because the inclusion bodies are prepared once the foreign particles is generated inside your small cellular confinement. But it's an open system. So that's why there is no inclusion bodies. All of them are in the solution. So one step, and that's why we can have a higher rate.
Protein can be from any system.
If you have any other protein systems, it will be better if it is protein optimized in the bacterial system, or for the bacterial system with the bacterial promoter you can put it, and we can produce in the bacteria. Fungal proteins with fungus I haven't tried, but we have tried for different proteins which are of fungus origin, mammalian origin, bacterial origin in this bacterial system. They have cloned it with a promoter operator of this plate or PVAD. Then we can put it here and here.
Just one question. How economical it would be to produce here, or deal with directly the conventional way of doing it for the eukaryotic proteins?
For the eukaryotic
proteins, if I want to purify in CHO system.
Yes, so we have mammalian system. That is at the back end we use CHO system, CHO system. So now for you, if you require large scale, so it's better that you produce in your CHO system. once everything is standardized. But many times you require to just modify the sequence and see that whether the yield is codon optimization, some mutation study, everything. So then this is a better system because you purchase 1 ml and you are done. And even nowadays the companies who are working, so they all the way they don't prepare this kind of proteins. What happens? They you have an order of 5 milligram of protein of this one. They have all the stocks. Now they have to start from the scratch again to grow the cells, purify everything. So here, if they have 5-10 ml of our material, they can produce put the plasmid, and readily next day they can deliver. Otherwise, they have a delay of 1 month because they have to start from scratch, from the bacterial cells.
Thank you for this excellent talk, sir. Is there any other questions from the audience?
Thank you, sir. May I request Dr. Faris to please present a memento to Dr. Jaydeep.
अच्छा आगे हमारा भी कैमरामैन आ गया अच्छा
The next talk is by Dr. Karthikeyan.
Yeah, so I would like to invite Dr. Karthikeyan Kumar. He has done his MSc from Delhi University, and yes, and Dr. Karthikeyan has completed his PhD in organic chemistry under Professor SMS Chauhan in the area of metallocyanins and ionic liquids. So he has published almost close to 19 articles, and he has also co-authored undergraduate chemistry books. Interestingly, he has not chosen the normal path of moving towards academia or company. Rather, he was more interested and joined the patent office, and he is currently working as a assistant controller in the Indian Patent Office. And to further maybe sharpen his skills, he has also carried out another postgraduate in patent laws from NALSAR University in 2022. So with this brief introduction, I would invite him for the talk today. Thank you.
Thank you, Dr. Ravi, for such a nice introduction. And thank you. First of all, I would like to thank the IKS committee for giving me this opportunity to discuss with all of you. Here, I think some faculty members are there and some research scholars are there. So, in previous lectures, what we have seen is that the academicians have shown their works, what they are doing, how they are contributing towards the society, and in my lecture, I will just focus on some specific topics, some specific strategies which you can adopt to protect your invention, to protect your research works, so that cannot be copied by another one. So, as the theme of this seminar is the Indian knowledge system, so I will start with the traditional knowledge. Before that, I will just give some brief about the patents and what is the intellectual property. So I think nowadays intellectual property is so much familiar with each and everyone. Everyone knows about the intellectual property, what it is, how we are going to protect, and how we are going to get some monetary benefits from this. So as there are so many definitions for intellectual property, but in general sense, we can say that the creation of minds, whatever we are getting, whatever we are creating through our mind, that may be called as intellectual property. So there are 7 different branches for intellectual property, but as the time is very less, so I will just focus on some specific branches of intellectual property that is relevant with the theme of the present seminar. So as we all know that patent is nowadays the requirement that is required for getting some promotions, for getting some jobs, and without that saying that we can only get some promotion on jobs based on the patents, we can also use that like our immovable property. We all know that what is our immovable property. We buy some lands, some cars, anything, but we don't think much about the our intellectual properties. So patent is basically a right which is being granted by the different offices of the world to the contribution to the inventor of that invention, so that he can disclose his invention before the offices. So patents is a territorial right which is given to which is being granted by different countries to the inventors, and for getting your invention protected in different countries, you are required to apply before their patent offices to get your invention patented. So I think everyone is now familiar about the patents and what we can achieve by getting a patents. So there are certain requirements which is being imposed by the governments, different governments of that relevant countries. There are some common requirements which is being adopted by all the countries, that is called novelty, inventive step, and industrial applicability. So what you are required to get a patent is that your research work should be novel. It should not be copied from any other's work. It must be novel, and it should not be disclosed in any form. That means not only in written form. It should not be disclosed in communities. It should not be disclosed like in videos or in. It should not be disclosed in methods that are being adopted by different local communities. So it should be novel enough to prove your research should be novel enough to be proved that yes, you have not copied someone else's invention. So in India, we basically check the absolute novelty. There is two different definition is there for novelty. One is absolute novelty and one is just common novelty. For absolute novelty, each and every elements of your invention, like if your invention comprises of 4 parts, like if you have come up with this certain pen, it may have the refill, its body part, its cap. So each and every element of your invention must be disclosed in a single document. It should not be disclosed in the mosaic of documents. So in India, we basically adopt the absolute novelty. It should be disclosed in single document. And yes, of course, if your some parts of your invention is disclosed in one document and another parts of your invention is disclosed in another document, so your invention just passes the novelty requirements. So I think what we are facing, we are just seeing different types of inventions. We are just acting for the grant of your invention. So when we examine your inventions, so mostly almost 95% of invention passes the novelty criteria. So it's good to see that yes, nowadays researchers and the scientists are doing such a great job that they are not copying. They are familiar with these works. The other requirement is the inventive step. So for determining the inventive step, what offices do is that they are combining the features of your invention with different documents. So your invention should be capable enough that yes, by combining the features from different documents, it should not be obvious that yes, you have copied one part from one document, another part from another document, and you have just combined for the same use. It should not be like that. And third requirement is the industrial applicability. That is very small requirement, that your invention should be capable of being used in industry. Because if government offices grant a patent, it assume that you will just make it commercialized. You will not just keep it like a piece of paper. Sometimes most of the academicians are just doing that. Yes, we have get a patent. Now we have kept it as aside, like our research papers. It is not assumed that you will just use it as a piece of paper. You will commercialize it, and there is a requirement that yes, every 3 years you will just submit a Form 27
that is the commercial application. You will show that yes, you have commercialized your invention for the betterment of the society. That's why the government is granting you patent. So as I think I have discussed the every requirements for getting the patent, so we will move on the traditional knowledge. So there are different definitions for traditional knowledge, and in the common sense we'll say we can see that yes, traditional knowledge is mostly the knowledge which is being passed from generation to generation. That is mostly that may be in any form, like Ayurvedic systems. India is a rich culture, and we in each and every parts of this India we can see different types, different mediums of getting some crops, like some products like Banarsi sari, or each and every part produces some unique products. So these all are known as the traditional knowledge. These are covered under the domain of traditional knowledge. And WIPO, which is the World Intellectual Property Organization, it also recognizes our traditional knowledge. And recently WIPO has covered that in Paris, in convention, in different types of convention, that the invention which are being based on the traditional knowledge should not be granted a patents or any other intellectual property. So moving on the different domains of traditional knowledge, that may be divided on the like agriculture. There are in different parts of the country, our farmers uses some traditional way for getting their crops. They are using some traditional way to harvest their plants. They are using bioorganic plants to obtain that compost. They are using some specific techniques. So all these type of techniques are the inventions which is our traditional knowledge, and that must be protected. Traditional knowledge belongs to a community. However, patent belongs to a single person, or it may be we may say that it belongs to a company or a single university. So there is a difference. There is a borderline between traditional knowledge and getting it patented, getting a patent for this. If we preserve our traditional knowledge, then the whole community is getting benefited. So how we can protect our traditional knowledge and how we can protect our traditional knowledge? India has adopted the another branch of intellectual property, that is called the geographical indications. So as of now, today, Indian Patent Office has granted 643 GI tags to different products of India belonging from different states, to recognize the rich culture, to recognize the rich products of different tastes, different odors. So if we grant patent for those products, so only one person will get benefited. If we grant GI tags for those products, whole community will be get benefited. So what we are required is to just separate the traditional knowledge as well as the invention, which we can get the patents. So why traditional knowledge is important for us, why we should not get it patented, and if someone is coming with some advancement in that traditional knowledge, that may be, that must be also benefited. So we are required to just provide a balance, check and balance, to protect the traditional knowledge, via that maybe via patent or trade secret or GI, and the inventors who is just providing the improvement to that traditional knowledge. So we are required to see the balance, and India is absolutely just drafting different laws to protect the traditional knowledge as well as the benefits, the share of the researchers. So we'll move on. What are the just challenges in patenting the traditional knowledge? So as I have already discussed, that for getting a patent you are required to buy so that your product is novel. If your invention is based on this traditional knowledge, that may not be in documented form, because that may be the routine practice of some communities that is not written somewhere. But we check the absolute novelty at Indian Patent Office. If we get a single piece of information that yes, it was available in public domain in any communities, if we get to know, your novelty will be destroyed, and we just object that yes, you are required to prove that your product is novel. So you are required to show that your product is novel. And one other problem is risk of biopiracy. What is biopiracy? Biopiracy is basically the misuse of our traditional knowledge. We can, in simple language, we can say that it is the misuse of our traditional knowledge, which is available in our public domain, that is being copied by some other person because it is not in documented form. They are coming in our communities. They are just learning our techniques, and in their countries they are going and they are copying and they are getting the patent for that. I will just discuss some examples how it was happened and how India has objected for that patents. Another problem is that yes, if you are coming with some improvements of the inventions which are based on TKDL, traditional knowledge, and you are required to prove the inventive step, which is very rigid in India. We are required to show the obviousness, we are required to show the technical advancement, and you are required to show that yes, it has economic significance also. In other countries, inventive step determination is light as compared to India, but India adopts a rigid technical inventive step examination process. Another that part that is being introduced in 2005 in Indian Patent Act, that is the section 3. That is different from all over the world. We have India has introduced this section 3 to restrict the misuse of evergreening, to restrict the use of our traditional knowledge. And one section, that is section 3P, is related with the traditional knowledge, which is relevant with present theme of this conference. It says that anything which is available in the traditional knowledge that cannot be patented, even though if you simply you just fulfill the requirements of novelty, inventive step, industrial applicability. But if your invention is based on the traditional knowledge, you are required to prove that yes, it is not based on that. If it falls under this category, even though you fulfill the requirements of novelty, inventive step, and industrial applicability, your invention will be rejected solely based on this ground. So India has adopted a rigid system for just to restrict the others for copying our traditional knowledge. Yes, as I was just discussing that what is biopiracy, and I have said that yes, it is the misuse of our traditional knowledge. So there are 3 case studies which is related to the biopiracy. I can discuss it here. First example is the neem. We all are familiar with the neem. All parts of this plant is being used in India, either in any form, like medicines or antifungal, antibacterial. Every part of this plant is being used in India. In 1990s, US has granted a patent to a US company for the invention that neem oil has the antifungal property, and it can be used for to cure the fungal infection of plants. So in 1990, they have granted the patent to a US company, and it come to the knowledge of Indian government, and Indian government has strongly protested against this grant. And it, through the litigation process, it was being proved that yes, it is already available in our traditional knowledge that it can be used as antifungal plant, neem oil. So by the with the protest of Indian government, the patent which was granted to a US company was revoked. Another example is turmeric. Again, in US, they have granted a patent to turmeric for the wound healing. We all are familiar that बचपन में हमारे पास घाव लग जाता था तो टर्मरिक ही लगाया जाता, सबसे पहला फर्स्ट स्टेप। यूएस has granted a patent for this. Again, a single chemist, that is Dr. Ramanujan, and with the help of CSIR, India has shown its protest to US, and that patent was also revoked. Similarly, basmati rice was granted a trademark in US and EP, and with the protest of India, it was being revoked. So when we are just talking about our traditional knowledge, it's our responsibility being a government, and it's your responsibility being a citizen, researcher, academicians, to just be familiar with what is happening in our territories. What they are, either they are copying our research, either our culture, they are coming and they are copying our culture, our traditional knowledge, and getting in their countries they are getting benefited. So it's everyone's responsibility to be familiar, and if something comes in our knowledge, we must show our protest. So there are some legal and ethical barriers when we are just discussing about the patents part based on the inventions based on the traditional knowledge. So if you are coming, being a researcher, being a scientist, if you are coming with the patents which is being based on the some information of some communities, some their practices of their community, it's your responsibility to share the benefit with that community so that they may be equally benefited and they can equally grow with you. And of course, India has just in 2002 passed the Biodiversity Act. With help of that, National Biodiversity Authority has been established, NBA has been established, and they are continuously just monitoring the which type of patents are being granted. And if you are utilizing the biomaterials from India, that is that may be from regional, any Himalayan region or anything, you can be simply, if you are discussing about Ayurveda, mostly the herbs and subs are coming from Himalayan region. So office object that yes, you are utilizing the biological material from India, you are required to get the NBA permission certificate. If we forget sometimes that yes, they have clearly drafted that patents, then NBA itself sends a letter that yes, they are utilizing our biological materials and NBA permission is required. And being an applicant of any patent, if you are approaching to NBA for getting their permission certificates, they will just sign a bond with you on affidavit that yes, some percentage of your benefit, what will you will earn after getting the patent, will be shared with NBA, and they will share with that community. So India has adopted has just changed its law to benefit the researcher as well as the communities from where you are just getting the information from, you are getting the products from there. So if we will just discuss the nanotechnology in traditional knowledge, so I have just got us one example of the Damascus steels. It was previously used in the swords of our kings. So nanotechnology is not the just the domain of this era. It is being used traditionally. So nanotechnology plays a crucial role to just define the traditional knowledge and provide a recent advancement in your invention so that you can benefit yourself as well as to that community. So we'll move towards the nanotechnology in the field of patents. So as all of we know that nanotechnology has a diverse role, it has a numerous application in different fields, but as my topic is to related with patents, so I have tried to focus the nanotechnology, the inventions which are being used, which can get patent in India based on the nanotechnology. So I have just selected some of the fields, that is healthcare, that may be some, you are coming with improvement in our Ayurvedic medicines, agriculture, right? Yeah, okay, I'm just, so different fields that we have covered, I have tried to cover. here, environmental consumption. Uh, what is the advantage of getting nanotechnology based traditional knowledge inventions? So if we'll just focus on the invention which are based on the traditional knowledge, so we can see that yes, our suppose turmeric was being used previously being used as 1 gram. If we come with the nano formulation of turmeric, you are required to only nanoscales in your body. So nanotechnology has just improved the our rich cultures, and with the collaboration with TKD traditional knowledge and nanotechnology, yes, you are doing excellent job to benefit our communities. Uh, there are some examples of invention which are being based on the traditional knowledge as well as nanotechnology. So recently you can get the turmeric nanoparticles, ashwagandha nanoparticles, which have been granted patents in India, and they are being commercialized nowadays. So when you come with the nanotechnology and TKDL, you just provide some research, you just provide the documentation which is being required to prove the novelty. You are doing research, you come up with certain documents, and yes, you just pass the novelty criteria which is required for getting the patents. Ethical concerns I have already discussed. One more important thing which I will try like to discuss here is that what India is doing to protect its traditional knowledge. In India has just formulated a traditional knowledge-based digital library, which is available, which has been available freely with all over the world to every patent offices of the world, so that they can check that yes, their invention is the part of the traditional knowledge which is available in India. Another is GI. I have already discussed that yes, we are offering the GI to those communities who have their rich cultures. Biodiversity Act, I have already discussed that yes, in 2002, Biodiversity Act was initiated to get the benefit sharing between researchers and the communities. Yes, I was discussing the products which are based on the recent advancement with the with the help of nanotechnology and traditional knowledge. This is you can see here that nanocurcumin is available in the market. It is being patented. Nano ashwagandha is available in the market. It is being patented. These are being actively commercialized in India. And for the liposomes, in previous sessions, we have heard so many things and we have discussed in detail. So I will not touch this topic. Thank you.
Any questions? Thank you, Dr. Karthik, for wonderful and informative talk on the patent. So now house is open for the question. Any concern related to the patents or anything?
I'll speak. Okay. I'll speak. Sir, I just wanted to know हल्दी का जो भी केस हुआ था उसमें वो चीज़ बाद में रिवोक हो गई थी. इंडियन गवर्नमेंट ने रिवोक कर लिया था. वो इंडियन गवर्नमेंट ने उनको बोला था देन दे रिवोक दैट टर्मरिक वाला पेटेंट. बट आई वांटेड टू नो एज अ सिटीजन ऑफ दिस कंट्री हम लोग मल्टीपल चीज़ें देखते हैं, तो उस सिचुएशन में हमें कौन सी अथॉरिटीज़ को मतलब टारगेट करना चाहिए, पूछना चाहिए कि हम इस चीज़ को मतलब प्रिवेंट कर सकें, सो दैट वी कैन प्रिवेंट कि हमारी कोई भी चीज़ इस तरीके से कोई भी ट्रेडिशनल नॉलेज को कोई अपने बेनिफिट के लिए ना, मतलब कमर्शियल बेनिफिट के लिए ना यूज़ करें. वो जो चीज़ गवर्नमेंट ऑफ इंडिया की है वो गवर्नमेंट ऑफ इंडिया के पास ही रहे. फॉर एग्जांपल अभी रिसेंटली आई वाज गोइंग थ्रू एक रील को स्क्रॉल कर रही थी, देन आई कम टू नो हम लोग इंडिया में पत्ते के ऊपर खाना, जिसे हम पत्तल बोलते हैं, पत्तल के ऊपर खाना इज़ वेरी नॉर्मल थिंग. बट इन जर्मनी दे पेटेंटेड इट और उसके ऊपर फिर दे हैव मतलब उसको पूरे तरीके से मीन्स बहुत ही अच्छे तरीके से कमर्शलाइज किया गया और उस तरीके से. तो एज अ सिटीजन ऑफ दिस कंट्री हम ऐसा क्या करें या कौन सी अथॉरिटीज़ को अप्रोच करें कि हम इस चीज़ को प्रिवेंट कर पाएँ?
Yeah, it's a good question.
Sir, if I could just add
Yeah.
to that question, हमारे पास इतना सारा ट्रेडिशनल नॉलेज patent all of it, because like we know neem, we know turmeric, we know all of these are Indian knowledge base. So is there a wholesome way of just patenting it, just stamping it like trademark India, something of that sort?
या फर्स्ट ऑफ ऑल पेटेंट्स जो मिलता है किसी को भी एक सिंगल पर्सन को मिलता है। ट्रेडिशनल नॉलेज हमारा कम्युनिटी का है। अगर हम किसी को पेटेंट दे रहे हैं तो एक सिंगल पर्सन को देंगे, एंड दैट आल्सो बीइंग फॉर अ लिमिटेड पीरियड, दैट इज 20 ईयर्स इन इंडिया। 20 ईयर्स के बाद वो सबके लिए फ्री अवेलेबल हो जाएगा 20 ईयर्स के बाद। बट अगर हम जीआई देते हैं, जीआई टैग देते हैं, जियोग्राफिकल इंडिकेशन अगर हम किसी कम्युनिटी को देते हैं, दैट इज फॉर द लाइफ टाइम, एंड द होल कम्युनिटी इज बेनिफिटेड फ्रॉम दैट। उस रीजन की जितनी भी कम्युनिटी है, जो भी है उस रीजन में रह रहा है, वो उस प्रोडक्ट को सेल आउट कर सकते हैं विद दैट जीआई टैग। सो इन दिस सिनारियो जीआई इज बेटर एज कंपेयर टू पेटेंट। एंड फॉर योर क्वेश्चन, yes, there are certain associations is there, that is patent attorney association is there. You can write to CSIR, you can write to even Indian Patent Office, IP India website is there. But before writing you must be sure, आप रील में तो कुछ भी दिखाते हैं, but you must be sure that patent has been granted in any countries for that invention, for that TKDL based invention. You must be sure. अगर आप पेटेंट नंबर उसका प्रोवाइड कर रहे हैं, definitely Indian government will process, Indian government will do all the things. आपको केवल इन्फॉर्मेशन सबमिट करनी है। आप एसोसिएशन को दीजिए, एनजीओज को दीजिए, CSIR को दीजिए, इंडियन पेटेंट ऑफिस को दीजिए। वेबसाइट है ipindia.gov.in, आप सिंपली स्क्रॉल करके सारी इन्फॉर्मेशन वहाँ पे अवेलेबल, आप वहाँ पे मेल कर सकते हैं, आप इवन थ्रू स्पीड पोस्ट वहाँ भेज सकते हैं। बट यू मस्ट बी श्योर दैट यस पेटेंट हैज़ बिन ग्रांटेड। और अगर कुछ पेटेंट ग्रांट होता है तो उसका एक नंबर होता है, पेटेंट नंबर, आप उस नंबर के साथ मेंशन कीजिए। रेस्ट थिंग इज इंडियन गवर्नमेंट विल डू।
Okay, last question. Yeah.
So you said that patent must not be just kept with oneself; it should be used. But then, I mean, sometimes this might be inventor might himself be frightful. I mean, if he is bound to not only invent but also ensure that it is utilized, etc., and every three years he has to do some processing, it's an additional burden. So how rigorous is that, and what is the actual scenario? That because I think nowadays a lot of patents are coming, but then your criteria that they should also be commercialized, how much it is being followed? Can you throw some light on that?
बेसिकली जैसे हमारे पास जो भी पेटेंट्स आते हैं, एकेडमिशियंस के जितने आते हैं, मोस्टली दे आर डूइंग फॉर देयर करियर ग्रोथ मोस्ट ऑफ द टाइम्स। हाउएवर जब इंडस्ट्री की बात करते हैं हम, दे आर कमर्शलाइजिंग दैट प्रोडक्ट। देयर इज द डिफरेंस बिटवीन एकेडमिशियन एंड द इंडस्ट्रीज। फार्म 27 जो कि कमर्शलाइजेशन का रिक्वायरमेंट है, ये दोनों को ध्यान में रख के किया गया। अगर इन्वेंटर कुछ प्रोडक्ट इन्वेंट किया और दैट वो सोसाइटी के लिए बेनिफिशियल है, तो ये इन्वेंटर की रिस्पॉन्सिबिलिटी है कि वो सोसाइटी तक पहुंचे, बिकॉज दैट लाइफ टाइम ऑफ द पेटेंट इज ओनली 20 ईयर्स। अगर वो सोसाइटी तक नहीं पहुंचा पा रहा, रिस्ट्रिक्शंस, दे कैन सेल इट आउट। वो उसका आप सेल भी नहीं करना चाहते तो आप अथराइज कर सकते हो मल्टीपल कंपनीज को जो उस प्रोडक्ट में इंटरेस्टेड है, सो दैट आवर कम्युनिटी, आवर सोसाइटी में गेट बेनिफिटेड। उसको रखने से कोई फायदा तो है नहीं। तो देयर आर सर्टेन प्रोसेस, आप उसको सेल आउट कीजिए, आप उसमें लाइसेंसिंग कीजिए, आप भी मॉनेटरी बेनिफिट होंगे, कंपनी भी होंगी। एंड जो फार्म 27 की स्ट्रिक्टनेस तक सवाल है, तो अभी रिक्वायरमेंट है 3 साल में आपको देना चाहिए। मोस्ट ऑफ द टाइम्स हमारे एकेडमिशियंस नील करके देते हैं। वी आर कंसिडरिंग, वी आर कीपिंग दिस थिंग्स इन माइंड कि उनके पास टाइम नहीं है, वो लोग नहीं कर पाते हैं। बट यस, आप 2 बार 3 बार 4 बार नील कर रहे हैं, उसके बाद तो उसका टेन्योर खत्म हो रहा है ना, आपको उसके साथ लाइसेंसिंग तो करनी चाहिए। सो इंडियन गवर्नमेंट हैड पावर। अगर इसमें प्रॉब्लम ये है कि अगर आप नील करके दे रहे हैं और कुछ कंपनी या कोई भी इंडस्ट्री उसमें इंटरेस्टेड है रियली में वो प्रोडक्ट में, और आप उसको लाइसेंस भी नहीं दे रहे हैं, तो इंडियन गवर्नमेंट हैज़ द पावर इन द एक्ट, वो आपके पेटेंट को रिवोक कर सकता है, क्योंकि आप उसको ये कमर्शलाइज नहीं कर रहे हैं, और उसको फ्रीली दूसरी कंपनी को दे सकता है, फ्री ऑफ यूज।
Okay. Just last thing, it was about something that you showed related to eating, so I thought I'll just ask here. The nano haldi, nano curcumin, or nano ashwagandha, these commodities would go to every common man. So are they clinically validated that they are safe to use because nanoparticles can cross many boundaries in the body?
Yeah. Before getting it marketed any product हम पेटेंट देते हैं, उसके बाद आपको अगर मार्केटिंग करनी है उसकी तो आपको ड्रग रेगुलेटरी अथॉरिटी के पास परमिशन लेना पड़ता है, वहाँ पे आपको क्लिनिकल सर्टिफिकेट सबमिट करना पड़ता है, उसके बाद ही आप मार्केट में आ सकते हैं.
Thank you. I must say there is a many question still up, but we cannot take all. I think you people can interact with Dr. Karthik after this session event. He is available. Thank you. Thank you, Dr. Karthik.
Thank you for the inspiring talk, sir. May I now request Dr. Ravi Verma to present a memento to Dr. Karthik. Dr. Please. Thank you, sir. Thank you all the speakers and chairpersons. May I now request Dr. Balaji to present a token of appreciation to Dr. Neha Paras. May I now request Professor Satyendra sir to present a token of appreciation to Dr. Ravi Verma. May I request Dr. Tulika to present a token of appreciation to Dr. Ravi Kumar.
अब पता चला ना किसको मिला है.
We extend our gratitude to the speakers for their enlightening presentations and chairpersons for chairing the session. This session has certainly provided valuable insights and fostered stimulating discussions. With this, we conclude our second technical session.
Next, we proceed to the oral and poster presentations, which will be conducted in both offline and mode simultaneously. Oral talk OT1 will be conducted in this lecture hall at the Convention Center. Oral talk 2 OT2 will be conducted at SCNS Committee Room. All guest, faculty members, participants and students are requested to return to the lecture hall by 5 p.m. for the valedictory session.
यहाँ पे तो आप ही हैं ना, हाँ बस मैं वहाँ पे क्या देख लेता हूँ उधर सेंटर में, आपको सेंटर देखना में मिलेगा.
So now we
जिनका
begin.
पोस्टर प्रेजेंटेशन है, ओरल प्रेजेंटेशन है, वो नैनो साइंस में चले जाएंगे बच्चे जिनका लिस्ट में नाम है. और एक बार बता भी दो.
Oral talk OT1 will be conducted here, so all the participants are requested to stay back here. Oral 2 OT2 will be conducted in special center for nanoscience. All the participants are requested to proceed to SCNS.
Ma'am, for poster presentation?
पोस्टर
For
के
poster
लिए आप वहीं पे
presentations.
नैनो साइंस जाइए. ये कुछ वॉलंटियर्स जो यहाँ पे हैं वो लेके आप लेके चले जाइए 2 बजे ना.
MTech volunteers are requested to take the poster presentation participants to SCNS. In OT1, oral presentation number 1 to oral presentation 11 will be here. OT2 will consist of OP12 to OP20. This session here will be chaired by Professor Satyendra Singh, Dr. Balaji Birajdar and Dr. Tulika Prasad. We now hand over this session to the chairperson.
So now we are starting our oral presentation. First presenter is OP1, and then Dr. Arindam Pramanik will be presenting his work. So sir, you have only, for each presenter will have only 5 minutes for the presentation, and maybe will take 1 or 2 questions within 2 minutes, so that total time will be for 7 minutes only. So please try to manage this time. Thank you, sir. You can start your presentation.
Good afternoon, everyone. Myself, Dr. Arindam. So I'll skip the introduction and move to the next slide. Yes. So we know that in the last 15 to 20 years, a lot of research has been done on nanoparticles in the context of nanomedicine or drug delivery. But there has been only a small fraction of it which has actually crossed the clinical barrier or the practice in the clinics. And as we know that there is a clear winner in this context, that is the liposomal formulation. So we know that there are a lot of liposomal formulations which have actually approved by FDA and European medical associations. Some of them are written here. So what I am doing, or my team is doing, is we are working on a third generation of a liposomal formulation which we call the cubosomes. So these cubosomes are basically made of lipids, but they have a slightly distinct structure. That is, they are cubic in structure, they are 3-dimensional, and they have something like pores like here. So they have a backbone of liposomes, but they are in a 3D structure, and this helps them to give a lot of stability, a lot of encapsulation efficiency, and there are so many advantages which are written here. So I'll just quickly try to cover this up. So now coming to the treatment in cancer, so there is a big challenge if we talk about treatment in cancers, that is the chemotherapy. So the biggest challenge in chemotherapy is toxicity, right? So there are a lot of drugs which can kill cancer cells, but at the same time they also kill normal cells. And in order to avoid this, what we can do, we can target these drugs. And one of the targeting best option is to use antibodies. But the problem with antibodies again is it is very expensive and not affordable by the common man. So we have come up with a protein molecule which is a recombinant protein. It behaves very similar to the antibody, that is, it binds to specific receptors, and this is a protein which can be produced in the bacterial cell. So this protein is basically produced using fast display library, and through that we can identify specific sites. So there are some sites in these proteins which are similar to the antibody. They are variable regions, and they can be changed, and depending on the variable region, it can bind to specific receptors. So this protein, which is called the aphemer proteins. So the aphemer proteins are not just one protein, they are a class of proteins, and different aphemers can bind to different receptors. Okay. So the receptor which I am talking about here is the carcinoembryonic antigen, which is overexpressed in various cancer cells. Okay. So we have produced this protein which can bind to the CEA, which is the carcinoembryonic antigen, and then we have used the cubosome nanoparticles which I was talking about. So we have functionalized the cubosome nanoparticles with this CEA binding aphemer. So we have the cubosome, and then we have the aphemer proteins on the top of the outer surface. And inside we can encapsulate any kind of drug or any kind of imaging agent, right? So these are the cubosome nanoparticles which have been taken. I took the pictures of this using TEM and cryo-TEM.
So as you can see they are clearly cubic structures, and they have these pores inside them where the drugs or any molecule can go inside. And these cubosomes can be encapsulated by various kind of molecules, drugs or any imaging agents. So then we took, I was working on colorectal cancer, so we took colon cancer cell line, the LS1740, which basically expresses the CEA receptor, but normal cells do not. So this LS1740 cell line was used as a model cell line in my work. So what we did, we studied the cubosome, we loaded some fluorescent dye, and we saw that after tagging the ephemeral protein on the cubosome, it can specifically target the colon cancer or this particular cell line. But when there is no ephemer present, there will be no uptake of the cubosome. And then when we encapsulated drug, we found that only after targeting it is killing the cells, but if it is not targeted, the ephemer is not present on the cubosome, then there will be no toxicity in the cells. And this was further verified using the non-cancer cells, which is the HEC-293 cells. So then we further tested this on spheroid models, because we know that the tumor 3D spheroids actually mimic the real tumors precisely compared to the monolayer culture. Then after testing this drug in the in vitro system, we wanted to move to the in vivo system, right? So what we did, we took xenograph, we developed xenograph model in nude mice. So we took the LS1740 and injected into the nude mice and developed the tumors. And we found that the tumor, after targeting with the ephemeral protein, the cubosome got specifically uptaken by the tumor cells, but not in the other organs. For example, lungs, kidney, spleen, and other, all various organs. And the uptake of cubosome in the tumor after the targeted delivery was maximum, right? So this was further validated by confocal microscopy. Then we encapsulated the drug. So first, initially we first verified whether the cubosome is going to the tumor or not. Once it is validated, we then encapsulated drug, and we found that after drug encapsulation and targeted delivery, there is significant reduction in the tumor volume, as you can see. So normally people measure the tumor using caliper, but we use the USG imaging, which gives more precise three-dimensional tumor volume. So as you can see in the control mice, there was a big size of tumor present, but after ephemer targeted delivery, the tumor size has significantly got reduced. So these are the same graphs. So, and we found that there was maximum uptake of the drug in the tumor after ephemer targeted delivery. And there was no sign of toxicity, whereas in the tumor tissue, after targeted delivery, there was maximum amount of tumor tissue death, that is through necrosis, or you can see if apoptosis also. So, but in case of non-targeted or control mice, there was significantly no death, obviously. So if the drug is not reaching there, it will not kill it. So there was no sign of toxicity in the rest of the organs, and so we took kidney, liver, heart, lung, brain, spleen. We studied after and with and without targeting, where to see if the cubosome can cause any toxicity or not. But there was no sign of toxicity, so it is completely non-toxic. And so this paper was published. If you are interested, you can go through the paper. And right now, my group is working on several aspects. So. Of course, we are working on different kind of cancer for drug delivery application. For example, colon cancer, breast cancer, and recently we have started working on glioblastomas as well. So, and we are also working on anti-cancer peptides, which are the peptides which have been extracted from various bee venoms. So these peptides have cell-killing properties, and we are trying to modify the peptides to specifically target the cancer cells. So these can be used as a cytotoxin to kill the cancer cells. And we are also using the drug delivery application for cardiovascular diseases, for example, cardiac hypertrophy, using siRNA as a therapeutic molecule, and also some small molecular inhibitors. And recently I have also started working on rare genetic diseases such as amyotrophic lateral sclerosis. Using siRNA delivery, we are trying to see if that can be reversed. So these are some of the themes which my research group is currently working at. So if you are interested, please get in touch with me. I'm open for any kind of collaborations. So that's all for my talk. So thank you so much. If you have any questions, you can ask.
Thank you, Dr. Arvind, for a very nice talk. And we can have one quick question.
Hello.
Yes, I can hear you.
So, sir, you have mentioned about ephemerals. They are specific against some kind of an antigen, like you told about CEA. So they are same like efficiency they have like aptamers also.
So aptamers are basically nucleic acid made. These aptamers are protein made. So you can develop different kind of aptamers. So for example, in this work, I have used carcinoembryonic antigen, right? You can develop for HER2 receptor, which is again expressed in breast cancer. You can use for EGFR. So different aptamers can be made using like the fast display library. And each aptamer will be specific for one particular antigen or receptor, which is expressed in cancer cells or any other cell receptor which can be used for any other kind of diseases. So these can be changed, altered. So I hope.
Thank you, Dr. Arindam. So we are falling short of time, so we move on to the next speaker. Thank you.
Thank you so much.
So we move on to the next speaker, Dr. Devolina Brahmani. Your time will be 5 minutes and 2 minutes for discussion.
A very good afternoon, one and all. It's indeed a privilege to be a part of the one-day symposium. So, I'm Dr. Devolina Brahmani, working in the area of environmental chemistry and toxicology. And today I'm here to present a bit of my research and some bit of the insights that I've gained. So this particular topic on assessing the toxicity of the micro and nanopollutants on zooplankton is a part of environmental toxicology on alternate models to be used in toxicology research as a part of the 3R program. So by micro and nanopollutants, we know that we have several kinds of micro and nanopollutants which are there in water, but I particularly work in the area of micro and nanoplastic pollution, as it is one of the most pertinent one and a class of the emerging pollutants. So microplastics or the nanoplastics, they are any kind of the microparticles less than 5 millimeter or less than 100 nanometer in size, which are developed as a result of shredding or weathering of the macroplastic particles, and they could invade us or they could get inside our body through different routes, through food, beverage, or even inhalation, and could lead to several kinds of diseases including cancer. So this is a very upcoming branch of research which we are now focusing on. Now what's the role of zooplankton? So zooplankton is exactly a phytoplanktonic species which are heterotrophs, but now the zooplanktons can be used as an alternate organism in the research of toxicology, because the most important point is they are the key organisms in the food chain. So we can get a lot of insights on bioaccumulation and biomagnification as well. So through the zooplanktons, the next species goes to the fishes, and from the fishes it goes to the humans. So it's like the upper part of the food chain. So these are some of the points which you can go through. So I'll keep it very brief. So the two major zooplanktons from the marine category, we have Artemia salina, which is the organism on which I work on, and the freshwater organism, which is an alternate, it's a Daphnia magna. For the Artemia, it's the genus Artemia. We have the other species as well, and the same is for the Daphnia magna. So as you can see from this particular image, how distinct and precise are the morphological features of these particular organisms. So we have the organism of zebrafish also, but that is a vertebrate model for which we also require an ethical clearance in the Western countries. But for the invertebrate models, they are, because of their size and precise features, we can also involve them for the HTS or the high throughput screening approach. So just a brief on this particular part. So what we have done is we have studied the toxicology of the microplastics on the Artemia salina in terms of different kinds of assays, the biochemical assays, the enzymatic assays, the swimming competency changes, the mortality, to name a few. So this could be an interesting image where we see how the microplastics are localizing in the organism, which is Artemia salina. So we have used two kinds of images. One is the bright field microscopy image, and one is the fluorescence microscopy under the DAPI filter. So the microplastics used here is PET, which is polyethylene terephthalate, which is a result of the plastic bottles we use for drinking purposes. So it is a very logical work that we have so many bottles which are disposed every day. So from there we are getting a lot of microplastics, and how these microplastics accumulate in these organisms which otherwise serve as the feed for the fishes, and then it goes into the humans via consumption. So that justifies this particular work. The fecal matter of this particular organism, it showed that due to the filter feeding activity of these organisms, the microplastics are later converted to the nanoplastics.
So if the organism is consuming a 100 micrometer plastic particle, it is very capable of transforming that by filter feeding activity into a 10 nanometer a nanoplastic material. So that's how it is. So now this is the gut region of the Artemia salina, which we have seen. So basically we wanted to see what kind of damage this type of plastic materials could do to the gut wall of that particular organism, and this we compared our results to an H&E, another result which is already published, where the researchers have performed an H&E staining to show the damage done to the gut walls. We also studied the oxidative stress and wanted to study how and where the fluorescence accumulates in that particular organism, whether it is the thoracopods or whether it is the head part or whether it is the tail part. So as we can see that over a period of time, 0th hour, 20th, 24th hour and the 48th hour, and with an increasing dosage of the microplastics, that in the 0th hour we have no accumulation of the fluorescence. But as we are going with the increasing order of time, the increase in fluorescence is noted, and the fluorescence accumulation we particularly see at the 100 milligram per liter exposure of microplastics, particularly in the ovisac region of this particular organism. So that's how the precise toxicology assessment we got. This is just an image to show we have the Artemia and we have how the microplastic, if it's in the fibrous form, it's going to just twine around and it's going to kill the organism. Another one is the image, which is a wide field deconvolution microscopic images, where we see the changes in the hatching percentage. So with microplastics, we see nil hatching, and without the microplastics, we see more of the other developmental phases. So this is another parameter we evaluate while we do the toxicological assessment. The same is here. So the oval shaped structures are the umbrella phases, and the round shaped structures are the decapsulated Artemia cysts, or the eggs, in other words. So if I play the video, you can just see how the swimming competency of this particular organism is affected in the presence of the microplastic. Swimming competency is one of the most important toxicological parameter which we study on the zooplanktons. Even we study in the zebrafish fries also. Another important work is for the Daphnia magna. This is another research paper where the microplastic accumulation and the nanoplastic accumulation is seen in terms of the ingestion and egestion. So the fluorescent particles, once ingested, they exactly localize inside the Daphnia. The only reason to show this particular work is how we see that how precisely this particular organism they function to show the exact precise localization of this particular nano or the micropollutants. And we have the other biochemical assays also the similar for the Artemia. To summarize the work, Artemia or Daphnia or any other zooplankton of that matter could serve as an alternate organism for toxicological assessment studies. So I'm open for questions, and right now I'm looking for collaborators who want to do the toxicological studies on these organisms or use these organisms for the high throughput screening approach method. Thank you.
So the session is open for questions.
So ma'am, we have published this particular research on Artemia salina.
And on Daphnia, you have just from the literature, no?
Yes, we are currently working on Daphnia. This is the research work of the citation we have provided.
Okay, so you have given the different dose of microplastic to this? Okay.
Yes, ma'am.
Okay.
Okay, ma'am. Thank you. It was an excellent talk. And now we call upon the OP4, OP3 apparently is missing. So the Kundan Kumar, he is going to talk about reading between the lines through artificial intelligence, data at nanoscale.
Good afternoon, everyone. My topic is reading between the lines through AI. In this, I have explored how nanoscale can be measured in digital data or virtual realm in the context of AI. historically we have known the truth through two modes. First is faith and second reason. Reason gave birth to scientific temperament and which finally gave birth to the science which we know today. But now we have new mode, AI, through which we can know about truth. And we all are aware that this year Nobel Prize in Physics and Chemistry went to the person who have used AI. This is the conceptual representation of how AI learn from the data and look through the real world. So you can see that AI is surrounded by the data. He through the data analyze the real realm. In this picture, we can see that in the real realm, scientists with the use of powerful microscope look through the nanoscale, but AlphaFold and AI look through that scale through the data. That's why AlphaFold being able to predict the fold structure of protein just by looking through the DNA structure. It means that even AlphaFold is able to look at that scale through the data. Then the question arises, what we humans can know from data and what AI can know from data, and also how to define or measure any scale at nanoscale in virtual realm. So the convergence of nanotechnology and AI also create one more problem, that how to verify truth, especially in those contexts where we can't verify the truth through experiment. Like if AI discovers some facts related to extinct species, then how we can verify the truth, because that aspect doesn't exist. Similarly, if AI software is used in social sciences and other fields, then how we can verify the truth? One also may be a problem, because we know AI is giving the output, but even the best researchers are unable to predict, are unable to understand how they are giving the result. They are acting as black box. So I am suggesting some possible solution that may help to measure the nanoscale in virtual realm. One is that see the right figure. You can see that this is a neural structure which is used by AI in AI programs. You see there are many hidden layers, and it is just it is developed on the basis of human mind. Human mind have billions of neurons which have trillions of connections. Things becomes complex. That how we reach at any conclusion. So one way that we can measure is by the layers. That how AI goes through how many layers before giving any output. And but it is not possible, because once the number of nodes increases, then system become very complex and we can't say how it is giving output. But then 2 days ago, Google has announced that it has developed the quantum chip below, which is even faster than supercomputer. So we humans can't know about that, but we may develop an AI which can then monitor other AI which is output and may find the number of layers. It is in this term there is possibility that we may define nanoscale in the virtual realm. So as the emergence of virtual realm increases, and we know there is development of metaverse where billions are invested to even simulate the physical forces like gravitation and other things in and now everything first will take place in virtual realm, every invention or discovery, and then it will those things will be applied in real realm. So as the convergence of real and virtual realm increases, this question becomes profound and we need to be explored. Thank you.
Thank you very much for keeping in time. So, any question? Can you tell why you use the term AlphaFold talk? What is its relevance? Can you explain to the audience?
Yes, because AlphaFold is looking through the DNA structure of protein, and it is and then it is predicting the how it folds. Because you know, human body, 70% of human body is made of protein, but what that protein will do depend on how it folds. So AlphaFold is by looking at that structure, that DNA structure is predicting, and it has experimental level accuracy. Means AI is looking at data scale, nanoscale.
Okay, thank you for this excellent talk. So
next speaker for this session is Suhani Chadda, who will speak on ancient Bharat's nanotechnology parallels with modern advances. Suhani Chadda. And you have 5 minutes and 2 minutes for discussion.
Hello everyone, a very good afternoon. My name is Suhani Chadda. I am from Sri Aurobindo College. I'm a first year student and I'm in my first semester. I may not have that much knowledge and information as the ones that spoke before me, but I'm here to share my inputs and what I understand about this topic. Okay. Okay, so what do we understand by nanotech? Nanotech deals with creating, designing, and everything at a very small particle that we like to call commonly nanoscale. To just give you a gist how small a nanometer is, we can compare a human hair, which is 80,000 to a lakh times a nanometer. So it's that small. Okay, so how did the idea of nanotech emerge? The man behind the vision was Richard Feynman. It was around 1959 that he spoke in his famous lecture. There's plenty of room at the bottom that we should deal with everything, manipulating atoms at a very small scale. But it was around his time that there was not enough technology to go ahead with the idea. And it was around the 1980s when the scientists developed scanning tunneling microscopes that the scientists could finally bring his idea to life. Modern day, in the 1990s, with nanotech advanced so much that we came up with cool stuff like nanoparticles and carbon nanotubes. So we're still building upon that. Okay, so ancient Bharat may not have coined the term nanotech or nanocell or anything nano-related, but they were far ahead of their time. Harappa civilization, they were pioneers in using copper, bronze, and gold for crafting tools and much, much more. And they built the idea that we use in India. Gupta period saw the metallurgy, the famous artifact we all might know, which is the iron pillar in Delhi. It has been standing around 1500 years without having a single bit of a rust on it. That's the power of nanotech. Okay, so ancient with modern metallurgical processes. Like I said, we're still building upon that, but the idea was given by Harappas and Guptas. They used basic furnaces and clay crucibles for smelting metals. This involved heating ores and using charcoal as a fuel source. Modern day, we're using electric arc furnaces, induction furnaces to precise temperature and everything that we can do. Okay, so wood steel, what exactly it is? Wood steel is an ancient form of steel that was built in India around 300 BCE, and it was known for its strength and durability. A very famous wood steel artifact is Wood's Qatar tiger knife that was used by the Sikhs. And it was known for its durability, resistivity, and everything. Okay, now let's talk a little bit more about Iron Pillar of Delhi, like I mentioned before. It's a remarkable example of corrosion resistance. It has been standing for 1500 years and it's a cool thing to talk about. And yeah, okay, so how does everything connect to modern day electronics? Today we are trying to make everything smaller and faster and more efficient. So that is very much possible with nanoscale. Okay. So, like the artifacts I mentioned to you, they are everything that we need about durability and corrosion. Today, we're using nano materials in electronics by making everything smaller and resistant and everything, which is also making it sustainable and has an organized mind. So it's a win-win. Okay. So the conclusion, the knowledge from ancient Bharat continues to guide innovations in electronics and nanotech, proving its timeless relevance. Jai Hind. This is the salute.
Okay. So thank you very much. It was quite good. Then the next speaker is Shriya. Any questions? If you have, we have some time. So
I can try to answer questions.
yeah. I think you anyway explained very well, so they have understood everything you told. Then the next is Shriya Mudgal. She is going to talk of integrating Indian Bharat roofing with nanotechnology for sustainability. So you have 5 minutes and 2 minutes for discussion.
Greetings, ladies and gentlemen. Today, I, Shriya Mudgal, a student at IKS Greater Noida, currently in the 11th grade, will be presenting this to you. I heard about this seminar through my mom, so I was really interested. So I'm keen on presenting this to you today. Okay. So basically, I'll be discussing the potential of integrating ancient Bharat's construction and architecture with nanotechnology for sustainable development. Okay, like the peers before me have mentioned what nanotechnology is, so I'll jump into the problem that I'm trying to discuss today. India's construction fuels climate issues with heat trapping designs, urban heat, and rising emissions. Making this problem worse is the rapid urbanization, weak regulation, and limited use of eco-friendly designs. But not to worry, this problem can be tackled with nanotechnology and maybe some ancient wisdom of our ancestors. So let's discuss what nanotechnology is, but now I'll focus more on the applications. Maybe in medicine, the tiny drug carriers targeting specific cells like cancer without harming the healthy tissues, or in electronics, so we can have faster, smaller, and more efficient devices. Maybe in the environment, where we have filters for cleaner water and air, or materials that break down pollutants. Energy can be more efficient through solar panels, batteries that long laster, and charge faster. But today, we will be talking about nanotech's role in quite literally the building blocks of our society: bricks, roofs, and construction. Okay, so fired bricks of the Indus Valley civilization. The fired bricks of the Indus Valley civilization were composed of silica, alumina, and iron oxide, and were subjected to high temperatures, finding approximately at 1000 degrees Celsius. The process induced vitrification, produced dense microstructures with nanoscale porosity. This structure enhanced the mechanical strength, reduced water absorption, and provided superior thermal insulation. The significance: these bricks had the compressive strength and durability to far exceed the sun-dried mud bricks, and enabling the construction of long-lasting structures. The rock-cut architecture of the Ajanta caves. The Ajanta caves showcase nanoscale polishing techniques applied to granite surfaces. The polishing reduced surface roughness, minimized friction, and enhanced the aesthetic appeal. The rock was shaped using advanced tools followed by abrasion with progressively finer materials to achieve a polished finish. The significance: this method demonstrates the application of controlled material removal with the precise geometric shaping and the structural integrity with the implications of modern stone finishing techniques. The Great Bath of Mohenjo-daro. Waterproofing the Great Bath involved nanoscale applications of bitumen, providing impermeable barriers. Heated bitumen was clayed together with enhancing the adhesion and resistance to the water infiltration. This technique integrated effectively with the drainage systems for the efficient water management, and it prevented leakage and erosion, offering insights into sustainable waterproofing with modern hydrological engineering. Lime mortar in the ancient temples. Lime mortar was formulated using calcium hydroxide, which chemically transformed into calcium carbonate, though carbonation. This reaction formed nanoscale crystals, improving the adhesive strength and its flexibility. The mortar exhibited low thermal conductivity and high resistance to cracking. The significance: chemical properties of lime mortar provide a framework to modern eco-friendly binders and sustainable construction. terracotta roof tiles composed of clay materials were fired at high temperatures to create porous structures. The microconstructor facilitated heat regulation through air pockets, enhancing the thermal insulation properties. Bamboo construction techniques. Bamboo cellular structure, primarily cellulose, provides high strength to weight ratio. The hollow fiber reinforces the design, optimizes tensile strength, and after harvesting, bamboo underwent is to inhibit biodegradation, and jointing techniques leverage its natural flexibility. The significance, it still remains high performance, renewable resource, which we can have modern applications in lightweight and sustainable construction systems. Even the jalis and the lattice screens we see were fabricated with micro-scale precision from wood or stone. The designs allowed for controlled light diffusion, enhanced ventilation, and thermal comfort. Tools of the time facilitated intricate carvings with functional aerodynamic properties. Stepwells utilize hydraulic engineering principle to optimize water management, constructed from stone or brick. These stepped architectures improve the accessibility and the sustainability during the season. And like iron pillar of Delhi that was mentioned before, even that used phosphorus-rich nanoscale surfaces that imparted exceptional corrosion resistance. Forged using high temperature furnaces, the iron pillar surface treatment is inhibited oxidation. The Great Stupa of Sanchi was constructed using layered of sandstone with nanoscale bonding at contact surfaces. The stones were shaped and aligned using gravity-based stacking, enhancing the load distribution and the stability. Moving on. Now, we can integrate ancient Bharat structures with modern nanotech. Okay. So, I'll just summarize with this. How we can collaborate both the ideas to improve the technology. For example, nano coatings and durability. We can use titanium dioxide, silver nanoparticles to improve the longevity and reduce the maintenance. Or maybe we can use nanostructured concrete like silica nanoparticles and cellulose nanocrystals, which can reduce porosity and similar to ancient structure and aggregate methods. It has multiple sustainable benefits as well, like listed here: resource efficiency, improved durability and longevity, because of all of the features it provides us, and also energy efficiency, because now maybe you have to use less of the ACs, less of the fans, because you have thermal insulating roofs and houses. Thank you.
Thank you very much. So, if you have questions, please go ahead. Okay, so thank you for the nice talk.
Next speaker for today is this session is Tanmay Mukherjee, and Tanmay is going to speak on biotechnology in Bharat, a historical evolution from ancient wisdom to modern innovation. The time allotted is 5 minutes and 2 minutes for discussion.
So, good afternoon everyone. My name is Tanmay Mukherjee and I am a first year undergrad student from Sri Aurobindo College. So I'm going to speak today about biotechnology in Bharat, a historical evolution from ancient wisdom to modern innovation. Coming to the introduction, we can see that biotechnology is a wide field combining biology, technology and innovations that develops the processes and products for the benefit of humanity. Do you know when the term biotechnology was coined? In 1919, agricultural engineer Carl Ericke foresaw that biology can be used for making useful products. So that was the time when he coined the term biotechnology, combining the terms biology and technology. Foreseeing the first use of biotechnology in our past, we can go back to 10,000 years when our ancestors first time started keeping plants as a reliable source of food. Ancient biotechnology was fully relied on natural biological processes, rather relying on advanced genetic tools. Natural processes because they had to fulfill the needs of the society for agriculture, food production and medicine. So that time the key areas for biotechnology were Ayurveda and medicinal plants, fermentation, agricultural tools and techniques, and food preservation. So we know that modern biotechnology is very much inspired from our ancient biotechnology, knowingly or unknowingly. Now that the drug discovery and vaccines are totally inspired from Charak Samhita, whereas when we go to plastic surgery and prosthetics, it is inspired from Sushruta Samhita, which is nowadays used in modern plastic surgery and skin regeneration. Ancient use of sustainable materials inspires modern bio-based and biodegradable materials. Modern biotechnological practices is inspired from ancient rainwater systems. Coming to Ayurveda and Rasayana is basically a part of Ayurveda only. Ayurveda is a plant-based text where we can see various cures and treatments in a valuable resource for modern phytochemical research. For example, there is a plant called Brahmi, scientifically called Bacopa moneri, used in Ayurveda for improving the cognitive function. It is also good for increasing the memory and brain functioning. And the Rasayana's role, why I have especially mentioned over here, is because its role is in maintaining the strong immune system and also aligns with the biotechnological innovations of vaccines and immunotherapies that focus on boosting and enhancing the immune responses. When it comes to surgical techniques and prosthetics, while not strictly biotechnology, ancient texts such as Sushruta Samhita describe the advanced surgical techniques and even the creation of prosthetics. These examples show that while ancient Indians or ancient people were not knowing the term biotechnology, but they were far more ahead in terms we are now. Genetics and DNA, when we go to the ancient times, so genetics was not understood in that era, but they used to practice it in selective breeding based on the observation of inherited traits. When we come to modern biotechnology includes genetic engineering, CRISPR gene editing and genomics. Is built upon the foundational idea of inheritable traits. So in conclusion to this, I would like to say that still we are trying to reach that extent that our ancestors were. Thank you.
Okay, so questions if any, we have some time. Okay, so thank you for the nice talk.
Thank you.
And we call upon the next speaker. He is Sujata Shekhar, and she is going to talk on green synthesis of silver nanoparticles from citrulose colosynthesis, a blend of traditional knowledge and modern nanotechnology. So you have 5 minutes and 2 minutes for the discussion.
Good afternoon to one and all present here. So I am going to talk on the topic green synthesis of silver nanoparticles from citrulose colosynthesis, a blend of traditional knowledge and modern nanotechnology. So this plant, citrulose colosynthesis, is a well-known plant in Indian water system, and its medicinal importance is clearly mentioned in all samhitas of Ayurveda. And this plant, citrulose colosynthesis, is used by tribal communities for the cure and treatment of various diseases like asthma, diabetes, and many more. So this plant is commonly known as colosynthis in English, while colosynth in English, and also it is also known as bitter apple, while in Hindi it is commonly known as Indrayam. It belongs to the family of cucurbits, and it is widely distributed in the Arabian and Sahara desert and southern parts of the Asia. In India, this broad-bearing plant species is usually dispersed among all hot, arid areas, including Uttar Pradesh and Rajasthan. As I already mentioned, that this plant is commonly used by the traditional medicinal framework, and it is easily propagated by vegetative and generative modes of reproduction during the summer season. So, the food part of this plant possesses various pharmacological properties, like it is used to, like it possesses antimicrobial properties. It is used to cure the blood sugar level. It is used to control the obesity. It is used to control the lungs problems and many more. So, why we people are switching and more prone towards switching toward the green synthesis? So, as we all know that in this 21st century, the main problem is to reduce, is to fix the waste. So, the green synthesis, as we all are aware that the green synthesis is a process which doesn't need any toxic byproduct, and it is eco-friendly in nature. It doesn't harm our environment. And in biosynthesis of silver nanoparticle is a single step process in which we have to just add the precursor, which is isolate of the plant through photosynthesis, and the silver nitrate solution of desired molar concentration. So there is no need of adding any extra reducing and capping agents in it for the stabilization of silver nanoparticles. So as we all know that plant extracts are eco-friendly, they possess various antimicrobial properties, and they are biocompatible in nature. That's why they are more opted for the synthesis of silver nanoparticles. And as we all know that silver is possesses various medicinal properties. Silver is considerably possesses various antimicrobial properties, and it has high electrical and thermal conductivity. It is non-toxic in nature. So I just keep it very brief. So I selected the seed part from the plant, from the fruit part of the photosynthesis. Actually, the seeds are embedded inside the flesh of the fruit, and we prepare the extract from the powder of the plant, from the seed extract, and just precursor and the connected solution of desired molar concentration, which is 1 millimolar, and just mix both the solution and leave it for and incubate it for a time duration. So after the completion of incubation period, the prepared solution was gone through characterization techniques. So firstly, the solution was through UV visible spectroscopy. So the UV visible spectra clearly showed a prominent peak nearly around 400 nanometers, and which correspond to surface plasmon resonance. And the synthesis was confirmed after various optimization methods like pH, its temperature, its the concentration of the plant extract, and the silver nitrate solution. Further solution was going through XRD spectral analysis, and from the XRD spectral analysis, it is clearly observed that the three strong peaks were observed, which correspond to the breast section peaks of 111, 220, and 200, and 222, and which correspond to the face-centered cubic crystal of silver. After the XRD analysis, the solution was further gone through FTIR analysis. So as we all know that the FTIR detected the functional group which might be responsible for the reducing and capping agent for the synthesis and stabilization of silver nanoparticles. So in this FTIR spectral analysis, clearly observed the four different peaks in the infrared region, and which indicated that there are various functional group lies present in the solution. So the major peaks of aromatic CH stretch and C double bond H stretch and various OH and NH stretch are present, and they present of this functional group shows the might be responsible for the reducing and capping agent for the synthesis of silver nanoparticles. Further, the TEM micrograph study reveals the shape of the biosynthesized silver nanoparticle, which was around 16.6 nanometer, and the range was around 8 to 18 nanometer. So, further prepared silver nanoparticle was further gone through antifungal efficacy. So, in the in vitro study for testing the antifungal potential of biosynthesized silver nanoparticle from the seed extract of Citrulus colocynthis shows that as we increase the concentration of silver nanoparticle against actually we tested the antifungal efficacy against the fusarium built pathogen, which is Fusarium dicopersicline. So as we clearly observed from this graph that when we increase the dose of the AGNPs, the inhibition percentage gets increased. So as we can observe from it, at 100 ppm concentration, the inhibition percentage was observed around nearly 92%, which is quite good. So I concluded that the green synthesis of silver nanoparticle and all the characterization techniques confirm the formation of silver nanoparticles and from the seed extract of Citrulus colocynthis. And the in vitro study revealed that mycelial growth inhibition were observed in a dose-dependent manner, and which was observed maximum at the 100 ppm concentration. And the study underscored the potential of integrating traditional medicinal knowledge with modern nanotechnology to develop sustainable agriculture solutions. Thank you.
Okay, thank you. So we have some time, questions if any. Yes.
You have shown the synthesis, like a green synthesis, and you have specially written you don't need any reducing agent to convert silver nitrate into silver.
Yes.
So do you know which reagent in your plant you have, so that it is converting silver 2 plus, nitrate is silver 2 plus to converting to silver 0?
Actually, in the seed extract of Citrus colosynthesis, actually the plant is already rich in various secondary metabolites. So various studies have shown that during the GCMS studies, there are various phytochemicals are reported which might be responsible. We can say that which might be responsible for the reduction and capping for the AGNP.
It might be.
Yeah, it might be. It might.
So what is the size of the nanomaterial that is used?
Then the range is around 8 to 18 nanometers, and the size is 16.6 nanometers. The major size we will observe in this 16.6 nanometers. Yeah, ma'am, can. Yeah. Yeah, ma'am, I think can. This one, the D1, ma'am. Yeah, ma'am. Actually, the range is around 8 to 18, but median and ENCs are of 16.6 nanometer of size. Actually, the uses AMU. They provided the whole report in which they clearly mentioned the average size, the size range, specific size. So from that data.
In XRD also you have refined your data because XRD having so much roughness. How
Yeah,
you can
no.
say that 42 peak is silver or rough?
We have to figure it out according to
very strict.
we have to.
Or either you have not done a proper washing of your after green synthesis. So maybe because of that you are getting so much noise.
Okay. Yeah, you are right. Any more questions?
No, thank you.
The session is Muhammad Aslam. The title of the talk is Graphene Oxide for the Detection of Antimony. The time is 5 minutes.
Good evening, everyone. Myself, Muhammad Aslam, and I am a PhD scholar at SRM IST, Delhi NCR campus. So we are talking today about traditional to modern nanotechnology. So I have taken one of the traditional compounds, like carbon-based compounds, to use in modern world. So my work is on graphene oxide for the detection of antimony using different techniques like electrochemical studies, DFT calculations, and experiment technique also. So earlier in ancient time, carbon-based material were heavily used, but they were not many terms for them. They were just using them without realizing whether they are using nano materials or not. Like from the morning, we are listening that nano materials, carbon-based materials have been used in different places. Like soot, it was used in paintings, walls, and writing sculptures. There were use of nano materials. Even in the morning, there was a lecture we were listening that people were using them on the talwars and all that, those things. And even in our homes, we were our mother used kajal. हमारी माम सबको लगाती थी बचपन में. So what is kajal? Kajal is a mixture of graphene, CNT, and other carbon-based material. So what does it do? It also absorbs our impurities from our eyes. Mom used to say na that. Our mom used to say na that it will clean our eyes. So. So I have taken one of these materials like graphene oxide for this. So modern terms to these materials have been given like CNT, graphene oxide, graphene, reduced graphene oxide, carbon quantum dots, and we all know that they have different kind of properties, different kind of strengths. So what graphene oxide has, I have taken graphene oxide. Why? Because it is hydrophilic in nature and it has high surface area, which allows for more adsorption sites, and it is highly function stable. So this is my methodology. I have taken graphic plate, synthesized graphene oxide, and then detected antimony. Detection of antimony using different techniques. These are my characterizations. First, we did the IR spectra. of graphene oxide and after the absorption of various concentration of antimony salt. We found that the peaks of the FTIR were really sharp in graphene oxide, but after the absorption there was dampening of the peaks. Similar observation was seen in XRD. We have in XRD we seen that graphene oxide has a very sharp peak at 10.09, but after the absorption of antimony, it was observed that there was shift in this peak and also the peak was broadening. So we can say that there was no new peak for antimony, but in the graphene oxide there was some modification because of the absorption of antimony on that. We did a SAM and also the ADS spectra for that. Next we did the electrochemical sensing using cyclic voltammetry, TEFL and EIS. So during the cyclic voltammetry we find that there was an oxidative peak here at 0.4 minus 0.4 volt, and we did the study at different concentration that what will be the limit of graphene oxide to test the limit of the graphene oxide. Later on we did the study for at different scan rate. What the scan rate does is that it moves potential very high speed. So we found that there was increasing peak on increasing the scan rate. This shows that our process that was occurring, it was diffusion controlled process. Next we did a linear plot for that, and then we did a TEFL. What does TEFL does? TEFL tests about the electrokinetics of that process. We see that we've seen that there was this was for the blank process when we have taken water, and these peaks were all for the present when the antimony solution was present. We have seen that the peak was shifting towards a lower potential. That means in the presence of antimony there was lower potential was required to equilibrate the reaction. Later on we did the reproducibility study. What does in this we have taken 4 different electrodes and repeated the same process 4 different, that we are showing that our process is reproducible again and again with different electrodes. After that we did the interferon ion studies. In this we have taken a mixture of 2 salts with our antimony salt and we found the current response for that. We found that when cadmium was present with antimony, the current was higher than the only when antimony was present. After that we found out the limit of detection using cyclic voltammetry only. We found that the limit of detection was 3.36 into 10 to the minus 6 molar. That was really good and really low because the WHO has set a drinking limit of antimony at 20 milligram per liter. So we found that our instrument can detect the antimony at very low concentration, and the LOQ was 1.12 minus 5. Later on we did the DFT calculations for antimony using Gaussian software. We first optimized the graphene oxide sheet. It was a 3x3 graphene oxide sheet with 3 COH groups and 3 OH groups. We changed the number of atoms, and we found that as more and more interaction, that is very favorable interactions are possible with graphene oxide for antimony. Then we did non-covalent interactions. Again, the same thing was observed that it is forming a very high number of non-covalent interactions with graphene oxide. Using Material Studio, we did analyze that how many maximum number of antimony atoms can bind to that 3x3 geosheet. We found that 12 number of antimony atoms were binding to the geosheet. So this was my conclusion that graphene oxide can be used as a sensing material for different metal ions, and also for different we are further exploring it for detecting further pesticides and other toxic materials also. I would like to thank my supervisors and Professor Pichan Singh for their these are my bibliographies. Thank you.
Okay, so thank you. Is there any question?
So,
Thank you. So the
sir, it's okay.
She has a question.
you have a question? Yeah, you can go
It's
ahead.
okay.
बोलिए.
Okay, so you started very well by saying that this carbon nanoparticle actually contains a lot of many allotropes of carbon. So whatever the kajal or means you were asking about talking about that,
So did you try to see the FTIR or some absorption spectra of these kind of suits, black suits?
No, ma'am, we have taken only FTIR for graphene oxide.
For only graphene oxide?
Yeah. Ma'am, if we are in process, we will be further in future, we are storing magazines and also CNT we will.
I think you can just collect that some suit of that carbon coating, mix it in with some solvent and just analyze it in the absorbance or something.
Thank you. I will really look.
Yeah, then you will find out what all carbon allotropes are there. It is a simple thing to do.
Yeah. And it will be really good. Thank you.
Yes.
Okay, thank you. So now we go over to the next speaker.
Speaker for this session is Sandeep Yadav, who will talk on a multifaceted approach to investigate interactions of thiaflutamide with hemoglobin.
Hello, good evening to all. Thank you, ma'am. Okay, I'll try to. So, good evening, myself, Sandeep Yadav, and I'll be presenting my work, a multifaceted approach to investigate interactions of thiaflutamide with hemoglobin. So, we all know that the use of pesticide has been increasing gradually over a period of time. So, this is a report by FAO, in which it was reported in 2022 that there was an increase in usage of pesticide by 4% in 1 year, and was doubled since 1990. So, and specifically for herbicides and fungicides, there was an increase in more than 100% for herbicides and more than 50% for fungicides. And so pesticides, we all know that it has harmful effects, multiple harmful effects. So it is used for specific pests, but it will also affect the non-targeted organisms, and humans come into that category. It will also degrade the quality of the soil. It will have chronic and acute poisoning effects, obviously. So why do we need to see the interactions of these pesticides with the protein? Because it will provide several routes how the pesticide is interacting with the protein. It can give information about developing a better pesticide with a better structure, which will provide alternatives to the traditional pesticides. So in my study, initially we did the in silico study, in which molecular docking was done, and the molecule of the pesticide, this thiaflutamide, was docked into the hemoglobin PDB, which was 2D-N1. The PDB ID was 2D-N1. So it was docked into it, and it was found that there were several interactions with the pesticide. Majorly were the hydrophobic interactions. The ones in the pink shade are the hydrophobic interactions. And this one with histidine, it showed hydrogen bonding, histidine and valine. So the study was done with the two softwares, Autodoc, and the visualization was done with Discovery Studio. And after that docking, MD simulations were done, and it was found that the thiaflutamide was forming stable complex with the protein structure which was used. These are the RMSD trajectories, and it was found that after 150 nanosecond, the complex structure stabilized. And in the RMSF trajectories, it was found that specific regions which were interacting with the pesticides showed higher fluctuation, which can be interpreted as the increased flexibility of the protein, which is usually seen when the protein is opening up and accommodating the incoming ligand or the incoming molecule. And these are the hydrogen bond trajectories which was observed, and we can see that these are correlating with the molecular docking results, that majorly one hydrogen bond is there for the period of like 250 nanosecond, and a triplicate study of this was done to see the validity of this thing and the repeatability of the study. And the secondary structural analysis of the computational study was done from the Stride web server, and it was observed that over a period of 250 nanosecond, there was a reduction in alpha helix structure of the protein. It reduced from 80% to 72%. And these in silico studies were validated with experimental studies. So first, CD spectroscopy was done, and it was found that on gradual addition of thioplasmide to the hemoglobin solution, there was a decrease in alpha helix structure from 23% to 82%. And thermal CD spectroscopy was also done, and we can see that in 222 nanometer this thing range, there was a reduction in TM, or the melting point of this thing, protein structure, which can be attributed as the destability of the alpha helix structure, or the alpha helix secondary structure of the protein. And later on, electrochemical analysis was also done for the interactions of thioplasmide and hemoglobin. Initially, the characterization of thioplasmide was done, and in which we can see that majorly reduction of thioplasmide was happening in the solution, and a peak at minus 1.48 volt was observed, which was confirmed with Tafel plot, and where we can see that there is a lower cathodic slope is there for thioplasmide, so which indicates that the reduction reactions are happening at a better rate as compared to the oxidation reaction, or we can say that the oxidation reactions are sluggish in the solution. And later, a time-based study with the hemoglobin solution was done, what we did, in a solution of thioplasmide, solution of hemoglobin was added, and gradual cyclic voltagrams were taken at a period of time, like from 0 to 2 hours, 0 minutes to 2 hours, and it was observed that there was a gradual reduction in the peaks of thioplasmide. That means the thioplasmide was not, we were not able to detect thioplasmide in the reaction after a specific period of time. Yeah. Before each reading, the electrodes were washed to remove any possibilities of depositing of any protein protein molecules, or the reduced pesticide molecules. So before every reading, the electrodes were washed. So we can see that there was reduction in the presence of thioplasmide in the solution. So where did it go? Obviously, it was absorbed, or it interacted with the hemoglobin, which was present in the solution. So, in conclusion, we can say that with the in silico study, we confirmed that the pesticides is interacting with the hemoglobin structure, and which is changing the basic structure of hemoglobin. This was confirmed by the experimental studies later on. So, obviously, we know that there are adverse effects of pesticides, and it is marketed that thioplasmide is a low toxic pesticide, but actually it can interact with a lot of other proteins in the human body, right? So this is one of the protein I took. Yeah. I would like to acknowledge Dr. Prashant Singh and Dr. Pallavi Jain, my supervisors, and I would also like to acknowledge SRM Institute and ARSD Institute for providing me the infrastructure to conduct my research. Thank you.
So, thank you. Is there any question? Yeah.
So you have done both computational and the experimental setup.
Yeah.
So sir, the result which you got during your computational, that gave the same result during your experimental setup?
We can't say exactly same, but the direction was same. From the computational studies, we saw that there is a change in the secondary structure of hemoglobin, obviously. And it was confirmed from the CD spectroscopy that the structure of the hemoglobin is changing in the presence of thioplasmide. And there was binding between the pesticide and the hemoglobin. Obviously, the results can't be exactly the same because the conditions are different. As in the initial talk, my supervisor, he said there are limitations to it. Obviously, I didn't take the whole hemoglobin structure. I took a part of it because there is a limitation to my machine, obviously. So the direction was important. So that is the way we are transitioning from the traditional methods to computational methods which are less time consuming and which are cheaper. Like without going to the bench, we are moving towards that thing.
Okay, thank you. So the next talk is by Archana. Okay. Exploring the electrochemical detection of paracrysyl sulfate using reduced graphene oxide molecularly imprinted polymer. So Archana, you know 5 minutes plus 2 minutes, okay?
So good evening everyone. Myself Archana, I am a PhD scholar at Special Center for Nanoscience, and this is one of my PhD work under the supervision of Dr. Pratima Solanki. And this is titled as Exploring the Electrochemical Detection of Paracrysyl Sulfate Using Reduced Graphene Oxide Molecularly Imprinted Polymer. So here we can see there's a very interesting pictorial showing a globe carrying a piece of kidney and it is all sweating out. This actually depicts the global burden of CKD which is currently happening. So what is the role of PCS in chronic kidney disease as well as in cardiovascular disease? So this is a schematic which shows when the renal damage initiates, it accumulates toxins including PCS. So I will be referring my metabolite as PCS. And it initiates vascular calcification and atherosclerosis, which ultimately leads to heart damage. So according to the report published in Lancet, 7% of all cardiovascular deaths are attributable to CKD actually. Now there are many risk factors of CVD. Some are the traditional risk factors like diabetes, hypertension, tobacco usage, and some are the non-traditional risk factors which includes accumulation of uremic toxins, for example PCS. So this is the biosynthesis of PCS, and PCS has been labeled as gut microbiota derived metabolite as well as protein-bound uremic toxins or uremic toxins. So here we see it begins from the dietary food which we consume. It changes to oligopeptides, amino acids, later on to aromatic amino acids, then to picresol and then picresyl sulfate. So you can see here ABCD, these are the enzymes involved in the transition from the food to picresyl sulfate. So why we have chosen PCS and how we will be detecting it, that's the next approach. So this is the synthesis and preparation of the receptor, the chemical receptor which we have made in this work, that's called as PMAA, that is polymethyl acrylic acid, reduced graphene oxide, molecularly imprinted polymer on screen printed carbon electrodes for PCS detection. So we have chosen a Hammers method to first make geo powder from graphite flakes, and next we have used hydrothermal method to make RGO from geo powder. Next is the approach to make the MIP. In this we have used two phases. The first is the organic phase consisting of the monomer and the cross-linker. The monomer is methyl acrylic acid and the cross-linker is TEOS, that is tetraethyl orthosilicate. Next we have our inorganic phase which consists of the catalyst like HCl. And then we have a final solution which solidifies and later forms PMMA, RGO plus the analyte which is PCS. Later what we do is that we subject this powder to sonication as well as centrifugation to remove the analyte, and ultimately we get the powder which is labeled as PMAA, RGO, MIP. Here we have we can see that this powder is further drop casted on the 3 system electrode consisting of working electrode, reference electrode and the counter electrode. And when the PCS is reintroduced in this matrix, it gets detected and electrochemical response is generated in the presence of electrolyte. In this we have used ferrocyanide and the electrochemical response was recorded using cyclic voltammetry. So how this MIP works? So first we are having this PMAA added RGO and IP. This is called as non-imprinted polymer, but there is no imprint of the analyte PCS. Next PCS get added in the polymer and now we called it as polymer plus PCS. Next we can see that sonication and centrifugation is subjected to it and the analyte get removed and we get the specific cavity of the PCS in the polymer matrix. Now we have to ensure that these the bond formation between the monomer or the polymer and the analyte should be a non-covalent bond because it is easy to break down rather than a covalent bond formation. So we have characterized our material using different techniques. First we have performed XRD for GEO and then for RGO, and we have also performed Raman spectrum for both GEO and RGO. We have also performed TEM to see the thin sheet-like structure of RGO. Here we have performed SEM also. In this we can see flake-like structure for the RGO. Now this is a very interesting picture showing the difference between NIP and MIP. So you can see here is a very smoother texture in like box C. But in box D we can see there is a very rough kind of structure. This rough structure is there because MIP has been subjected to sonication, which has provided this rough texture. Next we have the FTR spectroscopy. This is the most important technique to actually understand if MIP is formed or not. So I'll just skip these two graphs. I'll just go to the third one. Here we can see this is PMMA, RGO, NIP, and then when the annulate is added, new peaks are introduced, which is shown in this red dot box. And when these annulate are removed, we are again getting back the same peak which was available here in graph C. So this is for NIP and this is for MIP. Now this is electrochemical sensing, which we have performed using the MIP which we have synthesized. So here something like this happens when the annulate is available and the cavity towards that annulate is available in the polymer. So what is the difference which we get because of the presence of RGO and without RGO? So in this case, so without RGO we are getting a linear range from 50 to 2100, but when we are doing the same experiment with RGO, then we are getting a broader linear range, that is 10 to 2100 nanogram per ml. This is the control study which we have performed using NIP. In this, there are no cavities present in the polymer matrix. So when the annulate comes and interacts with it, there will be no interaction between the annulate and the polymer matrix. And here we can see the graph is completely overlapping and we have got minimum change in the current. And here we have taken a concentration from 300 to 1500 nanogram per ml. So this is the control study which shows that there is no cross reactivity between the polymer and the annulate. Next we have the interference study. In this interference study we use different molecules along with our interest of molecule which can be possibly present in a human body fluid. So in our case we have used other annulates such as TMAO, PC, 4-EPS, KCl, magnesium nitrate, uric acid and urea. So here also I have shown different shapes along with my annulate. So when all of them comes together, this happens, and only the annulate which is specific for our polymer, they will interact and the rest will not interact. So this is the interference study. And this is the RSD, that is relative standard deviation study for spiked urine sample. In this we can see that the graph heights are almost matching when we are talking about specific concentrations 10, 50, 100 till 1700 nanogram per ml. This shows that when we are doing the reaction, then we are using the reaction in like when we are getting a standard curve, and when we are doing it with the spiked sample, we are almost getting same kind of a current. And this is the comparison of our data with the LCMS which we have performed, and in this we can see that the recovery rate is almost very nearby, but the sample volume which was used in LCMS was 2000 microliter, which is up to 2 ml, but in our case we used just 5 microliters. And this is the end of my presentation, and I want to acknowledge all the funding agencies, DBT, DHR and ARGNU, and this work was like in this month, this year we have published this work in ACS Applied Polymer Material almost under the same time. Thank you.
Thank you. So the presentation is open for discussion.
Just a basic question. You have a solid sample.
The next speaker for this session, the last speaker for this session is Dr. Pooja Rawat. Your time is 5 minutes.
Okay, good evening everyone. I am Dr. Pooja from Amity University, Haryana. My topic of presentation is cuprous oxide, bismuth oxide, nanocomposite with the guar gum and its adsorption properties with the Congo red dye. So this general content, I will not include this one. Okay, our lab is working on a guar gum and recently we have published a copper ferrite and silver nanocomposite with the guar gum and the photocatalytic degradation of this composite. But currently we are working on the guar gum hydrogels and its composite with the cuprous oxide and the bismuth oxide. As we know, bismuth oxide is a UV visible photocatalyst. So we try to reduce, we just try to optimize the band gap using a cuprous oxide. As you can see, cuprous oxide having a band gap around 1.81 and bismuth oxide having a band gap around 3 to 4. So we just try to tune the band gap so that we can get it around the 2.8 or 2.6 and then we make a composite with our guar gum. And we are trying to do the studies of adsorption properties using a Congo red dye. Basically, the use of hydrogel, why we are using a hydrogel, as we know that hydrogels are generally a polysaccharide cross-linker. Here we are using a guar gum, which is a natural polysaccharide cross-linker, and it's easily available, biodegradable. So basic, these are the advantages of a guar gum with a composite. In the synthesis part, we have synthesized cuprous oxide and the bismuth oxide, general precipitation methods. For composite, we tried both the precipitation methods and the hydrothermal methods. Here I have shown only the hydrothermal method because when we compare the XRD data, hydrothermal giving the best result as compared to precipitation. So we followed the hydrothermal method, making a composite. Once we have prepared the composite, we move forward towards the composite of our cuprous oxide and bismuth oxide with a guar gum. You can see the guar gum is a cross-linked polymer, and once we have put our composite, we are getting a composite hydrogel. This is a general, after synthesizing a composite, we went for the characterization studies just to check whether we are having a composite or it's just a separate one. So going towards the A part, it's a bismuth oxide. Okay. This one is a bismuth oxide, and as we know, bismuth oxide exists in the 5 polymorphic pores. So this one is a alpha bismuth oxide phase, which is a monoclinic in nature. Cuprous oxide is cubic in nature. Then we have a composite contains both the peaks of bismuth oxide and cuprous oxide, and the last one is our guar gum composite with the cuprous oxide and the bismuth oxide, which is showing that broad hump is for the polymer, and you can see a very minute peak of our composite. The FTIR, if you want to check whether your composite within the polymer matrix, you can check by the FTIR, as this whole is related to your polymer, and the last part, the nanocomposite, the metal oxide generally gives the peak around 400 to 800, and we can see in our guar gum we are not getting that peak, but in composite we are getting a peak around 475 region. So this is basically for the metal oxide. Next, these are the band gaps of tuning. So bismuth oxide is around 2.8 or 3. Cuprous oxide is 1.8, and we just try to tune it between that. Before going to the polymer, before going to the adsorption studies, we first try the swelling study, that how much our polymer is able to absorb. So for that we have performed the swelling studies using just a water. So here we have performed the swelling studies for the 2 days with a regular interval of 12 hours, 24 hours and 48 hours, and we have seen around 650% of the water is absorbed by our hydrogel, and then we have performed the adsorption properties. So currently we are working on this point, the adsorption properties. Here we have tried the adsorbent doses, pH, amount of catalyst, and the amount of dye. So we have seen these are the adsorbent dose. This is the initial dye concentration which we have taken from 20 to 60 mg per liter. And this is the contact time, how much we have taken. So you can see here the basically main result is this one. Within a 2 minutes it is absorbing 74%. When we will go more than that, then 5 minutes it's a 76, and after that is not that much big. So we have taken that 5 minutes is approximately the best time, and with this time we have tried to change the pH, we have tried to change the concentration. All these experiments are going on, and after that we are going for the adsorption studies, or mainly the fitting curves, that Langmuir, Friendlich, Skips, this all that. So generally we are working on this point. So this is the last thing. And the conclusion, we have synthesized the cuprous oxide, bismuth oxide composite with the guar gum. We have characterized it. It is showing that the polymer composites are forming from the XRD and the IR result. Band gap is also tuned with the composites like with the cuprous oxide and bismuth oxide. Generally, we are doing the combo red dye degradation, but we are going for the try other cationic and anionic dyes both. Thank you.
Thank you very much. So the talk is open for discussion. If there are any questions.
So, interesting talk. Where you have calculated that band gap.
Yeah.
Top plots. उसमें जो आपका third वाला curve है, how did you choose which area to extrapolate for calculating the band gap?
Yeah, actually, when we are calculating the band gap, we used to draw a tangent, which is.
Can you go to that graph? So it will be more clear. So yeah, after this, so see there are like two kind of things, and it is this extrapolation is also not very
Yeah,
clear.
right. Yeah, this extrapolation is not the right one, and that's for that we will repeat this experiment for the band gap calculation, because if it is a composite, it shows the two band gap for both the cuprous oxide, for the bismuth oxide, but when we calculate it, it's not giving the good result, so we are trying to repeat this experiment.
I think it is better not to show such
right.
kind of graph,
Yeah,
because
right.
it is a bad data.
Yeah,
Okay.
right. Right.
Okay.
Okay, thank you, thank you.
Thank you.
We welcome everyone back. We have now come to the end of oral talks and poster presentations. We hope that the oral and poster presentations have inspired fresh ideas and perspectives. As we commence the valedictory session, may we invite Dr. Vinod Kumar to address us and announce the winners of the oral and poster presentations. All the winners are requested to come up on the stage as their name are called, so that we can take a group photograph. I would now like to request Chairperson Professor Vijay Kumar Kaur to give us brief address about our Special Center for Nanoscience.
Okay, so we are really thankful to all the speakers and all the attendees that we successfully finished this one-day talk of the IKC. Is this IKC? IKS. So the Indian traditional knowledge system. Okay. Anyway. So out of this we heard many of the talks, but only the thing which is important is that nanoscience as a nanoscience or nanotechnology as a subject is so much interesting that anyone can fit in to this area of science. So there is no boundary between the engineering or science or computation. Anything is possible in nanoscience. Yeah, it can be a field of physics or chemistry or biology or anything, but everyone can contribute towards the nanoscience. So we heard many talks relating to even a bio computation. We heard talks towards biophysics, and many multidisciplinary and interdisciplinary subjects are all spoken here. And many, you must gather some knowledge at least in this one day very quick fire, and what he named as something like what is that session he called as rapid talk. So it is kind of a rapid, so whole day, and is kind of a rapid and finish like a rapid thing. So so we are in the end of this rapid session, and now coming to the nanoscience. I'm not so old in this nanoscience or JNU thing. I joined in 2013 only, so it is just 10 or 11 years here. So we have started this department when I joined here. We are 4 people in nanoscience at the beginning, and then Dr. Tulika joined us, and then after that we are now 10 people. So 10 faculty members and 2 professors now in our center, and then I think 3 associate professors and 4 or 5 assistant professors. So all are doing very good work. Like for example, Dr. Pratima, she received the presidential best presidential researcher of the year 2019. So everyone is doing good, and we also have a good amount of funds from Government of India as a PI based funds. Not even we didn't get any institute based or the department based, like DST PERS, not the DST PERS but DST FIST. We applied that, maybe we will get something this year. But as a center, we have many patents also. We are publishing in a good number of papers. And thanks to, again, Pratibha, she is publishing like anything. A lot of publications of her. And we are just trying to catch up to her. So she is the best. And also, similarly, many patents we have. And funding also, we are having good funding. So the thing is that we are now, almost we are established now in this nanoscience, though we are not a school yet, but we came closer to any of the good school of JNU now in a 10 years of time. So what I can suggest is that if you need any help from nanoscience, as doing some experiments or collaborating with someone or taking some help or taking some advice from us, you are very much welcome to come and talk to us or email us or contact us, and you can take our help if you need so, or collaborate with us, or publish or patentize any ideas of yours. Thank you very much, and I wish you all the best for those in the early career of the teaching, or the students. They can have a good future and go ahead with the nanoscience. I hope we all are from nanoscience, or if not, you are doing nanoscience anyway. Okay, thank you very much.
Good evening to all. So before announcing the name of poster or oral awards, we have to finish the vote of thanks, and it is a very important part. So on the behalf of Nanoscience, IKS-NANO 2024, we sincerely thanks Nanoscience, SBT and GKB Haridwar. And before that, we sincerely thanks our Honorable Vice Chancellor, Professor Santi Sri Dulipuri Pandit, and Chancellor, Gurukul Kandri University, Dr. Satyapal Singh. And I also thankful to the JNU administration for the support that made this event possible. And I am also thankful to our sponsor, CT Instrument. And Springer Nature is going to finance some award, but we have not received any email, so we are waiting for that only. Ah. So in this thing, we also collaborate with the Chemistry Select Wiley Publishing House, who are going to start a special collection, and that we will inform you after 10 to 15 days through email. So don't worry. Meanwhile, you prepare your research article or review article. I also sincere thanks to distinguished invited speakers whose visionary presentations have illuminated our path. And we have listened how we can utilize our Indian knowledge system to the modern scenario. And we have to proud of our ancient literature, and before we have to read any of the ancient literature. It's very easy कि इसमें तो कुछ नहीं होता, ये ऐसे फालतू के हैं. ये मैंने सुना है कई बच्चों से. ये वही बोल सकते हैं जिन्होंने नहीं पढ़ा. अभी हमने जितने भी लिटरेचर देखे, जितने भी साइंटिस्ट हैं, they followed some of the Indian literature, whether it is Oppenheimer, उन्होंने गीता पढ़ी थी 1940s और 30s के अराउंड. ये मैं नहीं बोला, ऑनलाइन सब है, उनके लेक्चर भी ऑनलाइन प्रेजेंट है. तो जब उन्होंने एटम बम का विस्फोट किया था, देयर आल्सो ही रिसाइट्स फ्रॉम ऑफ द गीता श्लोक फ्रॉम चैप्टर 11 कि शास्त्र विद्वत से, वो हम साइंस के तो हैं, संस्कृत के नहीं है, कि जो हजारों सूरज के जो प्रकाश होती है उससे जो रोशनी निकलती है, ऐसी हमें रोशनी नजर आ रही है. फिर जब यूएसए ने बम्बार्ड कर दिया हिरोशिमा पे, और जहाँ पे लाखों जो इनोसेंट सिटीजन थे, दे डाइड. तो एट द टाइम ही इज सेइंग कि फ्रॉम सेम गीता श्लोक चैप्टर 11 कि आई एम ए डिस्ट्रॉयर आल्सो, कि मैं जन्म देता हूँ पर मैं डिस्ट्रॉयर भी हूँ. तो वहाँ पे उन्होंने सब कृष्ण जी पे थोप दिया कि भाई आपकी वजह से मरे सब. तो जब हमारे इतने जो एमिनेंट साइंटिस्ट हैं, दे रेड आवर एंशिएंट लिटरेचर, वैसे हिजनबर्ग एंड सो मैनी, तो वाई वी कांट. तो इस फर्स्ट हमें जरूर उसे जरूर ध्यान दें हमारे. तो जो भी वट एवर वी हैव डन ड्यूरिंग दिस फर्स्ट ईयर, फर्स्ट सेशन, थर्ड एंड फोर्थ, प्लीज यूटिलाइज दोज थिंग्स इन योर रिसर्च और थ्रू योर इन योर डे टू डे लाइफ. I extend my profound gratitude to the stage, travel, food, technical committees and excellent catering. क्योंकि फूड बहुत अच्छा था. हो सकता है लंच ये टी नहीं मिल पाया, क्योंकि दूसरे जो सेमिनार वाले थे उन्होंने खा लिया हमसे पहले. हाँ, तो I apologize for that. And I also thanks the faculty members of our center, SBT, SPS and other places who continually supports us throughout the event, whether offline or online. So I am going to name some faculty members कि जिन्होंने हमें support किया. Professor Ravi Verma, SBT, Professor Vijay Goyal, SPS, Dr. Uma Naran from NSUT, Professor Priyanka Jhanjaria from Kyorimal College, Dr. Sanjay Kumar from SPS, Dr. Virendra Kumar from SBT, Dr. Aminder Kaur from DTU, Dr. Poonam from DTU, DTU Delhi Technical University, Dr. Kartike, Patent Officer, Dr. Deepika from Himachal Pradesh University, Dr. Deepak Gupta from DTU, Professor Neha Sharma, Professor Sunny, Dr. Prasant, and there are so many other faculties. And last, I would like to thank some of the volunteers. Without them, we can't have this type of program. तो उनका नाम तो लेना जरूरी है, अदरवाइज तो नेक्स्ट प्रोग्राम में करवा पाएंगे हम। तो और फिर भी हो सकता है कुछ नाम रह जाए, तो सॉरी। प्रशांत कुमार, शुभम चौधरी, मोनिका, शिखा ज्योति बोरा, रूपल पाल, त्रिप्रेश शंकर द्विवेदी, रविंदर कुमार, पुष्पेंद्र, शोभित सैनी, ऋषि राम, करमवीर, अभिमन्यु, मनीषा डबला, संस्कृति, अरविंद माधव, विमल, इतिका, अंकित, दानिश, फरीन, डॉक्टर प्रीति एंड मैनी मोर। तो ये हमारे वॉलंटियर लिस्ट थी। कल भी सब यहाँ से 2 बजे गए और 7 बजे आ गए, और ये पिछले 3 दिन से कंटिन्यूसली चल रहा था। और एब्स्ट्रैक्ट बुक वी विल सेंड यू टिल ट्यूसडे, क्योंकि हमारे पास लास्ट में भी आया कि प्लीज़ एक्सेप्ट अवर एब्स्ट्रैक्ट, तो वो इतना इजी नहीं है कि हम सब कुछ कर पाएँ। तो बाय द एंड ऑफ ट्यूसडे you will receive your abstract book through email. So now we have several sessions. So in from faculties, the best oral presentation goes to Arindam Parmanik. We will send you the certificate through email. आप प्लीज खड़े हो जाए, जिसका नाम ले खड़े हो जाए। I don't know the name of university, तो sorry for that. नहीं, sorry बोल रहे हैं, हमें नाम नहीं पता। हाँ, क्योंकि हमें जो लिस्ट मिली हमने फटाफट लिख लिया।
Sir, MIT University.
हाँ, from MIT University. Dr. Tripti from Gragi College, second prize. Dr. Pooja Rawat from Amity, Haryana. Now, oral taught for students, so we have a huge list, 6 to 7, because some of them are present here, some of them are there. तो वहाँ पे 1, 2, 3 नहीं पॉसिबल, तो हमने कुछ नाम है वो हमें उन्हें अवार्ड दे देंगे। हाँ, फर्स्ट के हिसाब से है, फर्स्ट है इक्वल कर देते हैं सबको। हाँ, क्योंकि बड़ा टफ है कि 1, 2 बताना। हाँ, अर्चना, संदीप कुमार, कुंदन कुमार, सरला यादव, मनीषा कावला, गुंजन वासने, मनोज, आयुषी प्रजापति, सब हैं यहाँ पे। अरे खड़े तो हो जाओ, दिखा। हाँ, आई रिक्वेस्ट सबने सुनिए भाई। हाँ, तो बेस्ट विशेष। नाउ OT3, ये हमारे पास 3 नाम है, फर्स्ट, सेकेंड एंड थर्ड। OT3 डॉक्टर विवेचना, डॉक्टर सिल्वी एंड मिस्टर मंदीप, फर्स्ट, सेकेंड एंड थर्ड। OT4 because we have several sessions. So if we have several systems, so in each session we have given 3 prizes, first, second and third. And if we receive the prizes from Springer Nature, so they offer some money to purchase their e-books. So we will share the awardees when we receive or not. Otherwise we will share only the certificates. Depends if they will share or not. We have written again कि please share. एंड स्टिल वी आर वेटिंग। मैं अभी भी मेल चेक कर रहा था कि शायद आ जाए, तो बोल भी दें कि क्या देंगे वो। हाँ, इन OT4 डॉक्टर नूतन, डॉक्टर सेंथिल नाथन एंड मेघराज विवेकानंद सूर्यवंशी। OT5 अमित सिंह, शाजिया हुसैन एंड मंजीता कुमारी। हाँ, पोस्टर ऑफलाइन सुचिता तोमर, फर्स्ट प्राइज। हाँ, देन भारती राणा एंड पूजा यादव। भी सर्टन नहीं होना, जिनको नहीं मिला दे आल्सो प्रेजेंटिंग वेरी वेल, बट हमारे पास भी ऑप्शन है कि 1, 2 या 3 देंगे, उसके अलावा ऑप्शन नहीं है ना। तो नेक्स्ट टाइम आएंगे तो उन्हें भी दे देंगे फिर अगली बार। एंड पोस्टर प्रेजेंटेशन ऑनलाइन दिव्या ठाकुर, अच्छा वो तो होंगे नहीं, आयशा, सेकंड प्राइज, थर्ड प्राइज गोज टू सरिता एंड श्यामला। तो 6 सेशन है ना हमारे पास, तो सब में 3-3 दे दिए ना हमने। टोटल, हाँ, टोटल हमारे पास मिला के मोर देन 100 प्रेजेंटेशन थी, ऑफलाइन एंड ऑनलाइन। So I sincerely thanks once again to all of you. Without you, this program is not feasible. So as our chairperson said, if you require any help from Special Center for Nanoscience, so you always welcome. 19 we have one-day seminar on advanced materials. एडवांस मटेरियल का हमारा नैनो सेंटर में एक प्रोग्राम है। हाँ, हम ग्रुप पे आपको शेयर कर देंगे और उसकी डिटेल यदि आप 1 मिनट बता दीजिए और एक ग्रुप फोटोग्राफ हो जाएगी। फर्स्ट जो अवार्डीज है वो आप आ जाइए, जिनके नाम लिखे हैं अवार्डीज के ग्रुप फोटोग्राफ हो जाएगी। उसके बाद
Good evening to all of you. So we are running one electrochemical society JNU chapter, and the society is belong to UK. So we are having 4 this event in a year. So that in the last event of this year, that will be on 19th December, and we have like published the Google link for the registration. So I think registration is over, but JNU students, they can join us on 19th, and other if they are interested to learn the speakers and some they are interested to for the poster, you please submit your names. Thank you.
And I request faculty members of different centers, please. Karthikeya sir, please. Conference का picture ला दो। फिर उसके बाद सबको बुला। हाँ। चौधरी। आप सब पार्टिसिपेंट प्लीज आप आ जाइए। अच्छा चलिए हम इधर आप लोग अपने जगह खड़े हो जाइए। बाहर चाहे तो आप साइड में जा सकते हैं।
मैंने खींची तो गुस्सा किया
इसको थोड़ा प्रेस किए रहे
ओके लॉन्ग प्रेस हो गया बट यहाँ से थोड़े कट हो रहे हैं
पीछे चले जाओ
अरे उसको लेस को ऐसे करिए ना
अब डन
वो लेस नहीं था
ओके वन मोर मैं छोटे क्लिक करवाती हूँ
भाई ये फोटो खींचेगा और एक बार देखा दीजिए बताते नहीं आया
लेंस एडजस्ट
वो लेंस को मैनेज करना पड़ता ना एक परेशान था कि भाई सगे खाना नहीं खाया मेरे क्या करूँगा मीटिंग है ना तो मैंने बताया कि हम बाद में देंगे सर्टिफिकेट उसमें फिर भी बता देना एक बार खाना उनको कर दो इसको अपने भाई सभी टीचर्स को बहुत बहुत धन्यवाद आप लोगों ने बहुत सपोर्ट किया हाँ और कॉन्फ्रेंस की पार्टी पंकज ठाकुर सर वो नहीं आए उन्होंने मजे किए हाँ हाँ